mobile AI can scan 100,000 lines of code in 2 minutes to spot and fix bugs. It can translate from code to code and is one step closer to speaking 1,000 languages, even whale. Today, AI impacts lives for the better and understands the world the way you do. Our AI spots threats 7 times faster, understands speech sentiment, helps prevent vision loss, predicts weather 10 days out in 2 minutes, translates thousands of pages in seconds, detects lead pipes to keep drinking water clean, eliminates paperwork so care is more human, generates from text, visuals, audio, and video, creates entire worlds from your imagination, creates this thing and that thing, a new thing, the new way to cloud.
Mathco began with a bold yet simple vision in 2016 to help enterprises unlock the full potential of their data and solve their most pressing challenges. We started as a small, passionate team of problem solvers, driven by the belief that data could empower businesses to think bigger and do better on their own.
Self-sufficiency remains at the core of our offerings to enterprises. We strongly believe that we live in an age of hyper-personalization. Enterprises, in the quest for being digitally at the top of their game, often face critical challenges. Challenges that can result in millions of dollars lost or missed opportunities to earn them. They're looking to evolve while overcoming their own unique set of challenges.
We today engage with more than 60 plus global enterprises across multiple verticals like retail, consumer goods, pharma, technology, and many more to come.
We're here to enable them to make smarter, faster decisions with enterprise intelligence. It's not just about solving problems, it's about building trust both with people and with tech and creating everlasting value.
Our strength doesn't just lie in numbers, it's in the unparalleled expertise of our mathematicians. Our people are the heartbeat of Mathco. They innovate, collaborate, and bring ideas to life in ways that drive real-world outcomes.
Every individual has a space to take ownership, make an impact, and shape not just their careers, but the success stories of our clients.
Everything we do revolves around creating meaningful experiences, whether it's through exceptional delivery for our clients or the way we collaborate and support one another as a team.
Each mathematician's goal aligned with a larger mission to empower decision makers in global enterprises to own and activate intelligence.
Our goal is to scale Mathco from where we are to 10 times our size. 10x in terms of the value that we add to our customers, the quality of experts we have on board, and the capabilities that we invest in. All in all, we want to be a one-stop shop for all our customers' digital transformation needs.
Synchron is a leading global consulting firm for digital transformation and technology enhancements. We specialize in the financial services and technology innovation sectors. We work hard to become the trusted innovation and transformation partner of choice to our clients. Synchron's progressive technologies and optimization strategies span end-to-end artificial intelligence, consulting, digital, cloud and DevOps, data, and software engineering, servicing an array of noteworthy, top-tier firms. Our coordinated, cross-regional teams have deep domain experience in high-tech, capital markets, investment banking, wealth management, retail and commercial banking, asset management, exchanges, insurance, and payments, as well as cutting-edge technologies. Our 14,000-plus global employees, spanning 55 offices across 20 countries, are passionate about innovation and meeting new challenges.
Our team at Synchron is committed to pushing the boundaries of AI technology and delivering state-of-the-art solutions. We understand the importance of staying ahead in today's fast-paced world, and Gen AI tools are designed to give you that competitive edge. The future is here, and Gen AI is leading the way. Embrace the power of generative AI with Synchron Nexus tools.
In a world clouded with complexity and ambiguity, there exist significant opportunities for disruption and growth. At Tiger Analytics, we help our clients navigate this uncertainty, empowering them to move decisively through shifting sands, unlocking these opportunities. We work with our clients to strategize, design, and engineer a future-ready enterprise. At Tiger Analytics, we've been reimagining possibilities with cutting-edge AI and analytics, solving some of the toughest problems out there and building the blueprint for tomorrow. And at the heart of this mission is our battle-tested team of exceptional technologists and consultants. It's our unique expertise and character that enable us to create exceptional value even in hazy conditions. That's our Tiger Gene. The Tiger Gene is what makes us learn relentlessly, experiment without fear, seek help and offer help. The Tiger Gene is what helps us uncomplicate complex problems, build for the future, deliver clarity amidst ambiguity. To our clients who are traversing a fog of uncertainty, we are not just a technology partner, we are a certainty partner, relentlessly seeking, solving, challenging, and growing. Together, as we set bold ambitions and target extraordinary outcomes, let us experience the power of data-guided decisions, the potential of connected insights, the promise of an AI-empowered future. Experience certainty to shape a better tomorrow with Tiger Analytics.
Even before the world could start talking about AI and Gen AI, for the last 15 years, we have invested in AI with the pioneers in AI. We have built some world-class solutions around AI.
Wipro has been at the cutting edge of data science and AI for a while now. Wipro and I get to work across various and diverse industries, everything from agriculture to pharmaceuticals to healthcare to oil and gas.
So we are helping many Mang-level customers in their transformation journey. So we have strategic consultants, we have domain experts, we have data scientists. So basically we do customer hand-holding right from the inception to post-deployment stage.
We have more than 400 plus use cases which are live. We embed AI into the end-to-end software development lifecycle, as well as we are working with our clients to infuse AI into the operations as well, the application management services, infra management services, by bringing in the generative AI to enable an end-to-end transformation, autonomous operations for our clients, predictive operations for our clients.
Our responsible AI is taken extremely seriously, and we have typically 4 dimensions that we talk about. One is the societal dimension, the individual dimension, environmental, and technical dimensions.
So there's a wide variety of work that we get exposed to in terms of AI and solving various kinds of industry challenges, and that's the part I love most about. And Wipro offers a tremendous great learning environment, a working environment for us to learn every day and experiment on various things.
The amount of flexibility this company offers in terms of the working location or the working hours, that is why I feel that I could not find a better company to start my career with.
Apart from work, I just wanted to talk about the facilities that we have. We have a great creche over here, and my daughter goes to that creche. At the end of the day, we get to spend time together with the strays, and we can spend some time with them and can feed them. I feel this is something which is really unique and great about Wipro, that we are able to share this message of love to our next generation with all these small things that we do, and I feel super proud about it.
So it is understanding their aspirations, understanding their capabilities which they may not be aware of, and that requires observation, that requires passion to help the person. And that's what Wipro is all about.
It's an exciting place for people to come work here, work in cutting edge technology or solve real life problems and really
Hello everyone. Thanks for coming to the third day of MLDS. Just a quick announcement. The first session has been cancelled because of personal emergency of the speaker. Like I would request all of you to go to hall 2. Yeah. So extremely sorry for the last minute update. So the next session will be starting at 11:15. Yeah. Uh, so I request the attendees to move to hall 2 because the first session has been cancelled because of a personal emergency of the speaker. I hope that's fine. Yeah. We'll be resuming the session at 11:15 onwards. Yeah. Check, check. So how many of you attended the hall 1 session at 10? All of you attended? So are you guys building SOTA models? Excited or at least thinking about building one? Like, no? Maybe. Devyanshi is fine. Why last minute? And then problem is record ಅದೊಂದೇ ಬ್ರೋ ಏನು ಅದೇನು ಇದಿಲ್ಲ. Check, check. While people are settled in, I would just break the ice here. So let's introduce each other and tell what you do and what are your plans for this year. Yeah, let's start with.
Thanks, Amit. Yeah, hey everyone, I'm Saket. I work for Cargill. Been in the ML space for quite some time now, and yeah, but that's the boring part, right? The fun part is I'm into movies. I watch a lot of movies, right? Like thrillers, Korean stuff. Um, yeah, that's so. Yeah, I wish to watch a lot of new movies this year. Yeah. Maybe get into gaming, right? That's what a good GPU is for too, not just ML.
Soon, I think I had met Jensen long back a year ago. So he was saying, I told him same thing. You started from gaming, then you went to AML. When are you getting back to gaming? He said it's a full circle, and soon everyone will become a gamer, right? So that's the whole cycle. So gaming, I think I wish you all the best. Keep playing all the games. Which is the latest game you're playing?
I have to yet find a new GPU. It's been so hard getting my hands on it. Yeah, it's all sold out to the ML AI companies. But yeah, let's see when they're back in stock.
I think gaming will get a lot of priority. I think in the next 2-3 years, it'll pick up. Yeah. So let's, yeah, why don't you introduce yourself and tell what you do and what are you excited about this year?
Hello. So I'm an independent consultant, and I work into natural language processing, and I'm actually from Delhi, but I've been in Bangalore last 3 years. Yeah. So no, not completely, but I stay in both places. Like so, Amit.
My name is Amit. So yeah. So this guy is zoned out. Okay. Hi, man. Could you quickly introduce yourself and tell what you do and what are you excited about this year?
I'm Navneet Amarnath. I'm from Inford. I'm a research engineer at Inford, and I mean, it's a very exciting year for AI. Started off with DeepSeek and everyone, so just excited to see what comes next and innovate together with the entire world.
What about you? Yeah.
Ditto. Yeah, I'm a colleague of Navneet here, and we work together and in a team. And I'm pretty much kind of getting validations of what we do, and all the people that come here and say that they're working on something. So that's happy. How well the agents perform every day and make our lives better.
So, quick question: how many of you think? How many of you are actually working with agents as we speak? Is anyone in the hall who's already working with agents? And I just want to know, like, how is it, or any department that agents are already taken over? No departments. Oh, it's happening in your company, like, where you have built something in particular where agent is already taking care of things, like an intern who have been hired, which is on its own right now, figuring out things? Anything? Yeah.
So we do have a product. It's called Annie, and it's basically like the way that you mentioned, right? We have a lot of tasks to perform. We can automate them. We just give them high level requirement, and it'll be able to go through the entire process and code if necessary, and take care of the entire process. So we are working on that.
Okay, just a quick question. How many of you have been using ChatGPT for a while? All of you almost? And DeepSeek? Any of you have started using DeepSeek? None, right? Okay, what is the concern here? Like any particular reason why we're not using DeepSeek?
Like all we know, it's already a distilled model of GPT, so we don't find much improvement in the performance. But sometimes it's better at maths. I have tried it out, but I'm already accustomed with this chat GPT, so sometimes when I need some maths issues, I will be using
And what are some interesting use case that you've been using ChatGPT for a while? If anyone would love to share their experience in terms of how maybe you got a date or you had to negotiate certain deal with your boss or brainstorming. So I want to hear some interesting stories around how you guys have been using ChatGPT for a while. Anyone has some interesting story like I've been hearing, I'm up for interesting stories. Like you got your appraisals sorted, or you got your, girlfriend sorted, gifting ideas. I'm sure like already people have been using it personally. So I would want to hear some interesting stories. Yeah, why don't you go? Yeah.
I think so. I have a friend who's getting engaged, and I think she asked me, "What do you think of this ring?" Because she's trying to get a ring. I said, "I think it looks nice, but why don't you ask Claude?" But now she's asking everything to Claude and not talking to me.
That's interesting. That's AI understands everyone. And what about you?
I don't have a personal or professional story like that, but I think the most interesting conversation that I had with ChatGPT was debating about how it imagined me. So I just asked me to like give a picture to me as to what it thinks I look like. And interestingly, I'm working as a data scientist. So it imagined me as a man and not a female. So I'm like, excuse me, how do you think, like, why do you think it has to be a man? So it's like, and it gave me like a proper reasoning that it's not my fault. It's because of the inherent biases that I'm trained on, but that's a good point. So I'll improve upon it. So it came out as like a very mature answer from its end, and it was being very diplomatic. So I think that was like the most fun conversation I've had till date.
So that any interesting conversation that you guys have been having with ChatGPT or your friends would have shared something very interesting and you would love to share here. Anyone? Oh, yeah.
Similar story, but the opposite. I asked ChatGPT to tell me about it, and I was shocked that it knew I'm in Bangalore. I read books. I love coffee and tea also, and it imagined me how I'll be sitting in a room if I'm in Bangalore right now. So I asked it to give me a illustration, and it did. The other use case I find really interesting for ChatGPT is when I read books, sometimes I ask it to summarize a book in a picture. It's a challenge, but it is able to do it in one picture.
Yeah, some of the use case, I'll tell my personal use case, right? So I kind of inventing new words. Like I don't know if somebody has come up with this new, so you can create your own words, which is not in the dictionary or it is not in the out there yet. So inventing new words also because I think it predict the next token, next word, right? So you can create new words. So let me experiment that with you guys. If you all were chat GPTs, you have individual experience and everything. Imagine I would have prompted this particular prompt. So I want you guys to think of the answer. What would be the next token or the next word would be? Are you guys ready? I want to hear like your neural nets, what they think, right? So let's start. If nobody is somebody, I repeat, if nobody is somebody, who's everybody?
Nobody.
Yeah, this is your name? Aditya. Okay, it's a wrong answer. Again, if nobody is somebody, who is everybody?
No idea.
So yeah, so the same prompt, I think, I mean, all of you guys are thinking, what is this? Again, I repeat, if nobody is somebody, who is everybody? Right? So I prompted ChatGPT and it gave me like, okay, if nobody is somebody, everybody is anybody. Right? So now I could have stopped at this and said, yeah, I mean, I would not acknowledge to this, and all of you in the room also would be like, what is this? This sounds like a very dumb uh, question. There's no sequence to it. It's some random, abstract kind of a thought process, right? So then I said, okay, if nobody is somebody, everybody is anybody, what is this emotion called? Right? So in English, there is like, for example, another example of how did I arrive at that particular word? There's no word for that. If you say that if everybody is somebody, anybody is nobody also, what is the emotion of all of this? I mean, how is ChatGPT supposed to answer that? So it would come up with some random creation, and it gave me a very good word. It's called Nobiverse. Now I've started using that in my conversations. So whenever I feel like I meet a person, this person feels like everything to me, but at the same time it feels like nobody, and all that mixed emotion, right? So you say this person is a Nobiverse, right? So that's a new word that you keep experimenting, and trust me, it kind of creating a new language for humanity as well in terms of explaining. I don't have to tell now the full thing. I can just say this is a Nobiverse, right? Similarly, like say for example, I think Sam Altman also, I think few weeks, 6 months back, he had put a thing like what is a word or an emotion for you're experiencing happiness. So yeah, you're feeling happy and also experiencing it at the same time you're living it. So that in dictionary is called euphoric, right? So these are some of the words, like it kind of helps for me personally as a writer, editor. This has been my use case. I'm sure all of you, while developing, you would be amazing at coding and all of that, and kind of writing shorter codes. So any interesting? So this is my story. But I would love to hear about all of your use cases, because I think things are changing really fast, how people are using it. And I'm meeting day by day all smart people in terms of how they are leveraging this and, making their lives better. So yeah, amazing. Any thought? Did I scare you guys by any chance? Everyone looks shocked, like. Yeah. Any experience with ChatGPT that you've been using? Nope. Okay. Any other interesting use case, guys? Please, I'm all ears. Anybody has any thoughts? Nobody's using, is it? For coding Claude, what are the challenges? Or have you guys been using Cursor? Anyone? Nope. Okay. GitHub Copilot, Copilot Studio. Nope. Oh, you've been only this guy has been using everything. They were like, nice. Yeah. Cool. So we'll be starting in another 10 minutes. I have you guys grabbed coffee or 10:15 got cancelled because the speaker had an emergency. So yeah. 11:15 is on. Yeah. exactly 11:10 ಗೆ I'll start. Crazy. You attended the hall 1? Hall 1 session? That was crazy, dude. Huh? It happened off. Huh? Paras choked up.
Artificial intelligence. AI. Coexisting.
AI.
AI.
Artificial intelligence.
Can you tell me what is there in my bag? Attendee, magazine stack. The February edition. All right. That's a notepad and a pen. Yeah, tell him to play the video. Baba. Check. Can we have the AIM promo video? Yeah, can we have the AM promo video play, please? Yeah.
Intelligence.
AI.
Coexisting.
AI.
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 Artificial intelligence.
A very warm welcome, everyone, and good morning. I request everyone to settle down. And before we start, I would request everyone to keep your phone on silent or aeroplane mode, if possible. Yeah. Uh, so once again, we are at the last day of MLDS 2025. Thank you so much for being here. This event would not be possible without all of your guys' energy and dedication to learning more things about AI ML. And thanks for that. Um, so we are in the 7th edition of MLDS 2025. So the energy has shifted from last year to now. There has been so much development, and I mean, I personally have learned a lot from almost like attending this for the last 3-4 edition. This edition feels a lot different, and finally it is happening, and I'm seeing a lot of use cases. And in this hall, we'll be talking about the paper presentation from a lot of companies and researchers. So I am Amit Rajanayak. I'm also known as AI Human. I'm the editor at AM Media House. Feel free to talk to me outside the hall. I would love to hear all of your banters and what do you think about the current state of AI and your frustration. I'm here to listen about all the stories because it kind of opens up the perspective in terms of what really is happening on the ground, right? So I'll be around in hall 3 and outside you'll find me there. So that aside, so are you guys ready to kickstart? Again, I said, are you guys ready? Louder. Louder. Oh my God, okay. Yeah.
A relentless curiosity to break limits. Technology was once a tool. Now it drives transformation. It amplifies ambition. It reshapes the world. Visionaries didn't just dream, They built. Systems didn't just evolve, they revolutionized. Progress became inevitable. And here we are, standing on the edge of something even greater. The next breakthrough, the next revolution. Welcome to MLDS 2025.
Welcome once again to MLDS 2025, guys. Thank you so much. I would ask you to, great round of applause for all of you for being here for the third day. And I see it's the same energy carrying forward. And I assume all of you are like really curious to know how to build all of this thing and take all the learnings back to your office boardrooms and brainstorm. Amazing stuff is happening right here, and glad to be part of your boardroom discussions and development that each one is sharing from different uh, industries and different companies out there, and this never happens, right? So most of you have attended like say companies like define conferences like AWS Summit or Microsoft. So AIM strives to bring all of them together so that there's like what is working, what is not working, and make sure that you have like a little leapfrog in terms of developing this and deploying much faster, right? So that's our goal, to bring all of the intellects in one room and drive some amazing things for the country and outside as well, for the world as well. Amazing. So without taking much of your time, let me give you a quick roundup in terms of what is happening. So we have a amazing event happening called Code Craze at 1 p.m. Near Hall 1. So all of you developers out there, you can go there and show your coding skills and win some exciting merchandise. That's part of our machine hack team, which does a lot of these hackathons and coding assessment for companies, right? Then we also have a lot of, there's a lot of booths out there. You can try it out and win some exciting merchandise as well. So before today, there's a very important announcement. So we have a very interesting gentleman at our conference today, and he's none other than Kumar Varun. How many of you are aware of this guy? All of you? Or majority of them. For those of you who are not aware who Kumar Varun is, he's a he's an Indian stand-up comedian, actor, writer, and quiz master. He's known for his roles in comedy sketches of AIB. I just laugh because I imagine one of the AIB episode of his whenever I talk about him. He's also the co-founder of comedy collective called Random Chikubum. I don't know what that is. Okay. He has also won OML Comedy Hunt. Very exciting guy. If you get a chance to talk to that person, I think you should enjoy this particular day and have fun. Get some nice, interesting banter, or go for it. Ask him about what he thinks about AI, or what his thoughts are. Right. So there'll be a stand-up at Hall 1 in the evening. Make sure you attend that and have some great time. Learning is one, but also it needs to be fun, and you should enjoy that, right? So we hope this day will be full of fun and learning alongside some amazing network. I personally got to network with a lot of people today in the last 3 days. So before we start the session, I would like to quickly thank our sponsors, and without them, I mean, this event would not have been possible. A big thank you to our title sponsor, that is Genpact and Mathco. They have been partnering with us for a very, very long time. I don't know, more than a decade now. And it feels really amazing to have these guys and learn more about them. And also our AI partner, Google Cloud. Again, they have been with us for a very, very long time. Then we have platinum sponsor, EY, and our gold sponsors, Cinecron and Vex. And then we have silver sponsor, Insight, Intel, and Tiger Analytics. Thank you once again, guys, for making this event a grand success. Yeah. So let's kick off today's session. So let me ask you this: how many of you have experienced this when shopping online, where you've suddenly shown a product recommendation which somehow the app knows that you would require it just during the checkout? How many of you have seen that? Zepto, Swiggy, or any other platform where you have seen that, right? It's very surprising. I sometimes wonder, like, how did this app know that I need that? Usually I would have just selected one item while exiting, but then it shows me that something, and I'm not even searched for it anywhere. And it knows that, okay, you will need this. And I just say, yeah, it's amazing how it can save time and do that. So in this session, we're going to talk about that. The speaker will introduce transformer-based next basket recommendation model, or in short, NBR model, leveraging a modified T5 architecture to analyze shopping patterns and suggest fresh, relevant choice. So leading this session is Pawan Chaurasia. He's the lead research data scientist at Dunnhumby, an expert in generative AI and machine learning for business transformation. So let's welcome Pawan, guys. Yeah, Pawan, the stage is all yours.
Good morning, everyone. Thank you for the introduction. So my name is Pawan Chaurasia. I'm a lead research data scientist at Dunnhumby, and along with me are my colleagues Abhinav and Aditya. And we are presenting our work that we call as Basket Transformer, which is a novel grocery recommendation with the T5 architecture. So in retail, we usually work with two types of problems. First is reward. Reward is where we want to recommend products to the customers that they have already bought before in the past, right? And in acquisition, we are recommending products that users have never bought before. And we call these recommendations as novel item recommendations, right? So as you can see, acquisition is a much difficult problem to crack compared to reward, mainly because of two reasons. First is in reward, we are recommending products that customer has already bought before, right? So we know what the affinity of that customer is with respect to that product or how they behave. But in case of acquisition, we recommend something new. So we have no idea about the relative affinity with each other, right? And second, at Dunnhumby, we work with product catalog ranging from at least 1,000K products till up to 2 million products. And customers usually buy only 400 to 500 products in a year maximum, right? So we have a huge base of products to score from, right? Which again makes it more challenging compared to reward. So unlike reward-driven recommendations, acquisition focuses on exploring uncharted customer preferences, which naturally will demand much more capable models. Right? So I just want to quickly mention the evaluation metrics that we use for such kind of problems. So this is your typical recommendation system where we are trying to predict or trying to get the probability trying to get the probability that the customer might buy a product. And then we rank order those products based on their probability scores. And precision at K and decile gain, they work really well in these scenarios, right? So before I deep dive into what we did using the transformer architecture for this, I just want to highlight the existing approach that we are following to keep a benchmark as a baseline. So matrix factorization methods like ALS, they are typically used in the industry for such kind of a problem. Think about predicting or suggesting new movies to a user, right? New movies that they have not watched before, and these are usually recommended based on whatever the user has watched in the past or whatever other users have watched, right? A typical Netflix problem. In our case, it is something similar, but instead of movies, we are trying to predict products, right? And ALS does fairly well in these cases, right? But it has its own limitations. So first, ALS or any matrix factorization-based method, they are not designed for handling sequential patterns or to understand the context around a product, right? And in retail, the retail purchase data is sequential in nature in a way, right? So your next purchase typically is related to what your current purchase is, right? This is where transformers comes in, right? I think we all know that they excel at capturing complex item-to-item correlations and temporal sequences within a sequential data, right? So yeah, These are the results of our ALS-based benchmarking. So PrecisionNet K, the PrecisionNet third slot is 2.26% and 1.86 and 1.49% at 10th and 20th slot, which is fairly decent for an acquisition kind of problem in retail. And ALS does a fairly good job in rank ordering as well, as evident from the decile gain. The fifth capture rate is 671%, and the rank ordering is also there, right? So now comes our approach, what we did using the T5-based, transformer-based T5 architecture. So I'm sure most of us in the room are already familiar with what T5 is. I'll just give a quick refresher. So T5 is a transformer-based model developed by Google. It treats every NLP problem as a text-to-text task, right? And they do really well in cases like summarization, language translation, or question answering. So essentially where you have a sort of input sequence and you have a target sequence as well. So now why we chose T5 for this and how does it fit in the retail scenario? So if I have to draw the analogy, then it goes something like this, right? In text, we have words and a collection of words are sentences, right? In retail, we have products, product IDs, and a collection of products will form a basket, right? So let's say if I go to Reliance Mart, I buy 5 products, right? So the collection of those 5 products is one basket for me in that shopping visit, right? So again, in text we have words and sentences. In retail we have products and they form a basket, right? In text problems, we usually have an input sequence, right? So it can be, so the input sequence is usually a sentence, which is the cat sits on a mat. In our case, the input will be a sequence of baskets. So if my one basket is, let's say I bought 3 products, milk, egg, and bread. So that's my one basket that I can treat it as an input, right? And we can have multiple baskets. So basket 1, then basket 2, then basket 3. We'll make a sequence out of it. And in T5-based problems, we also have a target sequence, right? So if it's, let's say it's a translation problem, we are trying to translate English to French, then the cat sits on a mat will translate to something like this in French. In our case, in retail, my target is whatever the customer is buying next after the input sequence, right? So if my first basket was milk, egg, and bread, then I bought jam and soda, so my target becomes jam and soda, right? So again, my input is a collection of products, which are milk and bread, and my target can be whatever basket I bought next, again, which is jam and soda, right? So, and we have seen that these text models, they usually do really well. These trained LLMs, they do really well in predicting what the next word should be, given an input set of words or sequence of words, right? So we thought if we treat our problem, the acquisition problem, in a similar way, but instead of text or words, if we replace them with product IDs and we train the model on a sequence of products or baskets, then it should give us, it should be able to predict what the next basket or next product should be, right? So that's where the idea came in, right? So this analogy between text sequences and basket sequences and T5's versatility in sequence to sequence tasks made it a good candidate for this kind of a problem, right? Yeah, so now comes the technical part on how we implemented this, or how we transformed this into our retail use case. So first is tokenizer and encoding, right? So first we created a set of special tokens, token IDs from 0 to 4, right? 0 is for padding, then beginning of sequence and end of sequence as 1 and 2. Then we had a separator, special token, to separate baskets, right? Something like a full stop in English, or where we just want to separate 2 baskets. And then we create a special token to denote any empty basket, right? So the users will not buy in all the weeks, right? So wherever they did not buy anything, we'll just denote it with a special token so that the model has some extra information there, right? So these are our 5 special tokens. Then we just mapped each product ID to a unique token ID ranging from, again, 5 to n plus 5. Something like product 1 will get ID 5, product 2 will get ID 6, and so on, right? The example will make it clearer. So now we have a tokenizer encoding. The next second step is to create the input sequence, right? So for getting the input sequence, we'll take a customer's last 8 weeks of transaction data. Now this 8 week is a kind of a hyperparameter. You can use 8, you can use 16, you can use 6 months, you can use 52 weeks, 1 year, right? We chose 8 weeks for a couple of reasons. First, We were working with a very limited infra back then. So the model, the architecture was not able to handle very large sequences, right? So we had to limit it. And second reason was the business reason was we noticed that most of the customers, they usually buy at least once within a span of 8 weeks, right? So we were covering a lot of customer behavior within 8 weeks. But we also want, this is a retail problem and we have seasonality in this, right? So we thought just one sequence of 8 weeks does not cover the whole year's picture, right? So what we did was we created a 52 rolling window training samples, one for each week, right? To account for seasonality. This is an example. So let's say a customer, as of any week, so let's say week 1, the customer bought 2 products, P1 and P8, then P9 and P2. They did not buy anything in third week, then just one product in fourth week, and then there were a couple of empty purchases, so no purchases in those weeks, right? And so on. So we'll take this data, we'll do the tokenizing on it, right? We'll first add beginning of sequence, end of sequence tokens, convert all the product IDs to their respective token IDs, add the basket separator, right, which separates 2 baskets, add add the special token for empty baskets, right? And then we finally encode it, right? So we just convert it to numbers. This is what the model sees while training, and this is a lot similar to how text models are also trained, right? You take a bunch of text words, you convert them into numbers, and you feed it to the model, and model tries to learn the patterns, right? So this is how we did it in retail. Then with T5, we also have target sequence, right? It is pretty straightforward. So whatever the customer bought in our target window in future, we'll just take a unique set of all those products, follow the same tokenizer encoding process, and then we'll get the target, right? So for example, if I'm creating my this data as of 1st of March, right? So my training window will be the last 8 weeks, which will be Jan and Feb, right? So I'll get this input sequence from Jan and Feb, 8 weeks. And my target window will be whole of March. So whatever I bought in those next 4 weeks, the whole of March, I'll treat those products in my target window. And these are all only the product that the customer has never bought before. And they bought it for the first time, right? Hence the novel item for training. Yeah, so we got our input sequence, output sequence, then we just pass it through a T5 architecture. We train the model. These are the training configs that we use for T5. So fairly smaller model in terms of number of parameters if you compare it with your other models, other T5 models for text, right? And then on the right, we see the cross entropy loss. So it stabilizes roughly after 20 epochs, right? I just want to quickly mention the infra that we were using, right? So back then we were working with 4 NVIDIA T4 GPUs, right? 16 GB memory each. Although these are optimized for machine learning workloads, but we were still facing a lot of constraints in terms of machine, right? Especially given the scale of data that you're working with, right? Yeah. So now we have a trained model. Now for the inference, you follow the same process for creating your input sequence. You use historical baskets as input for 8 weeks, create a sequence, pass it through a trained T5 encoder-decoder model. And for the output, so this is a recommendation problem, right? So we are getting the output as the probabilities across all the products instead of outputting the whole sequence, right? So we create a sequence, pass it through the model, we get the probability across all the products, and then we just simply rank order them and make our recommendations, right? Yeah. So these are the results that we got, right? And we are comparing it against our baseline ALS-based method. So T5 outperforms ALS-based method with roughly 15% improvement in precision at 10th and 20th slot, which is actually really good for retail, especially in this kind of a problem. And it outperforms ALS in rank ordering as well, as evident from decile gain, right? And the rank ordering also holds. Yeah. This is all good, but it does have its own limitations, right? So new products are launched almost every week in retail, right? And we have no information at all about their interaction with any customer in the market, right? Because they are new. So naturally they are not included in our vocabulary of products when we are training the model. So we cannot recommend for those at all. Then comes the stability issue. We work with a relatively smaller T5 architecture in terms of parameters, right? But if you want to scale it to larger data sets, or like we'll need, it will demand a substantial resource. Then currently this model only works on the purchase sequences, right? We are ignoring all the external factors like seasonality, promotion, and demographics. We are not including them directly, at least, right? So to tackle these problems, this is what we are trying, right? This is what we have planned as our feature improvement, right? To tackle cold start problem, we are planning on including, we want to incorporate a hybrid approach, right? And include product description embeddings that might help with cold start problem. The tokenizer that we are using, it's a very simple tokenizer where each product ID is mapped to one token, but we are thinking of using something smarter, right? Maybe a subword-based tokenizer on product descriptions to help better capture the semantic relationship between products. We definitely want to try a larger T5 config once we have secured better GPUs for this. And then target sequence modeling, instead of just using a set of unique products, we can also model it as a sequence, right? Just like the input sequence, and then we can train our models. Yeah, so we anticipated some questions, so I'll just walk you through them. So the dataset that we are using the Numbly's publicly available dataset. We call it Let's Get Sort of Real, LGSR. It is available on our website. You can download it from there, right? It's a typical transaction dataset with roughly 5,000 products and 500K customers. So a fairly decent dataset to rest on. And this has been mentioned in many other research academic papers as well, right? Have we tested this against any other benchmarks besides ALS? Yes, we have tested this against a traditional popularity-based benchmark and a neural network-based method. ALS was the best out of these three, so we kept that as our baseline in the paper. Why T5 and not BERT or any other architecture? So we wanted to treat this as a supervised problem where we have both an input sequence and an output sequence, right? And T5 sequence to 6 model seemed a good choice for it. But we are also exploring, currently trying out BERT for reg implementation for this. If this works out, we might write another paper on this, right? The infra that we're using for scaling on larger data sets, right? So as I said, currently we are using 4 T4s, right? And each training epoch would take us around 50 minutes, right? Which is huge. And the overall scoring on all the 500K customers, right, from LGS or dataset would take around roughly 2 hours. But yeah, now once we have the bigger A100 GPUs or something else, so we'll test on that, and we are trying to scale it for a bigger dataset with 10 million customers, 10 million active customers. Has this been tested for different time periods? Yes. So we have tested this across different time periods of the year, and the results are fairly consistent. This is primarily because the model has seen the sequences all around there because of the 52-week rolling window, right? That's it. Here's the team. This is me. We have Aditya and we have Abhinav. Now I think we are open to questions.
Thank you, Pawan. I think questions we out of time. We can take it outside the hall if that's okay.
Sure, sure.
Thank
I'm
you.
here
Thank
the
you,
whole
Pawan.
day. You can connect with me.
Thank you, Pawan.
Thank you.
So there's a quick announcement. Intel is organizing a trivia contest at Tiger Booth at 12 noon and 2 p.m. So interesting participant can take part in that event. Thank you. Uh, So the next session is pretty interesting again. I request everyone to settle down as we're about to start the session. Uh, People at the back, I request you to please take the seat in the front, please. So yeah, so how many of you have struggled to fine tune AI models? Only to realize, okay, you. So yeah, only to realize it's source heavy, time consuming, and often a guessing game, right? With so many, I request the audience to please settle down. In the front, excuse me. Could you please, yeah, settle down, please? Yeah. So with so many open source models available, and now you have even DeepSeek, choosing the right one and optimizing it can be overwhelming. So in this next session, the speaker will be talking about a unified platform for fine-tuning AI models, leveraging parameter-efficient fine-tuning, in short called PEFT, with QLoader, dynamic hyperparameter tuning, and automated pre-processing to make the process more efficient, effective, and privacy compliant. So leading this session is Divyanshi Yadav. She is the business analyst at Genpact, specializing in NLP, generative AI, and knowledge-driven AI solutions. Alongside Divyanshi, Vishul Sharma also would be joining, who is also the co-author of this particular paper. So welcome both Divyanshi and Vishul. Yeah.
Hello. Yeah, am I audible? Okay, hello everybody. So today we are going to present an innovative approach using which we can unify and elevate the model selection and comparison process. So presenting to you our research paper on model fine-tuning, a unified platform for model comparison. So we all have been in the field of Gen AI, and we know how volatile this is and how exponentially this has been growing. In last 1 year, we have seen multiple models getting introduced from GPT-4o, 4o Mini, O1, O1 Mini from OpenAI, Gemini from GCP. We have Claude from Anthropic, and the latest and the greatest one, DeepSeek R1, which have been in the headlines from past 1 week. It has almost caused a tech disruption, and with the bold claims that it has and the results it has to offer us, we all have been through the research papers and we have tried it on the dashboard, and it is working pretty well for the STEM use cases and for the reasoning tasks. So now the question arises that with these many models in our selection basket, which one is the best one to pick for a particular use case, for a niche domain specific use case that we have at hand, right? So to answer this question, we are here today. We'll talk about the challenges and get you the probable solution for the one for this, and to optimize the process as much as possible. So hi, good morning everybody. I am Divyanshi Yadav, and I have with me Vipul Sharma. We are both data scientists at Genpact. Starting off, so today we'll walk you through the business challenge that is at hand, and we will also talk about the solution that we have to offer for you. The methodology, we'll go through it, the experiments, the metrics that we use, the results that we got, and we'll finally conclude it. At the end, we'll take all the questions that you have. So starting off, I just mentioned that we have many models at hand, right? Now this on the right hand side is a snippet of DeepSeek R1's research paper, which clearly shows the scores that it has achieved in multiple benchmark data sets that there are in different use cases. And there's a comparison with the other models that there are. So we can clearly see that even the best model that is claimed to be the best model right now is not performing well in all the possible tasks, right? We can see that it outperforms OpenAI on maths, but OpenAI's O1 is performing better than 3 out of 5 benchmarks for coding. So of course, for coding, you would go for O1. But for any math problem, you'd probably pick DeepSeek R1, right? So selecting the right model for yourself is a challenge, and given the use case, now you want to pick the right model. There can be multiple use cases. For example, you want to make a use case, you want to create a system that can update your code with every Git commit that you have. As soon as your software pipeline updates, you want to update the documentation. Or there can be a verdict decision-making software, anything. And you want to get the right model for it. You cannot choose a model randomly. You have to try it and test it and do hit and trial multiple times, which of course incurs a lot of cost and all. So for this problem, people came up with fine-tuning. The industry nowadays fine-tunes smaller models to make it a best fit for the domain use case that you have at hand. And we have seen it working pretty well. So a smaller model, here Instruct GPT, which is just 1.3 billion parameter model, if fine-tuned on a particular data set, is seen to perform better than a larger model which is GPT-3, just a pre-trained model, with 175 billion parameters. So we have seen fine-tuning is working wonders, right? But now, which model is to be fine-tuned? On what data, with what parameters, is also a question, and we do trial and error for that as well, right? So how many of you are comfortable with model fine-tuning? How many of you have worked with it? And how many of you are aware of the challenges that we have in model fine-tuning? Yeah, I can see there are a few hands going up, but I'll just reiterate for the rest of you that while fine-tuning a model, there are multiple challenges that we face. There is data, of course. There is infrastructure. There is cost that is going to be incurred, etc., etc. But why we are fine-tuning the model? Fine-tuning is just that you're taking a pre-trained model, you're ingesting some domain-specific data to it, and you're making it use to your data, which helps the model to understand the use case, the data, and it performs, increases the performance of your base model. That's it. So you help the model to acquire some domain-specific knowledge, which enhances the performance of your base model. It is a cost-effective approach. Rather than using a larger model and assuming that a larger model will suit your use case, it's better to go for a smaller model, fine-tune it on your data set. You might get a better accuracy, and you might save up some money there. We've already talked about this one, and most of the open source models are open for fine-tuning, and some of the proprietary models are there, and you can fine-tune them. Going ahead with the challenges, so fine-tuning a model incurs significant amount of cost. You need separate infrastructure. It is to be provisioned for your fine-tuning. Then the data quality is directly proportional to the quality of your fine-tuning. The better the data you provide to the model, the better accuracy you would see at the end. Then the hyperparameter, even if you take care of the first three, right, the infrastructure, the cost, and the data quality, if you take care of the first three, the last two will still give you a hard time. So choosing the right hyperparameters and choosing the right models will take multiple iterations of trial and error, which will take a lot of cost, time, money, effort, etc. Now, how can we save up some money here? How can we save up some time here? So we are kind of sort of there with the business challenge and the use case, that there are multiple open source models, and we want to search the right one for our use case. Multiple experiments are to be done to get to the right model. We want to save some money, and I'll just skip through it. And then coming to the objectives, that we want to design a data-driven solution that can help you get to the right model and also give you the right set of hyperparameters as a byproduct. We want to optimize the process, save time. So now we are coming to the framework that we are using for this entire thing. So we start with a user that has a particular use case at hand, right? And some data set. The user has to give the framework some set of data and some use case description along with a minimum accuracy threshold that is expected. Minimum can be 80 and max always remains 100, right? And an evaluation script is to be given by the user. Now, the data set goes through a generative AI model. This data set is broken down into subsets, and each subset is representative of the whole population. So we stratify the data set, and now this stratified random sample of the data set and the rest of the metadata is again sent to a generative AI model, and we choose the right benchmark for that use case. Now we refer to the leaderboard for that use case, and we pick the top 10 models that are there according to the leaderboard. There are multiple leaderboards available. We pick the top 10 models, and we use the 4-bit quantized versions of them. We pick that and we train it with different set of hyperparameters like alpha, LoRa, etc., etc. And post that, we use a custom model selection algorithm, which we will be talking about in the next coming slides. If we get to the right amount of accuracy, we come out of the loop. If we are not there yet, we have not found out the most optimized model with the least amount of cost and infra that is required, we reiterate and we check the other models that we have. I'll over to you for...
Check. Okay, it's working. So thank you, Divanshi, for giving the good overview of the solution design that we have in place, or the framework that we can say. So while the entire fine-tuning process, the many of you who would have fine-tuned before, they must know it. But you would have noticed a version that you might not have seen before. That is the customized model selection algorithm. Now, this is not something that is available out there in the market. This is something that we came up with, and I'm going to show you through how did it actually work. So please stay focused for now. So while we select 10 models for our fine-tuning processes, 10 models is a bit too much to show on a slide. So for example, I have picked 5 models. These are some sample models that I have on place. They are all arranged on their model size, or you can say that training billion parameters, how much the size the model has. They are sorted in an ascending order based on that. Now, it is always safe to start with the middle value. So what we do first is we pick the middle model that is available in the top 10 leaderboards model, and we fine tune it based on all the hyperparameters tuning that are in place, and we see whether the minimum accuracy threshold that Divanshi has already mentioned is being met or not. So now there are two cases will be arising. What happens when the accuracy is being met, and what happens when it is not being met. So I'd like you to come to the second diagram here. Is what will the custom model selection algorithm do if the accuracy is met? Now the whole aim of this experiment is to give you the least model size, or you can say the most optimized size, which you can use for your use case with the minimum cost, minimum infrastructure requirements, and all of the above things. So while if we meet the accuracy threshold with model 3, it is still possible that we might be able to meet the accuracy threshold with smaller models as well. So now the testing goes on to the left hand side, or the left hand list, which will be in a scale of 1 to 10. If the models are from 10, it will be like 1 to 5 along. So in those 1 to 5, now we have a smaller list. In those, again, we go for the middle element. Here it is just 2, so it goes for the middle element. It will check now whether this middle element is being able to meet the accuracy or not. This will go on till we are able to optimize it further. Now what happens if the accuracy at a certain point is not being met? So this is the third case. If the accuracy is not being met, then the model shifts to the right side. Now why this right side? You can understand it with your intuition. Is whenever you use certain models, as the size of the model increases, the general observation is the capability of the models and the accuracy of the output increases as well alongside. So if a certain model at suppose 15 billion parameters model is not able to perform well on your use case, what you do? Maybe you should go ahead for the model which is more capable in the list and that is available. So now the shift goes to the right hand side, and again the same process repeats, that the half of the list, the middle element is chosen, or the middle model is chosen, and that is hyperparameterized, fine tuning is done, and the accuracy is being met. Now at a certain point, it is possible, it will happen at a certain point where there is no going left or right, and you will be stuck with a model, or you will have the model which will be giving you the target accuracy with the minimal set of hyperparameters. Now or the model size, that will be the most optimal model for your use case, and the solution will be able to give you the name of the model, as well as the hyperparameters on which it was able to give you that result as well. This saves a lot of time because earlier this whole set of hit and trial experiments were manual, and a lot of resources, money, time, infrastructure was invested in this. Now this entire thing is a data-driven pipeline which can accommodate all the changes that are needed, which earlier required a human in the loop. Okay, let us go. So this is the example of how the model selection algorithm works. So the use case here is a summarization of email. We have picked a use case simple enough to understand for all, so everybody has a go at it. Now there are 10 models that are selected. All are open source and arranged in a ascending order of their model size. Now what happens? I like to see to the table here. At first step, the middle element is Llama 3.18b. That is fine-tuned, but the minimum accuracy threshold, as you are able to see in the above, it is 90% set by the user. The user wants nothing less than 90%. That is a breakup point for him. But the model gives 73%. Is it able to meet the target accuracy? No. So what happens? If this model is not able to meet, we go for the larger models. So now there are 5 models left, which are on the right. Now in this 5 model, in the second step, we go for the middle element once again. You can check, and the accuracy is 86. It is still not able to meet, but now we are left with 2 models. Now in the third step, we go ahead for another model. Now it is able to give you 92. And here, while the accuracy is being met, we stop because now there are no more models left to optimize it. Now if this would have met here, then we would have got to the left-hand side to see if we can fine-tune or we can optimize the size of the model to reduce the cost or the overheads in the long run. And the conclusion for this experiment will be Llama 3.370b is the go-to model for you to choose, which earlier required all 10 set of model experiments. Now, how many experiments did you do? You did 3. The complexity for all the SDs here in this room, the time complexity reduces from ON to O log n. This is the drastic improvement. Now this is 10. As in when the size of the models or the length of the list increases, the difference in the cost and the time invested will be huge. Okay, so going next. So let us talk about the optimizations here in place. There are several points where we have optimized the solution compared to the traditional approach. The first is the optimization of data set. So please refer to the solution design that we first shared. How the optimization of data set is taking place? It is taking place due to the stratified random sampling data set that we are using. It is a much smaller data set. Optimization of model pool. Now we are not testing on every model. We are only testing on the models that are tried and tested and are on the leaderboards. So optimization of model size, because we are fine-tuning, the entire set of experiments are being done on the 4-bit quantized model size. So the optimization of model size is taking place as well. Optimization of hyperparameter tuning. The user does not need to do anything. The entire pipeline will be able to give them the best set of hyperparameters for that particular model. And the last is the optimization of model selection. Now the entire model selection is of the time complexity O log n instead of the ON that we are used to before. Coming to the evaluation and experimentations, the data set I have already mentioned. It is a summarization of email on which the entire set of experiments were being conducted. Few of the experimentation evaluation metrics or the key points are here is model with the improved performance. We are able to get the model which will be able to give the minimum accuracy threshold with the minimum size. So the model performance improvement is evident. There are insights on evaluation. What are the insights? Now, there will be cases of hallucination as well, which all of you must be familiar with. So those cases will be highlighted on the evaluation script itself. The latency, the cost incurred in the fine-tuning, everything will be laid out to the user as a cost or metric report, and they will be used to, they can use it for their own decisions, and this will give them a great insight on the entire experiment. And higher productivity. The fine-tuning experiments on these 10 models, which earlier would have taken 3 to 4 weeks to complete it in its entirety, now can be done in a matter of few days and with minimal resources as well. The results, I'll go through the 2 charts here. The first is the memory optimization, because the 4-bit quantized models is almost 1/4 of the size of the full model for fine-tuning. So a person who is fine-tuning a full-size model will be incurring much more cost or time requirements on the GPU than the 4-bit quantized models. And the 4-bit quantized model is something that we use. So the optimization on the memory footprint is pretty evident. The most important result for this is, if we would have gone for the traditional method for this experiment, it incurred us around $232. However, with our approach, the entire thing, the similar results, similar set of hyperparameters and everything we were able to get in 81.2. This is a drastic improvement in the cost efficiency. We are able to save almost 65% of the total cost that is being incurred without being compromising on anything. Now, improved efficiency. The entire process is being more efficient. I will not spend more time on this because we have already talked about the optimizations here. Cost saving opportunities, almost 65%. That is a phenomenal number for a fine-tuning experiment, as well as the time that is being saved. So that is also extra. Reliable and optimized solution. While the entire solution is robust, it still provides the user the flexibility to change anything. They can change the number of models from 10 to 20. They can change maybe a different algorithm or something. So entire thing, it is, while being flexible, it is still robust enough to not compromise on the efficiency of the solution. And this takes us to the conclusion slide, where the entire solution is data driven, and data driven often brings in the more trust from the business side. The solution is highly optimized, as shown in the second point. All the optimization points we have already mentioned, and all the redundant parts of the fine-tuning are being removed. The entire fine-tuning experiment, the model selection part is being optimized. The cost saving is pretty evident. The time saving is an additional. And one more extra thing is the requirement of less human resource to get the same results that we were able to get with the earlier experiments. So thank you guys for being a good listener. That takes us to the end of end of this presentation, and we'll be open for questions if there are any.
Thank you, Vipul. Thank you, Devanshi. The floor is open for questions if anyone has one. I think a lot of questions. Okay. So could we have the mic, please? Yeah.
Yeah.
And please introduce yourself and what you do before asking question, please. Yeah.
Yeah, sure. Yeah. I'm here. Yeah. I'm Tejasvi. I'm working as a data scientist at Synchrony. We are a bank. So a wonderful presentation. Thank you. One quick question is for the email summarization example, right? What was the benchmark leaderboard metric, right, that you were using? Because there are different leaderboards, different benchmarks. So just wanted to understand how did you pick the right benchmark metric as well?
Okay. So for the English proficiency exam, for the English proficiency tests, there are few metrics I can show you. I'll go you both. I think the first slide which Devanshi showed focused on that only. You'll take a question? Okay. Okay. So this part is for the English part. Now there are of course, even for the English there are a lot of benchmarks available. Now we went ahead with MMLU and the GPTQA Diamond. There are few reasons. Like in all of the research papers for whatever the new model that are being released, you will first see the numbers that are being quoted for MMLU. That is one of the standard English benchmark datasets which shows the proficiency of a particular model on generalizing the efficiency on English task. Now summarization itself is a pretty English intensive task because the disclaimer, the entire dataset was in English. Okay, so the MMLU, this gives a very good idea of how the model will perform in general in all the English tasks. Like I'm not talking about the reasoning, only the English intensive tasks. So yes, that is what we have used to shortlist the models.
Okay, thank you.
Hi. Just wanted to understand on the hi. So just wanted to understand on the hyperparameter selection. So as you said that you were iterating on a lot of models, right? So for example, every model will have its own set of hyperparameters. So for example, just to give you a very random example, LoRa depth, right? So for some of the smaller models, larger LoRa depth might work. For larger models, might not work. So how do you come up with the set of hyperparameters for each and individual models? So if you can elaborate a bit on that.
Yes. Okay. So during the introduction itself, what we mentioned is the entire fine-tuning experiments were conducted on the QLoRa fine-tuning technique. Now the QLoRa fine-tuning, while it has a lot of parameters to fine-tune as well, we used a few of the metrics that made the most changes based on our experimentation. That is the rank and the LoRa alpha.
Okay.
So these parameters, based on our experimentation, changing them were drastically affecting the results that were in place. Now, of course, there are a lot of parameters. There will always be question on why not we optimize the other parameter. There's always a scope for increasing. Now, as we increase each hyperparameter, you already realize the complexity of the entire solution will go exponentially. So we picked only the worst because the entire use case behind this research paper is to optimize the entire process of model selection and coming to a conclusion that was not so quick in the traditional methods.
Okay,
So,
thank you.
Yeah.
Sure.
Thank you guys first of all for this lovely session. I just have two questions. First was related to you are using 4-bit quantization. Did you do experiment with like 8-bit or something, or is just like across all the model that you are using is remain that?
So the reasoning here was backed by a few things. There were few experimentations done on various frameworks. One of them is Unsloth. I think you might have heard
Yeah.
of it. So they offer the while 1 billion on all are there in the market as well. But based on our experimentation, the 4-bit model, the 4-bit quantized model,
Okay.
they were pretty efficient or pretty close to the 16-bit model, which the accuracy drop while in the 1 billion parameter there was still significant that we would
Okay.
because we want to make an informed decision of how the full model fine tuning will work in the production.
Understood.
So we did not want to go so low that the 90% that the full model would have given, now the 1 bit is giving 72 and we would have missed that. So that is why we went for 4 bit, so we can retain the most of the efficiency of the model while not compromising with the accuracy.
Okay. And second question was related to your initial infra setup. So I could see in your chart here go from 8B to like 70B. So initial your setup is started. So you take the worst case like to handle the 70B model, right? I mean, so your initial.
Your question is here, right?
Yeah, yeah. My question is here because you started with I think 8B and then you go up to 70.
No, that is 3.8b.
Yeah, I read 3.8B and
Yes.
then you like final one that works for you is 70B. So your initial infra setup was able to handle up to that case because in each model selection that you your infra will either
Definitely,
evolve
definitely.
or decreases.
Yes, yes, the infra question is definitely something that is most challenging. So what happens here is it is something very interesting. For if we are talking about a full size model, the GPU that we will use for fine tuning it will change drastically. Like a simple A100, I'm talking about just Azure. A simple A100 for the most of the till maybe half or sixth of the models would do just fine. After that, we'll have to raise the bar of the A100s, and maybe the last one will require the maximum A100 or maybe the H100 that is in place. However, with the 4-bit model quantizations, that is something that we are able to solve for most of the models.
Okay.
Because the 4-bit model consideration, it directly almost 1/4 the model size. Now with just you can optimize the secondary storage of the compute, then you will be able to fine tune almost all of the models.
Okay, makes sense. Thanks again for answering.
Sure.
There's one more question.
Yeah, great presentation. Thank you so much. I had one question. It's in this slide only. So when we're dealing with models from different companies, let's assume we started with a model which is in between the list, and it does not meet the threshold. But if there is another model which is of less parameters, but if on fine tuning could perform better, it's on the left side, but we are not choosing it, right? What would be the case in that?
Okay. So there is one thing, suppose I would like to take this with an example. Suppose the middle, as you have said, in the middle scenario, the middle model is chosen and it was not able to meet up accuracy. Now, by default, the algorithm will ask it to go forward. Okay. Now, the go forward, it comes with two cases as well. There is a potential that, as you are saying, maybe a newer, smaller, more efficient model is launched and it might be there and it might be missed if we go forward. Now, there is a catch. If going forward, if that solution itself does not give you the result, we will still revert back to the original method of we will pick all of those 4-bit quantized models that are left to see if we are able to still reach the efficiency at this point. Now, why is that important? Because while optimization we are able to do in 90-95% of the cases, but there might still be 5% where the algorithm definitely can miss. So that is the safeguard that is in place to ensure that these models are not missed.
Okay, but if the model which is performing better, if the right side model has met the threshold, but the model which is on the left side would be more efficient, right, in terms of GPU usage and other parameters if you're taking in consideration.
Yes. But this whole algorithm is based on the assumption that I have already highlighted. Is we often, like, this is not always. Of course, there will be change with time. we often come across these cases that the models, as they increase in the model size, the training billion parameters, they increase in their efficiency as well. So that is where the whole algorithm is based on.
So although your point is extremely right, right? But the likeliness of that happening is very low. So we assume that we'll.
Yes.
I have the follow-up question on that. So if you are saying that the assumption is that the heavier the model, the better the model, and if you have the infrastructure that can handle 70 billion, why not directly go with the 70 billion? Why even try maybe 8 billion or 3.5?
That is a very, you want to take? That is a very good question, in fact, and that is where the entire use case of this research paper comes into the play. What we discussed earlier is we are aiming to provide the accuracy threshold that the user wants with the minimum cost and time. Now, how will ensure minimum cost? The deployment cost for the model increases exponentially as the model size or the model complexity increases. Now we can definitely, that raises the question that why did we go for the open source model in the first place? Why not directly go for the OpenAI O1? That is charging $15 per million token for input and $60 per million token for output. Now directly just deploying O1 in the solution might not be the best possible solution that you have. In client's projects or something, the client will always have some budget constraints, definitely will have some compute constraints or some other policy restriction that they cannot deploy the bigger models because of the cost, because of the latency. Suppose you are using a real-time application. These reasoning models, as you go through the bigger models, the time also increases. The smaller model, that is where they excel the best. So that is where just directly going for the bigger models will backfire.
Got it. Thank you.
Thank you. Thank you, Vipul and Devyanshi. That was a brilliant presentation. Really amazing to see the fine-tuning cost reduced to less than 60%, you said? 70%? You said 60, right? Thank you. Thank you so much. So now we'll be breaking for lunch. See you in the second half at 1 p.m. Yeah. Thank you. Yeah, sure. They'll do it there.
At Google, AI isn't a tomorrow thing. It's a today thing. And sure, we can ask for answers to life's tough questions. But today, we can also ask it to do tough things, like ship that wood more efficiently, use satellites to reduce methane emissions, turn DNA into code to make drought-resistant corn. Oh, cool. It can spot and fill potholes, spot disease earlier, spot asteroids to protect Earth. It can create apps with just words and just hours. Today, Google AI can scan 100,000 lines of code in 2 minutes to spot and fix bugs. It can translate from code to code and is one step closer to speaking 1,000 languages, even whale. Today, AI impacts lives for the better and understands the world the way you do. Our AI spots threats 7 times faster, understands speech sentiment, helps prevent vision loss, predicts weather 10 days out in 2 minutes, translates thousands of pages in seconds, detects lead pipes to keep drinking water clean, eliminates paperwork so care is more human, generates from text, visuals, audio, and video, creates entire worlds from your imagination, creates this thing and that thing, a new thing, the new way. It's cloud.
Maths को begin with a
solve their most pressing challenges. We started as a small, passionate team of problem solvers, driven by the belief that data could empower businesses to think bigger and do better on their own. Self-sufficiency remains at the core of our offerings to enterprises. We strongly believe that we live in an age of hyper-personalization. Enterprises, in the quest for being digitally at the top of their game, often face critical challenges. Challenges that can result in millions of dollars lost or missed opportunities earned. They're looking to evolve while overcoming their own unique set of challenges. We today engage with more than 60 plus global enterprises across multiple verticals like retail, consumer goods, pharma, technology, and many more to come.
We're here to enable them to make smarter, faster decisions with enterprise intelligence. It's not just about solving problems, it's about building trust both with people and with tech and creating everlasting value.
Our strength doesn't just lie in numbers, it's in the unparalleled expertise of our mathematicians. Our people are the heartbeat of NAPCO. They innovate, collaborate, and bring ideas to life in ways that drive real-world outcomes.
Every individual has a space to take ownership, make an impact, and shape not just their careers, but the success stories of our clients.
Everything we do revolves around creating meaningful experiences, whether it's through exceptional delivery for our clients or the way we collaborate and support one another as a team. Each mathematician's goal aligns with our larger mission to empower decision makers in global enterprises to own and activate intelligence.
Our goal is to scale MAPCO from where we are to 10 times our size. 10x in terms of the value that we add to our customers, the quality of experts we have on board, and the capabilities that we invest in. All in all, we want to be a one-stop shop for all our customers' digital transformation needs.
Synchron is a leading global consulting firm for digital transformation and technology enhancements. We specialize in the financial services and technology innovation sectors. We work hard to become the trusted innovation and transformation partner of choice to our clients. Synchron's progressive technologies and optimization strategies span end-to-end artificial intelligence, consulting, digital, cloud and DevOps, data, and software engineering, servicing an array of noteworthy top-tier firms. Our coordinated cross-regional teams have deep domain experience in high-tech, capital markets, investment banking, wealth management, retail and commercial banking, asset management, exchanges, insurance, and payments, as well as cutting-edge technologies. Our 14,000-plus global employees, spanning 55 offices across 20 countries, are passionate about innovation and meeting new challenges.
Our team at Synchron is committed to pushing the boundaries of AI technology and delivering state-of-the-art solutions. We understand the importance of staying ahead in today's fast-paced world, and Gen AI tools are designed to give you that competitive edge. The future is here, and Gen AI is leading the way. Embrace the power of generative AI with Synchron Nexus tools.
In a world clouded with complexity and ambiguity, there exist significant opportunities for disruption and growth. At Tiger Analytics, we help our clients navigate this uncertainty, empowering them to move decisively through shifting sands, unlocking these opportunities. We work with our clients to strategize, design, and engineer a future-ready enterprise. At Tiger Analytics, we've been reimagining possibilities with cutting-edge AI and analytics, solving some of the toughest problems out there and building the blueprint for tomorrow. And at the heart of this mission is our battle-tested team of exceptional technologists and consultants. It's our unique expertise and character that enable us to create exceptional value even in hazy conditions. That's our Tiger Gene. The Tiger Gene is what makes us learn relentlessly, experiment without fear, seek help and offer help. The Tiger Gene is what helps us uncomplicate complex problems, build for the future, deliver clarity amidst ambiguity. To our clients who are traversing a fog of uncertainty, we are not just a technology partner, we are a certainty partner, relentlessly seeking, solving, challenging, and growing. Together, as we set bold ambitions and target extraordinary outcomes, let us experience the power of data-guided decisions, the potential of connected insights, the promise of an AI-empowered future. Experience certainty to shape a better tomorrow with Tiger Analytics.
Even before the world could start talking about AI and Gen AI, for the last 15 years, we have invested in AI with the pioneers in AI. We have built some world-class solutions around AI.
Wipro has been at the cutting edge of data science and AI for a while now. Wipro and I get to work across various and diverse industries, everything from agriculture to pharmaceuticals to healthcare to oil and gas.
So we are helping many Mang level customers in their transformation journey. So we have strategic consultants, we have domain experts, we have data scientists. So basically we do customer hand holding right from the inception to post-deployment stage.
We have more than 400 plus use cases which are live. We embed AI into the end-to-end software development lifecycle, as well as we are working with our clients to infuse AI into the operations as well, the application management services, infra management services, by bringing in the generative AI to enable an end-to-end transformation, autonomous operations for our clients, predictive operations for our clients.
Our responsible AI is taken extremely seriously, and we have typically 4 dimensions that we talk about. One is the societal dimension, the individual dimension, environmental, and technical dimensions.
So there's a wide variety of work that we get exposed to in terms of AI and solving various kinds of industry challenges, and that's the part I love most about. And Wipro offers a tremendous great learning environment, a working environment for us to learn every day and experiment on various things.
The amount of flexibility this company offers in terms of the working location or the working hours, that is why I feel that I could not find a better company to start my career with.
Apart from work, I just wanted to talk about the facilities that we have. We have a great creche over here, and my daughter goes to that creche. At the end of the day, we get to spend time together with the strays, and we can spend some time with them and can feed them. I feel this is something which is really unique and great about Wipro, that we are able to share this message of love to our next generation with all these small things that we do, and I feel super proud about it.
So it is understanding their aspirations, understanding their capabilities which they may not be aware of, and that requires observation, that requires passion to help the person, and that's what Wipro is all about.
It's an exciting place for people to come work here, work in cutting edge technology or solve real life problems and really transform the world as well. That's what we are.
And this is a great place for people to work, and me being an example of that. It gives you an opportunity to explore different domains, different technologies, and different geographies, which can provide a very nourishing experience for the people. Working in Wipro is an exciting learning experience.
For me, working in Wipro is all about creativity.
Working with Wipro is innovative.
I find working at Wipro extremely impactful.
Working at Wipro is exhilarating for me.
For me, Wipro is a second home.
Even before the world could start talking about AI and Gen AI, for the last 15 years, we have invested in AI with the pioneers in AI.
Our responsible AI is taken extremely seriously, and we have typically 4 dimensions that we talk about. One is the societal dimension, the individual dimension, environmental, and technical dimensions.
And Wipro offers a tremendous great learning environment, a working environment for us to learn every day and experiment on various things.
Working in Wipro is an exciting learning experience.
For me, working in Wipro is all about creativity.
Working with Wipro is innovative.
At Google, AI isn't a tomorrow thing. It's a today thing. And sure, we can ask for answers to life's tough questions. But today, we can also ask it to do tough things, like ship that wood more efficiently, use satellites to reduce methane emissions, turn DNA into code to make drought-resistant corn. Oh, cool. It can spot and fill potholes, spot disease earlier, spot asteroids to protect Earth. It can create apps with just words in just hours. Today, Google AI can scan 100,000 lines of code in 2 minutes to spot and fix bugs. It can translate from code to code and is one step closer to speaking 1,000 languages, even whale. Today, AI impacts lives for the better and understands the world the way you do. Our AI spots threats 7 times faster, understands speech sentiment, helps prevent vision loss, predicts weather 10 days out in 2 minutes, translates thousands of pages in seconds, detects lead pipes to keep drinking water clean, eliminates paperwork so care is more human, generates from text, visuals, audio, and video, creates entire worlds from your imagination, creates this thing and that thing, a new thing, the new way. It's cloud.
Mathco began with a bold yet simple vision in 2016 to help enterprises unlock the full potential of their data and solve their most pressing challenges. We started as a small, passionate team of problem solvers, driven by the belief that data could empower businesses to think bigger and do better on their own. Self-sufficiency remains at the core of our offerings to enterprises. We strongly believe that we live in an age of hyper-personalization. Enterprises, in the quest for being digitally at the top of their game, often face critical challenges. Challenges that can result in millions of dollars lost or missed opportunities to earn them. They're looking to evolve while overcoming their own unique set of challenges.
We today engage with more than 60 plus global enterprises across multiple verticals like retail, consumer goods, pharma, technology, and many more to come.
We're here to enable them to make smarter, faster decisions with enterprise intelligence. It's not just about solving problems, it's about building trust both with people and the tech and creating everlasting value.
Our strength doesn't just lie in numbers, it's in the unparalleled expertise of our mathematicians. Our people are the heartbeat of Mathco. They innovate, collaborate, and bring ideas to life in ways that drive real-world outcomes.
Every individual has a space to take ownership, make an impact, and shape not just their careers, but the success stories of our clients.
Everything we do revolves around creating meaningful experiences, whether it's through exceptional delivery for our clients or the way we collaborate and support one another as a team.
Each mathematician's goal aligned with a larger mission to empower decision makers in global enterprises to own and activate intelligence.
Our goal is to scale Mathco from where we are to 10 times our size, 10x in terms of the value that we add to our customers, the quality of experts we have on board, and the capabilities that we invest in. All in all, we want to be a one-stop shop for all our customers' digital transformation needs.
Synchron is a leading global consulting firm for digital transformation and technology enhancements. We specialize in the financial services and technology innovation sectors. We work hard to become the trusted innovation and transformation partner of choice to our clients. Synchron's progressive technologies and optimization strategies span end-to-end artificial intelligence, consulting, digital, cloud and DevOps, data, and software engineering, servicing an array of noteworthy top-tier firms. Our coordinated, cross-regional teams have deep domain experience in high-tech, capital markets, investment banking, wealth management, retail and commercial banking, asset management, exchanges, insurance, and payments, as well as cutting-edge technologies. Our 14,000-plus global employees, spanning 55 offices across 20 countries, are passionate about innovation and meeting new challenges.
Our team at Synchron is committed to pushing the boundaries of AI technology and delivering state-of-the-art solutions. We understand the importance of staying ahead in today's fast-paced world, and Gen AI tools are designed to give you that competitive edge. The future is here, and Gen AI is leading the way. Embrace the power of generative AI with Synchron Nexus tools.
In a world clouded with complexity and ambiguity, there exist significant opportunities for disruption and growth. At Tiger Analytics, we help our clients navigate this uncertainty, empowering them to move decisively through shifting sands, unlocking these opportunities. We work with our clients to strategize, design, and engineer a future-ready enterprise. At Tiger Analytics, we've been reimagining possibilities with cutting-edge AI and analytics, solving some of the toughest problems out there and building the blueprint for tomorrow. And at the heart of this mission is our battle-tested team of exceptional technologists and consultants. It's our unique expertise and character that enable us to create exceptional value even in hazy conditions. That's our Tiger Gene. The Tiger Gene is what makes us learn relentlessly, experiment without fear, seek help, and offer help. The Tiger Gene is what helps us uncomplicate complex problems, build for the future, deliver clarity amidst ambiguity. To our clients who are traversing a fog of uncertainty, we are not just a technology partner, we are a certainty partner, relentlessly seeking, solving, challenging, and growing. Together, as we set bold ambitions and target extraordinary outcomes, let us experience the power of data-guided decisions, the potential of connected insights, the promise of an AI-empowered future. Experience certainty to shape a better tomorrow with Tiger Analytics.
Even before the world could start talking about AI and Gen AI, for the last 15 years, we have invested in AI with the pioneers in AI. We have built some world-class solutions around AI.
Wipro has been at the cutting edge of data science and AI for a while now. Wipro and I get to work across various and diverse industries, everything from agriculture to pharmaceuticals to healthcare to oil and gas.
So we are helping many Mang level customers in their transformation journey. So we have strategic consultants, we have domain experts, we have data scientists. So basically we do customer hand holding right from the inception to post-deployment stage.
We have more than 400 plus use cases which are live. We embed AI into the end-to-end software development lifecycle, as well as we are working with our clients to infuse AI into the operations, as well the application management services, infra management services, by bringing in the generative AI to enable an end-to-end transformation, autonomous operations for our clients, predictive operations for our clients.
Our responsible AI is taken extremely seriously, and we have typically four dimensions that we talk about. One is the societal dimension, the individual dimension, environmental, and technical dimensions.
So there's a wide variety of work that we get exposed to in terms of AI and solving various kinds of industry challenges, and that's the part I love most about. And Wipro offers a tremendous great learning environment, a working environment for us to learn every day and experiment on various things.
The amount of flexibility this company offers in terms of the working location or the working hours, that is why I feel that I could not find a better company to start my career with.
Apart from work, I just wanted to talk about the facilities that we have. We have a great creche over here, and my daughter goes to that creche. At the end of the day, we get to spend time together with the strays, and we can spend some time with them and can feed them. I feel this is something which is really unique and great about Wipro, that we are able to share this message of love to our next generation with all these small things that we do, and I feel super proud about it.
So it is understanding their aspirations, understanding their capabilities which they may not be aware of, and that requires observation, that requires passion to help the person, and that's what Wipro is all about.
It's an exciting place for people to come work here, work in cutting edge technology or solve real life problems and really transform the world as well. That's what we are.
And this is a great place for people to work, and me being an example of that. It gives you an opportunity to explore different domains, different technologies and different geographies, which can provide a very nourishing experience for the people. Working in Wipro is an exciting learning experience.
For me, working in Wipro is all about creativity.
Working with Wipro is innovative.
I find working at Wipro extremely impactful.
Working at Wipro is exhilarating for me.
For me, Wipro is a second home.
Even before the world could start talking about AI and Gen AI, for the last 15 years, we have invested in AI with the pioneers in AI.
Our responsible AI is taken extremely seriously, and we have typically four dimensions that we talk about. One is the societal dimension, the individual dimension, environmental, and technical dimensions.
And Wipro offers a tremendous great learning environment, a working environment for us to learn every day and experiment on various things.
Working in Wipro is an exciting learning experience.
For me, working in Wipro is all about creativity.
Working with Wipro is innovative.
At Google, AI isn't a tomorrow thing. It's a today thing. And sure, we can ask for answers to life's tough questions. But today, we can also ask it to do tough things, like ship that wood more efficiently, use satellites to reduce methane emissions, turn DNA into code to make drought-resistant corn. Oh, cool. It can spot and fill potholes, spot disease earlier, spot asteroids to protect Earth. It can create apps with just words and just hours. Today, Google AI can scan 100,000 lines of code in 2 minutes to spot and fix bugs. It can translate from code to code and is one step closer to speaking 1,000 languages, even whale. Today, AI impacts lives for the better and understands the world the way you do. Our AI spots threats 7 times faster, understands speech sentiment, helps prevent vision loss, predicts weather 10 days out in 2 minutes, translates thousands of pages in seconds, detects lead pipes to keep drinking water clean, eliminates paperwork so care is more human, generates from text, visuals, audio, and video, creates entire worlds from your imagination, creates this thing and that thing, a new thing, the new way to cloud.
Mathco began with a bold yet simple vision in 2016 to help enterprises unlock the full potential of their data and solve their most pressing challenges. We We started as a small, passionate team of problem solvers, driven by the belief that data could empower businesses to think bigger and do better on their own. Self-sufficiency remains at the core of our offerings to enterprises. We strongly believe that we live in an age of hyper-personalization. Enterprises, in the quest for being digitally at the top of their game, often face critical challenges. Challenges that can result in millions of dollars lost or missed opportunities to earn them. They're looking to evolve while overcoming their own unique set of challenges.
We today engage with more than 60 plus global enterprises across multiple verticals like retail, consumer goods, pharma, technology, and many more to come.
We're here to enable them to make smarter, faster decisions with enterprise intelligence. It's not just about solving problems, it's about building trust both with people and the tech and creating everlasting value.
Our strength doesn't just lie in numbers, it's in the unparalleled expertise of our mathematicians. Our people are the heartbeat of MathCo. They innovate, collaborate, and bring ideas to life in ways that drive real-world outcomes.
Every individual has a space to take ownership, make an impact, and shape not just their careers, but the success stories of our clients.
Everything we do revolves around creating meaningful experiences, whether it's through exceptional delivery for our clients or the way we collaborate and support one another as a team.
Each mathematician's goal aligned with our larger mission to empower decision makers in global enterprises to own and activate intelligence.
Our goal is to scale MathCo from where we are to 10 times our size, 10x in terms of the value that we add to our customers, the quality of experts we have on board, and the capabilities that we invest in. All in all, we want to be a one-stop shop for all our customers' digital transformation needs.
Synchron is a leading global consulting firm for digital transformation and technology enhancements. We specialize in the financial services and technology innovation sectors. We work hard to become the trusted innovation and transformation partner of choice to our clients. Synchron's progressive technologies and optimization strategies span end-to-end artificial intelligence, consulting, digital, cloud and DevOps, data, and software engineering, servicing an array of noteworthy top-tier firms. Our coordinated, cross-regional teams have deep domain experience in high-tech, capital markets, investment banking, wealth management, retail and commercial banking, asset management, exchanges, insurance, and payments, as well as cutting-edge technologies. Our 14,000-plus global employees, spanning 55 offices across 20 countries, are passionate about innovation and meeting new challenges.
Our team at Synchron is committed to pushing the boundaries of AI technology and delivering state-of-the-art solutions. We understand the importance of staying ahead in today's fast-paced world, and Gen AI tools are designed to give you that competitive edge. The future is here, and Gen AI is leading the way. Embrace the power of generative AI with Synchron Nexus tools.
In a world clouded with complexity and ambiguity, there exist significant opportunities for disruption and growth. At Tiger Analytics, we help our clients navigate this uncertainty, empowering them to move decisively through shifting sands, unlocking these opportunities. We work with our clients to strategize, design, and engineer a future-ready enterprise. At Tiger Analytics, we've been reimagining possibilities with cutting-edge AI and analytics, solving some of the toughest problems out there and building the blueprint for tomorrow. And at the heart of this mission is our battle-tested team of exceptional technologists and consultants. It's our unique expertise and character that enable us to create exceptional value even in hazy conditions. That's our Tiger gene. The Tiger gene is what makes us learn relentlessly, experiment without fear, seek help and offer help. The Tiger gene is what helps us uncomplicate complex problems, build for the future, deliver clarity amidst ambiguity. To our clients who are traversing a fog of uncertainty, we are not just a technology partner, we are a certainty partner, relentlessly seeking, solving, challenging and growing. Together, as we set bold ambitions and target extraordinary outcomes, let us experience the power of data-guided decisions, the potential of connected insights, the promise of an AI-empowered future. Experience certainty to shape a better tomorrow with Tiger Analytics.
Even before the world could start talking about AI and Gen AI, for the last 15 years, we have invested in AI with the pioneers in AI. We have built some world-class solutions around AI.
Wipro has been at the cutting edge of data science and AI for a while now. Wipro and I get to work across various and diverse industries, everything from agriculture to pharmaceuticals to healthcare to oil and gas.
So we are helping many Mang level customers in their transformation journey. So we have strategic consultants, we have domain experts, we have data scientists. So basically we do customer hand holding right from the inception to post-deployment stage.
We have more than 400 plus use cases which are live. We embed AI into the end-to-end software development lifecycle, as well as we are working with our clients to infuse AI into the operations as well, the application management services, infra management services, by bringing in the generative AI to enable an end-to-end transformation, autonomous operations for our clients, predictive operations for our clients.
Our responsible AI is taken extremely seriously, and we have typically 4 dimensions that we talk about. One is the societal dimension, the individual dimension, environmental, and technical dimensions.
So there's a wide variety of work that we get exposed to in terms of AI and solving various kinds of industry challenges, and that's the part I love most about. And Wipro offers a tremendous great learning environment, a working environment for us to learn every day and experiment on various things.
The amount of flexibility this company offers in terms of the working location or the working hours, that is why I feel that I could not find a better company to start my career with.
Apart from work, I just wanted to talk about the facilities that we have. We have a great creche over here, and my daughter goes to that creche. At the end of the day, we get to spend time together with the strays, and we can spend some time with them and can feed them. I feel this is something which is really unique and great about Wipro, that we are able to share this message of love to our next generation with all these small things that we do, and I feel super proud about it.
So it is understanding their aspirations, understanding their capabilities which they may not be aware of, and that requires observation, that requires passion to help the person, and that's what Wipro is all about.
It's an exciting place for people to come work here, work in cutting edge technology or solve real life problems and really transform the world as well. That's what we are.
And this is a great place for people to work, and me being an example of that. It gives you an opportunity to explore different domains, different technologies and different geographies, which can provide a very nourishing experience for the people. Working in Wipro is an exciting learning experience.
For me, working in Wipro is all about creativity.
Working with Wipro is innovative.
I find working at Wipro extremely impactful.
Working at Wipro is exhilarating for me.
For me, Wipro is a second home.
Even before the world could start talking about AI and Gen AI, for the last 15 years, We have invested in AI with the pioneers in AI.
Our responsible AI is taken extremely seriously, and we have typically 4 dimensions that we talk about. One is the societal dimension, the individual dimension, environmental, and technical dimensions.
And Wipro offers a tremendous great learning environment, a working environment for us to learn every day and experiment on various things.
Working in Wipro is an exciting learning experience.
For me, working in Wipro is all about creativity.
Working with Wipro is innovative.
At Google, AI isn't a tomorrow thing. It's a today thing. And sure, we can ask for answers to life's tough questions. But today, we can also ask it to do tough things, like ship that wood more efficiently, use satellites to reduce methane emissions, turn DNA into code to make drought-resistant corn. Oh, cool. It can spot and fill potholes, spot disease earlier, spot asteroids to protect Earth. It can create apps with just words and just hours. Today, Google AI can scan 100,000 lines of code in 2 minutes to spot and fix bugs. It can translate from code to code and is one step closer to speaking 1,000 languages, even whale. Today, AI impacts lives for the better and understands the world the way you do. Our AI spots threats 7 times faster, understands speech sentiment, helps prevent vision loss, predicts weather 10 days out in 2 minutes, translates thousands of pages in seconds, detects lead pipes to keep drinking water clean, eliminates paperwork so care is more human, generates from text, visuals, audio, and video, creates entire worlds from your imagination, creates this thing and that thing, a new thing, the new way to cloud.
Mathco began with a bold yet simple vision in 2016 to help enterprises unlock the full potential of their data and solve their most pressing challenges. We started as a small, passionate team of problem solvers, driven by the belief that data could empower businesses to think bigger and do better on their own. Self-sufficiency remains at the core of our offerings to enterprises. We strongly believe that we live in an age of hyper-personalization. Enterprises, in the quest for being digitally at the top of their game, often face critical challenges. Challenges that can result in millions of dollars lost or missed opportunities to earn them. They're looking to evolve while overcoming their own unique set of challenges.
We today engage with more than 60 plus global enterprises across multiple verticals like retail, consumer goods, pharma, technology, and many more to come.
We're here to enable them to make smarter, faster decisions with enterprise intelligence. It's not just about solving problems, it's about building trust both with people and the tech and creating everlasting value.
Our strength doesn't just lie in numbers, it's in the unparalleled expertise of our mathematicians. Our people are the heartbeat of Mathco. They innovate, collaborate, and bring ideas to life in ways that drive real-world outcomes.
Every individual has a space to take ownership, make an impact, and shape not just their careers, but the success stories of our clients.
Everything we do revolves around creating meaningful experiences, whether it's through exceptional delivery for our clients or the way we collaborate and support one another as a team.
Each mathematician's goal aligned with a larger mission to empower decision makers in global enterprises to own and activate intelligence.
Our goal is to scale Mathco from where we are to 10 times our size. 10x in terms of the value that we add to our customers, the quality of experts we have on board, and the capabilities that we invest in. All in all, we want to be a one-stop shop for all our customers' digital transformation needs.
Check, 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 1, 1, 2.
Synchron?
Hello, hello. We are starting in 5 minutes exactly. We have to open the gates, please. I will start introductions in 5 minutes. All right, welcome back after lunch, guys. Hope you are all having a great time here at MLDS 2025. Please settle down. We are about to begin the second half of paper presentations. Before we begin, I would request you all to keep your phones on silent, please. And we have lined up some very exciting presentations for you in the afternoon track. So without any further delay, let's begin. In the first talk after lunch, we will explore how autonomous AI agents evolve beyond generative models to perform complex tasks without human intervention. Through practical examples and insights from our speakers, attendees will understand how autonomous AI agents revolutionize problem solving across various sectors. Sobhan George Thomas is the founder of Arc1.ai, a pioneering AI solutions company, and JoinUs.team, an innovative platform enhancing team collaboration through artificial intelligence. With over a decade of experience in machine learning and data engineering, Sobhan specializes in creating AI-driven solutions that optimize business processes and fosters team synergy. Can we please welcome Sobhan George Thomas on the stage?
Hi, thanks for coming in. I know it's post-lunch, so let's actually start with the story, right? Before we start with this speech. Now, this is a controlled story, so my objective out here is thoda lunch ka heat reduce karna hai, right? So this is a story my grandfather told me, right? So there was this old man and his dog. They used to stay on the top of a mountain. And the old man at his old age found it very difficult to work, right? As in his youth, he could do only 1/3 of his work now. Now, as he was going through the forest, he found an old lamb. Now, in the hopes of using the lamb, he took it home and started polishing it. And suddenly, a genie comes out. Genie says, "Oh, my great master, I'm here to help you out. Any task you have, I'll fulfill it. You want to change the world into a flat earth, I'll do it for you. But I only have one condition. One and only one condition. If for even for a second I'm idle, I will swallow you." The old man, initially who was happy, oh, at this old age, my back is paining, everything is paining, I got someone like a son to help out. But when he heard the terms, he was a little shocked. But anyway, he said, "I'll die one day. Maybe the genie will swallow me. Till then, let's enjoy." But the fact of luxury, fact of comfort, is that once you get comfort into something, you fear death, you fear things. The same happened to our old man. The old man started fearing death. The genie started giving him the luxuries of life. The genie built a castle. Genie did every task that the old man said. Now, the old man, scared of his health, death, started plotting how to get rid of this genie. The old man said, "Go and count all the grains of the sands in the deserts." Genie goes out. After 3 years, comes up with a number. Damn it. So the old man says, "Go and count the salt content across all the seas." After 6 years, he comes back. Now the old man is like, "I am going to die now." Then his dog comes in. The dog, he sees the dog and it clicks him. He says, "Genie, straighten my dog's tail." The genie goes out, tries all methods to straighten that dog's tail. Till day it is said the genie is still trying to actually straighten the dog's tail. And the old man has died, the dog has died, the dog's kids had died. The genie is still in the position of actually straightening the tail. Right? A good story may not be linked with our speech, but I just wanted to warm this crowd up, right? So let's start with my small introduction. I'm a 2x founder. My last exit was a deep learning model in 2020. I made a document processing model, which I sold to a Canadian company. I currently work in Arc1 to create autonomous AI models that can actually automate certain industrial practices. So previously I was into open source contribution. GStreamer, I've done some contribution in GStreamer in my younger age. Further on, post 2020, I actually was active with a Canadian organization to help open source projects get funded, accelerate them, do certain DevOps activities with them. Right? So this is a small background about me. And currently I'm building something. We started with the hopes of building a platform. We are now kind of a service plus ecosystem kind of a thing that we are trying to build for larger organizations. So now let me take you to a scenario. You're at home and your washing machine is cleaning itself, right? And your clothes are getting washed automatically in the machine. Clothes are getting walking through and getting into the washing machine. Plates are getting cleaned automatically. Your window is getting swept, right? What does that remind you of, right? Usually it reminds me of, reminds me of Snow White. Snow White this is 1938, Snow White and the Seven Dolls, right? A very classic cartoon movie. Really loved it. I was not born at that time. I watched my recording, so I'm not that old. So what excited the 7-year-old boy in me was I started trying to train the squirrel that used to come to my window. Started giving him food. I was like, I'll make him do some activity, right? Seeing this movie inspires me to do certain activities. So if you see the movie, Snow White is actually doing through her songs and chanting the animals to do her bidding. This is a common human behavior. We, for the longest, have tamed the most dangerous beast, and we have started putting him or her in our verses. The great wolves, we tamed them, crossbred them, and now we have made a small chihuahuas, German shepherds. It is a human nature to bend the entire ecosystem to make it easy for us. May it be animals, may it be the ecosystem itself, the nature, and everything, anything. We even molded the human DNA to do it. We expanded our age. Where now most people can live till 100. There are humans who live till 100 unless and until something hits you, right? So the effort to actually be lazy is something there in our DNA. We are the only animal that can reason. The ape can actually do or imitate what we do, but to ask the question why is only the human species, right, that can do that. Pushing to that, we created AI models, right? It started not recently, but in the 1950s, where a small AI model created by MIT, right, in the 1950s, should imitate human conversation. Now, it will not create anything of something new, but it can imitate human conversation. These are rule-based systems that came in. Now, post 1918s to 2000, we started exploring in neural network, deep learning. We started building various frameworks. We started generating images, very screwed up images, but we started doing it, right? Now see what we have done, right? We've got models which can actually generate great realistic images. There are YouTubers who are actually now creating AI models to do the recordings, right? There's no human intervention in it, right? But the problem with generative AI is you need human inputs, right? You need it to say, hey, generate this, generate that, right? But there was a field that was working separately, which is called AI agents. Now, this is also something, I'm clicking the wrong button again and again. So these are AI agents which can communicate with the surroundings. Now, this is also started in, these are robotics, early robotics, which started with, again in the 1950s, you can see the first human robot it used to interact with its ecosystem, right? So AI agents, as we say, are basically something that can interact, understand the surrounding. Oh, I am in Mumbai, so thoda amchi Mumbai भाषा में बोल सकते हैं, या फिर I am in Bangalore, Namma Bangalore, you can say in Kannada. So it understands this ecosystem that it is existing. It takes certain inputs. It could be visual inputs, it could be text, it could be any type of input. And through its reasoning, it can come up with an output and interact with its environment. This is a difference between AI agents and basic generative AI elements that comes up. But there are now LLM-based AI agents, right, which are multimodal, model-based AI agents which can interact with your surrounding. You can just have to look at ChatGPT's 7 days, 10 days of ChatGPT, OpenAI conferences to see the growth we have gone in, right? Let me actually talk how it works, right? Basically, you have input coming up. For example, look at the sky. Do you think it will rain tomorrow, right? So it takes that input. It actually uses certain tools to actually do an API call. Hey, will it rain? What is the temperature? What are the probabilities? And it then reasons it out. It actually uses its memory to see, hey, this is month of May. It may not rain in Bangalore. Oh, it is Mumbai. There's a high possibility if the rains are uncertain, right? So it can reason and create certain actions. Now, these are models, the AI agents, which can not just evolve into a part doing a rule-based quotient, but also actually take decisions. So if you tell it, hey, can you, what is the performance of Ashok during Q1? Do you think his job was up to date, right? If the AI agent is connected to the various systems, right? It can actually give you a feedback. It can actually take certain actions. A group of them can do certain executions, right? So this actually is our animals that you see in the Snow Whites, right? But we couldn't tame those animals, but we have tamed an artificial being or artificial elements with non-human intelligence to do our bidding, right? The lazy DNA in human beings, right? So now that I've actually covered what is an AI agent, everyone is excited. Hey, how do I build one, right? How do I go and build these AI agents? Now, the good thing is open source is been growing and building these frameworks. These are some of the frameworks. Around 78 frameworks out here are open source. You can actually scan the QR code here there and take us as my gift actually. Now, this is not something I have actually made. I actually stole it from a Reddit post. So please. So you can scan there. It will redirect you to the original link. You can actually explore all these links. These are frameworks that a developer can use from LangChain or through AI to some of Microsoft's technologies, right? To some of the open source libraries that are there, which may not be famous yet actually, or been popular yet for the right reason, lack of DevRel activities, all right? So now this can help you automate 90% of your task, right? Now some of you may not know coding, right? If you're hoping that we can use AI to code, AI hallucinates a lot. So as a developer, I will not recommend. But good thing for you is we've got AI agent platforms. Now here, I have platforms from Postman AI agent platform, right? I'm not sure whether you're familiar with that framework, to some of the paid platforms. Unfortunately, only 12 of them are open source. Rest you may have to pay for them. Again, QR code is there. If you scan the QR code, you will also get productivity. If you don't want to build any AI agent, or like I want to use something that is already there, if you scan the QR code, you will find productivity AI models that are there. Something around, in each category, you will find these models. AI agents. Now, let's actually explore some. How do I, now if some of you are thinking of, hey, let me build something. So let me get you an example. Let's take LangChain, right? Again, this is from a tutorial that I've referred to. Here, the problem statement is actually, I sent you an email saying, hey, can I reschedule my meeting with you at 2 p.m.? Right? So the email actually gets sent to XYZ. XYZ is using that AI model. That is the use case. Right? So the email comes in, it gets parsed, right? It gets sent to the agent. Right? Now, agent will actually process it using its prompts. It will fetch data that is required based on the emailer who sent it, verify whether if he actually has any scheduling with our AI agent owner, uses a chat model which is similar to a LangChain model, and then parses which tool can it use. For example, it can use availability function or any functions that are there. These tools can be, there's a huge set of tools that it can use, and based on that, it can actually then give out responses to it. It can revert back via an email. It can revert back via WhatsApp. It can actually reschedule, do certain activities based on it. This is a basic, this LangChain version 0.1. So some of these elements have changed. Now, if you want to put it into production, you need to do caching and few other elements, but this will actually get you started if you're trying to start with something, right? So now here, now this is an old function, but I want to actually point out something called temperature. I usually get people asking, what is the temperature out here with LLM, right? It's like, if I'm in Ooty, I should put Utica temperature, or what is it? So temperature is usually how, if you give it a lower temperature, then it is like apna Shankar party uncle that I know. He's a very strict guy in my colony. Hey, Sobin, no, don't do that. Don't do that. But a teacher 65, once he has in the evening, he's a very chilled out guy. Chilla, chilla, chilla. He starts dancing in the terrace. So if its temperature is like that, right? If you put a lower temperature, as in low alcohol in Shankar party uncle, he is very strict. If you increase the temperature, he will tell chilla, 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 chilla. So basically the model will actually be a little more creative. It will give out some funny answers. Instead of 2 plus 2, it may give you dragon is 2 dragons or 42, right? If you increase the temperature. If you keep it 0, you will give you 2 plus 2 is 4. So the basic tool model that is there. Let me actually get into some of these applications. AI agents are coming into use in various platforms, from the automated robots to healthcare sector to customer care, right? I'll give you some of the examples that we are using. Yeah, this is something that we have been using. So this is a conversation. This is supposed to be a GIF animation. So this is a performance review that that is conducted, right? So the Sue is our AI agent. So Sue asks Jim's performance. If you have seen The Office, this is created on the Office characters. So you can actually see the response that the Sue gives out. You can actually interact. These AI agents can work like humans and start conversing with employees, taking feedbacks. One of our use cases, wellness management, right? So if most of employees get burned out, they lose morale and they move out of the company. So our AI agents actually send messages on WhatsApp, send messages on Slack or Team based on the organization deployment, and actually understand the employee's current state. So this is another example where we have the Sue is interacting with one of the employee to actually filter certain candidates, and Sue has filtered these candidates. Another example is actually an email conversation. So Slack conversation about Sue actually interacting with another candidate to candidate filtering. Unfortunately, the GIFs are not working properly. Again, over email, Sue is actually reconnecting with one of the talent pool employees to actually understand whether they are available for opening, and the candidate actually pushes out. What we understood in most of our deployment is actually, if you say, tell the employees that this is a bot, the success ratio goes down, drastically down. But if you humanize it and put characters into it and put a name to it, basically humanizing it, response comes faster. So one example I'll tell you. For the last 1 year, I do not have an HR person, but all my employees know someone called Ria Thomas, who's been actually contacting them and doing all sort of activities. I have not told my employees till last month that Ria Thomas does not exist. My experiment was whether people would react to Ria Thomas. So I created an image, I created a backstory, I created an entire LinkedIn profile around her. I made friends, AI friends with her. So if you go to her profile, oh my God, Ria is like worked in this. She's communicating with people. So any of my employees felt that Ria is actually an actual HR. But she's been doing hiring for me. She has an it actually, it has been doing hiring for us. It has been actually approving leaves. It has been talking to candidates in terms of if they actually sign out late, is there any issues? It is actually communicating with them. One of my employee actually wanted to actually gift Ria for the emotional support that she sent, right? Candidates get rejection email and they say, send her thank you letter. This is the most empathetical letter that I found when I got rejected. I put these images on LinkedIn on her profile. The truth is, as long as you don't, it's about your perception with the model or the AI agent, right? So for the last 12 months, I've been actually experimenting on it, and it has been a success, right? It can create, now this is not replacing any job. What I understand after all our deployment is, we have not moved people out from their jobs. We have promoted them. Now an HR who is actually doing all these operational work, right, is now promoted to a general's role. She has an army of 100 AI agents in her command. She can do her strategic thoughts, ask for a hike, spend time with her family, right? All the mundane work that is required in terms of operation is moved to the AI. And These are not like bots. These are super human-like, or no, I shouldn't use the word human-like. These are more autonomous agents that can do these tasks. Similarly, there is an employee in my company called Priya. Now, Priya has been doing sales for us. And all my employees think she's an actual person because Ria interacts with them on Slack. So, so the perspective is actually even another employee of mine asked me, when is Ria's birthday? Because we are not celebrating. I even had to put up a date for her, right? But the matter is actually automating these activities which are mundane so that humans can actually move into more better things to do, right? Rather than these mundane activities, right? In terms of saving time, I will give you an example. One of our customer reached out to us, said, hey, Subin, we need an app clip developer. Now, app clip is a small feature in iOS development. It's not a very crazy feature that everyone uses. So we had to actually go in and interview around 1,200 candidates. Now, in a regular process, you will have to spend 600 to 1,200 hours calling the candidate, because if you ask the candidate, hello, you know app clip, the candidate will Google app clip. I know app clip. Yes, I know app clip. So then you spend interviewing them, you understand that he does not know app clip. He just Googled it and found an app which is called app clip, and he's talking about it. Now, that is a waste. It's a waste of time for the candidate also. He goes through the whole process of preparing, and finally he gets rejected, right? So what did we do? We reached out to all these candidates over WhatsApp. In a very empathetical manner, we asked them questions to validate their claims, and we verified them. And finally, we got 20 candidates out from there, and the employee hired 2 people instead of 1, saving a lot of our time, saving a lot of candidate times also. Again, this is supposed to be a GIF. These are certain communications that Sue is having with a vendor actually in terms of payment. These are certain interactions she is having with regards to this is in regards to a candidate who has logged in, right? It's his first day. Sue is actually communicating with the HR manager to say that the person has accepted his offer letter, and we can expect the first day agenda with them. Now, what are the ethical issues with this? Certain issues that I've seen with our startup is biases. So candidates from certain states, right? We started rejecting them because of certain issues with background verification and things like that, right? After a good number of months, right, the AI started rejecting these folks automatically based on where they were located, right? Based on the names and certain elements, which created certain biases which we had to remove, which is another issue with AI agents that we have to, when we are building up, we have to make sure those elements don't come up. Transparency is another issue. Misuse of AI agent, deep fake is a bigger example of that. And now, ethical issues apart, there are certain security issues that are there. Now, security issues are if you don't deploy it properly, if the models are not deployed, trained properly, fine-tuned, the agents are not programmed properly, the prompts are not guarded properly, there are issues of data poisoning that can come up. Prompt injection, where you actually put an input to understand the internal operations and prompts of the AI, of the ecosystem. And AGI is not there in this list. I don't look at that as a security issue, but certain regulations are not in place in terms of policies, where it can be used, who can message. These are certain security issues that comes into play. finally, what is the future, right? Is it a utopia where everything is like the Snow White? Or is it AI is going to destroy us? Uh, Skynet is going to come in, right? So that we can only determine what we do at the present. Based on our past behaviors, we can understand what what the AI revolution will come to, right? And I hope this was a good session, right? And you had some takeaways. I wanted to do certain programmings and GIFs were not working, unfortunately. So you could have seen the demo work. So yeah, so this is me, Sobin George Thomas. Hope you enjoyed the session. Thank you.
Sobin, are you ready to take a few questions?
Yeah,
One
sure.
or two?
Sure. Yeah.
Instead of replying to all messages immediately, maybe reply to some messages, lower priority messages with some delay to make it more human-like. Does that make sense?
Error. So this is another finding that we did actually. What happened was a candidate was communicating. So we usually deploy it for our customers. And we monitor the activity. We do it as a service. So the candidate got a response at around 12 at the midnight, right? And the message was immediate, right? And certain rejections happened in seconds, right? Because so people got hurt, right? Feelings got hurt. These are, so certain things, right? We have to, so these are not model issues, morely we have to implementation issues, right? The way we implement it. So we slowed down the model to how it works, how the responses have to put deadlines on timings. So it is not going to message at 3 in the morning, right? And when rejection. So there is a delayed, it does 6 seconds rejection, our system, but we have delayed it to make a 2-hour rejection. So any other questions?
Yeah, I have a question. One second. So it was very interesting that you pointed out the ethical considerations here. Just wanted to identify if you have things in place already to do it in runtime, or how do you manage to assess the bias and fairness? Like, how do you do it? Because I read about a legal lawsuit that had been set up, right, for iTutor group, I think, who had to pay a lot of money just because the AI algorithm rejected their lady's application and she sued back the company. So how do you deal with such things?
Yeah, so see, the entire framework itself is pretty new. LangChain is, we don't use LangChain, but LangChain itself, which is a popular one, is it's still not version 1, it's 0.03 version, right? So we actually have put certain conditions in place, like the rejections, like the way emails are going, even the way we reject candidates, because we have to manage a talent pool. Usually, usually people send a flat rejection. The candidate is pissed off, he's not going to apply now. So those ethical considerations have to be observed. Unfortunately, there's no single framework to do it, because based on conditions, right, it changes. Yes.
We will take one last question.
No, we are not.
You're not?
No, not.
Okay. Just wanted to ask, what's been your experience across the various agentic frameworks? Which ones do you think are the more mature ones today? And how would you answer that from an open source perspective as well? Thanks.
Okay. So when we started this experiment, LangChain was pretty new actually. My experience with open source framework, I did not want to jump it. So for example, version 0.1 is a lot of functions have actually changed, right? So we started building our own framework, and it's not great as LangChain is currently now, but it actually does our trick, right? So if you are actually starting a project, LangChain is a better option. True AI is also a better option actually. There are frameworks, and there will be frameworks coming, new frameworks coming as the model matures. Thank you.
Okay, he's a storyteller, he's witty, he's funny. and he is the co-founder of Arc One. Give it up for Sobin Thomas, people. In today's fast-paced digital environment, DevOps teams are under constant pressure to deliver software quickly and efficiently. AI Ops is changing the game by bringing AI and machine learning into the world of IT operations. To present the next talk, we have Nasiullah Chaudhry, a leading voice in cloud computing, DevOps, and AI, and the founder of Cloud Champ Solutions. As a Docker captain, HashiCorp ambassador, and AWS community builder, he combines expertise with innovation to help companies harness cutting-edge technologies. With 130K plus subscribers on his YouTube channel, Nasiullah shares impactful insights on cloud, DevOps, and freelancing, empowering professionals to excel in the tech industry. Please welcome Nasiullah Chaudhry on the stage.
Good afternoon, guys. I am younger than most of you, so please forgive me if I make mistakes today. But today's topic is about AI Ops. How many of you here know about DevOps or cloud? Okay, that's great. So I work as a DevOps engineer as well, and this is something new. With rise of AI and ML, companies are now shifting to AI Ops. You might have heard terms about FinOps, DevSecOps, DevOps, and so on. So today we are going to be learning about AI Ops and how it can help you, what are different tools. We will also look at some interesting case studies to understand how companies are actually using AI Ops to save money. This is something about me. I am a DevOps consultant. I work as a freelance DevOps consultant, but I also have my own company named as Cloud Champ Solutions, where I offer clouds and DevOps services to companies. I have a YouTube channel where I teach cloud and DevOps. It has around like 139,000 subscribers, not updated here, but yeah. And I am also a HashiCorp ambassador, the company that creates Terraform. I'm also a Docker captain, a Sync ambassador, and AWS community builder. This is my social. If anyone wants to connect with me on LinkedIn or wants to subscribe to my YouTube channel, can take a picture or scan this. Okay, let's learn about AI Ops today. So imagine, before I go on to this slide, I work as a DevOps, so my day-to-day job is to make sure applications work faster, make sure that they are not, they're secured, they are scalable. So imagine you're working in a company, and someday your critical business application suddenly crashes, right? Your manager is not happy, your CEO is not happy, and you're losing a lot of money. So this is a very common scenario in most of the startups and companies who don't implement DevOps properly. If this is the case, you will lose a lot of money, right? So there's going to be a war room. Companies, CEOs will ask you to start working on this issue and start troubleshooting it faster. So let's say this is you trying to diagnose what the problem is. And because you are a human and you might or might not have much knowledge about your systems, it might take a lot of time, right? You try to restart your servers. You try to delete some things to make it work. But if you don't have much knowledge, obviously it will take a lot of time, which will make you lose a lot of money, right? So you go ahead, try to do more testing, more diagnosing, going through the logs manually. And if you are someone who works into DevOps or in operations, you will know how difficult it is to go through the logs and to find out the real problem, right? So this is a common scenario and the things that we faced every day. And after a lot of troubleshooting, hopefully it might work, or you have to spend more time. So let's say it's working now. So the problems we face here is, if you work in DevOps, you'll get a lot of alerts depending on how you set up your observability. If you have metrics for your servers, for your databases, there are going to be a lot of alerts. So this is a bigger problem. And most of us, like we at Cloud Champ Solutions, whenever we set up observability for a company, we try to mitigate or keep the alerts as low as we can to make sure we are focusing on the important alerts that are responsible or actually beneficial for the company. So this is one problem where you have a lot of alerts for your application. Second problem, whenever your application is down, there is going to be loss of cost. There is going to be, customers are not going to be happy. So there can be a chance where your customers are going to move to your competitor. Third problem is, as a human make mistake, insaan hi galti karta hai, as we say. So if you are a human, obviously you might face problems or you might make mistakes. The solution to this is AI Ops. So what is AI Ops? Let's understand. So AI Ops uses AI and machine learning to understand your data and to make sure that you solve your problem faster. This is Gartner's definition of AI Ops. Gartner says AI Ops combines big data and machine learning to automate IT operations process. All of you here know about big data, right? And also machine learning. So I'll also explain you how this works, what are key components into AI Ops, how companies actually use AI Ops, and how things happen. So these are some key components, or you can say pillars of AI Ops. It starts with data ingestion. So you have different servers, you have different databases, different systems, which will push data, right? So you're going to get a lot of logs, metrics, traces, important information, which you might store in a particular storage, maybe S3 bucket or some other storage solution. So you collect data, you then store that data into a large volume of structured or unstructured data. Then you run machine learning and analytics on it to understand what is the problem or common issues that we face, right? After that, we will make sure that we are only looking into important alerts that are responsible or beneficial for our company. Lastly, when the main thing is, we don't want to just understand what is the problem. We also want AI to automatically solve it, right? So the next two steps are finding out the root cause analysis and also understanding how to automatically solve this whenever a DevOps team is not online. So this is the actual process. And the 3 steps, if we short it down to 3 steps, it collects the data, understands through machine learning, and lastly, act on it to automatically solve the problem next time it occurs. So the machine is going to learn from the mistakes, and it will know what to do or what to change to make sure it works. Now, here are some interesting case studies from big companies who are already using AI Ops. Netflix, a very popular streaming platform, uses AI to automatically scale their servers. So yesterday there was a talk about cloud and DevOps by other speaker who would also mention this. But Netflix uses AI a lot of, at different places. Netflix are very good at using cloud. They use it to automatically scale their servers depending on the load coming in. So they have saved around $1.5 million annually doing this. Next is JP Morgan. JP Morgan used Splunk. Splunk is a very popular observability tool. JP Morgan uses Splunk to reduce false alert. If you, I'm not trying to stress much about it, but this is a very common problem where companies get a lot of alerts and they spend a lot more time, which they should be spending on creating the product. So this is a very common use case on how you can reduce alert using AI Ops. Splunk is one of the examples, but there are a lot more tools which we are going to be looking at in the next slides. Then we have Etsy. I hope everyone knows about Etsy. It's another very popular shopping product, you can say. They also use AI Ops to reduce their mean time to imitation for 2 hours to 15 minutes using Dynatrace. Dynatrace, again, is an observability tool. Similarly, Airbnb uses Dynatrace again to reduce their bugs. Zomato, Indian brand, uses AI Ops to make sure they place their agents at the right spots to enable faster deliveries. And lastly, we have TCS. I included these two because these are two companies that we are very familiar with. And TCS uses AI to accelerate their product development by 20%. So you can see this is a pattern now. This is not the future. It's something happening today. So companies should be adopting AI for their applications. Next, let's look at some stats. So according to Gartner here, the AI Ops market is going to grow up to 19.93 billion by 2026, which obviously would be a lot more when we go into 26. Then there is another metric here where we can get 157% ROI if you use this AI in our product. And lastly, 80% faster resolution if you use AI. Here there are some important or maybe common AI tools, observability tool that uses AI so we have Splunk, Datadog, ServiceNow, Dynatrace, New Relic, Mookstuff, Big Panda, and PagerDuty. Most of them are paid, obviously, but there are also other options which you can use to understand how AI uses, how observability tool uses AI. So here is a name. This is what they are used for, and these are the companies who use them. So we have Cisco using Splunk, Airbnb using Datadog that we saw already, and so on. You can take a picture if you want to read about this later on. Now, this is another case study that is very popular, and I read this in a blog, so I tried to add this in my slide. Vodafone, which is the mobile company, had a very big problem where they were not able to manage the global network and they were facing a lot of issues. That's when they uses MOOCsoft. MOOCsoft is what we saw here. It's a automated event correlation and incident management tool. So they use this, which resulted them to increase faster solutions and reduce in the network downtime. These are some best practices when using AI ops. Obviously, you need to make sure that you're putting correct data so you get correct results. Whenever you use AI ops, make sure you follow these best practices. With new tools coming in, like DeepSeek, which was very popular a few days back, is now banned in some countries because it does not follow policies correctly. So you need to make sure that you're using best practices, you are putting correct data, you are defining prompts or you're defining actions properly so that it can give you accurate results. Right? For job roles, obviously we are all concerned about this. What jobs can be seen in the future? So we have jobs like AI ops engineer, which is a combination of DevOps who uses AI. So all the tools that you saw, a person who knows all these tools could work as an AI ops engineer in companies. This is a small range, but obviously the pay range would be different, and it could be more depending on the company you're working for. Data scientist is again an emerging role. And lastly, we have cloud DevOps engineer. So these are some job roles you could expect with the AI ops market growing. So these are some references. I took references from these slides. If you want to read more, you can always take a screenshot and read from the blogs here. So I completed my slide very quick because I speak fast. So if you have any questions, you can ask me. I think there's no questions. Oh, all right.
Can we have the mic for him, please?
You talked about a lot of companies here who are using AI ops and all, right? So that's we are aware of.
Okay.
What exactly they are using internally is what I think we are looking forward. For example,
I wanted to know that as well, but they don't release this data on the blogs. All I know is obviously every company uses AI. The first startup that I worked was also using AI. I don't have any internal.
I'm not asking you to share their secret sauces. I'm saying, what are the best practices in AI which you think about using the generative AI kind of tools and all that? Which usually people, for example, you might be writing some blog somewhere, right? And maybe channels and all. And you're already part of DevOps, right?
One of the best practices, sorry to interrupt though, one of the best practices never to share, like people do this often. When interns work in a company, they try to put down all the code, which might include some secrets and stuff, on the prompt to make it easier for the AI model to write the code. That could be one of the best practice. Does this answer your question?
To be honest, no.
Yeah, please repeat once again. I'll try again.
So I'm checking it out. For example, you were talking about AI ops means inclusion of AI technologies in your operations, and you are part of the DevOps engineer, right? For example, think from that perspective. If you need to look into, for example, very less false positives and all that, even correlation you talked about, you mentioned about the noise reductions and all that. So what exactly you would be doing it if you know all those AI skills and all that? Okay, I just try to rephrase my question about what exactly the best practices that people should start thinking, irrespective of going for Datadog and Dynatrace. Internally, if I need to implement something using generative AI.
One of the examples I could give you is we were working for a company which had too many alerts, and we used to get a lot of alerts on the Slack, and developers or DevOps engineers were more focused on the alerts, which wasted a lot of time for us, right? So we tried to lower it down, and this is what AI ops can help us to do it. We can make sure that we are solving the right problems which are actually helpful for the business. So using AI ops, you can train your AI models in a way where if something which is very common and occurs often, you can train them to automatically solve it rather than you as a human interacting or solving it.
Okay, thank you.
I can give you examples later on.
We can discuss more offline. Yeah, thank you.
I hope there's no more questions. Okay.
Hey, hi. So my question is like about like in DevOps, like generally we do the edge deployments also. Like, so I'm coming from the manufacturing industries where we have the multiple edge deployment, like the computer visions and all these things. But I want to know from your sides, like how the AI ops can be help me to solve your problems with the edge deployments of your any kind of things like.
It all depends on your use cases and your.
Anything like you're talking about AI ops is kind of a IT like which help you into the solving your logs and all, right?
So what? Okay, I'll ask you a question now. What operations do you do on the day-to-day basis, which is taking a lot of time for you?
So normally what happens to be the when your models will retrain on the new data and anything is going to be deployed on your edge, some kind of a problem is happening into the edge part. In that case, what we have to be take care of with the AI ops, like
What problem did you face?
it's like deployments on the edge part, like if we are using the NVIDIA Jetson and anything like. So where how to solve that any kind of deployments and
Not everything needs to be an. Are you using any automated solutions or tools?
Yeah, so we generally use like Azure DevOps kind of things to be
Okay.
deployed on our Jetsons and all.
And it's not working for you?
Sorry?
Is it working for you or not working
It
for
is
you?
working. Sometimes it gets like breaks between your networks calls and all these things.
Okay. I'll have to check this out. Obviously, I don't know much about this. Please.
Okay, we'll let him go for now.
Hello.
Thank you so much. Thank you, Naseerullah.
Hello.
Hello. Who's
I
there?
had
Yeah, sir. Go on.
Okay,
I
one
had a
last.
question. Yeah. So you have mentioned like to some extent it auto resolves issues. So in your experience so far, how much how much percentage it has been able to remove human from the loop?
I'll say around like 20% or so.
Because
Not much.
certain issues cannot be auto resolved. Like
Obviously,
suppose
yeah.
I used to be a PL SQL developer 10 years ago. At that time, if an issue comes in some job, we had to delete certain data and then restart the job. So those things I don't think that these agents can do.
Yeah, next thing that the previous speaker talked about, the AI agents, you could actually train them, but there are some use cases that obviously you cannot ask AI or auto-resolve it.
But you can't
these
ask
are
them to
about,
play with production data, right?
obviously, yeah, not. You have to obviously test it out, and if it's working for you, then you move it into production.
Yeah.
That's right.
I'm talking on production only.
Yeah, I'm sorry.
Yeah.
Okay,
Thank you, guys. You guys have
Thank you,
been a
thank
lovely
you,
audience.
thank you, Mr. Chaudhary. Thank you. Please, big round of applause for him. Okay, so our next talk begins in Hall 3 at 4:15. Feel free to grab a cup of coffee and come back. I'm sorry, 2:15. Okay, settle down, please. Let's move on to our next session quickly. So in this session, we will explore the latest trends, tools, and techniques in data engineering and provide practical tips to improve workflows and stay ahead in the field. This session is going to be the perfect place for anyone looking to enhance their knowledge and skills in data engineering. Our presenter, Darshil Parmar, is the founder of Data Vidya, a platform dedicated to helping individuals upskilling in data engineering. He's also a content creator running a popular YouTube channel with 160K plus subscribers, engaging a LinkedIn audience of 110K followers and connecting with 30K followers on Twitter. Evidently, Darshil is passionate about sharing knowledge and empowering aspiring data engineers worldwide. Please give it up for Darshil Parmar and welcome him on the stage.
Audible? Yeah, nice. Good afternoon, everyone. Thank you for joining. My name is Darshil. And again, this is the MLDS event, but I want to talk about the data engineering. So do you guys know about data engineering? How many of you know? Can I? Okay, awesome, awesome. Like you do have the basic understanding. So the talk I wanted to prepare around was like the trends, like where are we moving, right? AI is happening. With AI, a lot of things are getting developed, new approaches, new things are coming. So I'll start with the basics. I'll lay out the foundation for the history, what we used to use before, and then we'll move forward with the trends and where the industry is going. Okay? So a little bit about me. My name is Darshil. I'm a founder of Data Vidya. It's a platform for anyone who wants to upskill, become a data engineer, get a job. And I've been working as a freelancer for the last 4 to 5 years. I've worked with like more than 25 clients around the world. I provide them consultancy, build the data infrastructure, go from migrations and everything. With that, I also like teaching, right? I've been doing YouTube for the last 3 years. If you are someone who want to, get started with the data engineering or want to stay updated, you'll find me on YouTube and also on LinkedIn, right? So if you can just scan the QR if you're interested, and you can connect with me, all right? So data engineering market is the first thing that we need to understand because see, the AI hype is going on, right? We have data scientists, machine learning engineers, and everyone. But behind all of this are the data engineers who are actually collecting data from all of the different sources and making things happen, right? All of the end result that you see on the dashboards, the machine learning models that are going, recommendation system, everything that is happening, the backend is actually a data engineering, and it is a big field. We'll understand the history also, what we used to use before, and how the cloud computing came in, made the storage system much cheaper. Also, the computing is affordable. So you can process large scale of data using new frameworks like Apache Spark, build large scale pipelines using Apache Airflow, just to orchestrate all of the data coming from multiple sources and bring them onto the one location, right? So the data engineering market, like the last year, AIM published one report about the state of data engineering, where the data engineering is moving. And it is going to cross 100 billion market cap by 2028. And it makes sense, right? Because as the data is growing, right? If you have heard about like in the last 2 years itself, the 90% of the world's data was generated. You keep reading all of these statements around the internet. So as the data is growing, we need people who can manage, process, and make sense out of the data, right? Because garbage in, garbage out, we all know, right? If you put the garbage into the AI models, you are more likely to get the garbage output. So the future is bright for data engineering. There are some AI angles to it, like automating some of the system, and we'll talk about that, how AI is also bringing revolution around data engineering by automating some of the stuffs. Yeah, so this is the big data landscape. Hundreds of tools around different segment. If you just go on the internet and if you see the PDF file, you'll get the clear image. But you will see around like for the infrastructure, we have like a lot of tools available for the machine learning, for artificial intelligence, DevOps, everywhere. We have like bunch of tools. And you don't really need to know all of the tools, right?
there are some specialized tools that we use for data engineering, just like that we use for AI, machine learning, and everywhere. So we'll be talking about that. I'll start with the foundation first. We'll clear the basics, some of the history, and then we'll talk about some of the tools that you can learn, okay, explore, in order to, if you want to understand the data engineering. Okay, so this is the agenda, all right? We'll understand about, it's working? Oh, it's not working, okay. It's not working. Yeah, okay, it's working. Yeah. So first we'll talk about the basics of data engineering, where the data engineering fits, life cycle data processing, and data engineering 2.0, which is where we are moving right now, right? Going from ELT to ETL to ELT, like open table formats, unified data platforms, real-time data streaming, and AI-driven data engineering, little bit about it. Okay, so introduction to data engineering. Again, we know data comes from multiple sources, and we need to understand this is that everything that we are doing right now is only for the businesses, right? You can use any fancy tool in the market, you use neural networks, doesn't matter. If you can generate value for the businesses, then everything you are doing makes sense, right? If it does not have any value at the end, everything that you're doing is completely useless. You can make fancy dashboard, you can make best machine learning model, but if it does not increase the revenue, improve the customer experience, all of this is useless. So this is how the data engine actually goes, right? You have the application end where users interact, the data gets generated. Applications can be anything, e-commerce platform, Instagram that we use. Every click of the button, the data is getting generated. And there is a middle layer. We'll talk about it. And at the end, we have the final layer, which is dashboarding, which is what the business stakeholder uses, and machine learning models at the end. Between, we have like this, which is at the end, we have the value. Value can be anything, again, improving customer experience, improving profits, understanding the bottlenecks, and trying to remove them. There's a data science layer, okay? But again, there is a thin line between all of these things, but we have data analysts, machine learning engineers, data scientists, and before that, we have the data engineers, right? So we have data coming from multiple sources. Data comes from application, sensors. So in the case of e-commerce platform, we know, right? If the truck is moving from one direction to another direction, there are sensors attached to the trucks. So all of the data needs to get tracked, all right? So they go on to some of the Kafka stream or some kind of system. So the streaming data is coming, web application, analytics, all of these data are coming from multiple sources. And you want to make sense out of them at the end. So there's a whole process that goes behind, and that process is around data engineering lifecycle, all right? We have the generation, okay? This is where the data actually gets generated. This is the middle layer, which is the ingestion, transformation, serving, and the underlying foundation is the storage. And then we have the final layer, which is serving layer that we call, which is analysis, machine learning, and reverse ETL. You can put the data back. And under all of this, these are some of the things that make these things happen, right? Security, data governance, architecture, data ops. You have the software engineering orchestration that actually builds the data pipeline at the end. Okay, so we'll understand all of these components one by one first, okay? We'll lay the foundation, we'll go on the basics so that you can understand the trends, what is shifting, right? Because this is the core foundation of data engineering. This is the complete data engineering. What we are actually doing is that getting data from one source and putting it somewhere else. But between these two things, this is where the actual data engineering happens, okay? All good till now? Yeah, awesome. So data generation, we already talked about this. The data gets generated from web application. We have RDBMS system. We have sensors, web analysis, and surveys, APIs. This is where the data comes from. Again, very basics. I'm like trying to go from like level 0. What happens? All of this application data actually gets stored inside the databases. Databases can be PostgreSQL, MySQL. These are the core databases that we use. And then you can use SQL to query them. Now, in data processing system, we have two things. One is OLTP, and the second one is the OLAP, right? Now, these two systems are built for the specific use cases. Now, a lot of modern databases, if you look, they support both, right? They also support the OLTP transaction and also the OLAP. But this is how it started. OLTP are the online transactional processing. The databases like MySQL, these are row-based, right? So if you want to apply the CORD operation, like create, read, update, delete, these systems are very good for that. So on the application side, you can connect to these systems, store your data for the faster transaction. But let's say if you want to answer some of the questions like what was the last 3 years of revenue compared to this year? Or how did we do good in this particular product category compared to different region? Like some analysis related questions. I tried running this query in my first job, and it actually took the entire database down because these OLTP systems are not actually designed for that. What it will do, it will scan each and every row from start to end. So if you have, let's say, billions of rows, it will scan everything. And if you are just aggregating on 1-2 columns, then it will pick the 1-2 columns, and then it will give you the result. So these databases are not for analysis. We have the OLAP systems, and these are mainly column-based. So if you just want to query onto 2 columns, you can easily query that, and you will get the result within few seconds. Depends on the database that you're using. Okay, so this is between OLTP versus OLAP. Now to make this shift happen, right? Most of the data comes to the OLTP, right? We understood APIs, web sensors, analytics, RDBMS system. So from all of this data, we do the first process, which is called as the extraction. Extraction can be simple, like you connect to the API, you write a code in a way that every 5 minutes, every 10 minutes, or few hours, you extract the data, which is basically you pull the data, and you can store that to any particular location, like object storage like Amazon S3. Okay, then comes the transformation, and then comes the data warehouse. Data warehouse is finally where your data actually goes. And how do you put your data into data warehouse? It completely depends on what businesses really want, right? You can't pick any random columns and directly put it. So this is a transformation layer. This is where you actually write the logic. There are like, you can use Python, you can use Apache Spark, you can use Airflow to create the pipeline in between, and then store your data onto data warehouse. And then the serving layer. This ETL pipeline actually is the same thing as a data engineering lifecycle. Okay, the two ways we create the pipeline. One is the batch processing. Pretty simple to understand. You have like chunk of data coming. So every 4 hours, every 1 day, every week, depending on your use case, you can use that. And second one is this real-time data streaming. Okay, we'll understand that. So again, at the end, what we are really doing is copying and pasting the data somewhere. But the data are so complex. Right? It's not just like you can copy and directly paste it, right? You have to remove garbage values, you have null values, a lot of things are coming. So you have to take care of all of these things. And this is where the data engineering actually gets complicated in the real world. On paper, it looks that, okay, it's pretty simple. But as you start digging the data, you have to go onto the individual row level to understand the garbages and remove them so that it goes into the machine learning model and extract some of the values. Again, all of these things that we do, we have the tools available. So you don't have to worry about it. Okay, so some of the basics are clear, data engineering basics. I'll talk about this 2.0. First is moving from ETL to ELT. Now, there's a problem with ETL. If any one of you are from data engineering background, do you know what could be the problem with ETL and why we are moving to ELT? Anyone? Okay. Yeah, that is the one point. Anything else? That we can handle into the transformation only, right? So we don't have to worry about that. Anything else? Data volume, we can handle it. ETL is for that only. We are structuring data in ETL itself. Again, data is coming. The transformation layer is for that only. I want to structure all of my data. Why? It's just like the order is changed. But why? We can handle that again. Very close, yeah. Yeah, that is right, raw data, we need the raw data. Why do we need the raw data? AI is a different guy. Let's tackle that afterwards. But this is just a framework thing, right?
No, the cost of the operation, if you take here,
yeah.
See the cost of operation, doing the transformation and then loading, it's not necessarily that I need to do the transformation on entire data sets.
Yeah.
So wherever I have loaded the data, then I can do the transformation. It will give an effective cost penalty.
Very close, yes. So that is the same thing, right? What happens is that when you do ETL, you have to process, don't think about these are like 1-2 GB of data. We are processing terabytes and petabytes of data. These are very large scale and it requires a lot of cost, effort, time. You have to write every logic from the scratch to make it happen, right? Now, in case someone comes and the data scientists or machine learning engineers, and they're like, okay, you gave me 5 columns, I want to add 1 more column. What will happen? I'll have to first modify the schema for my data warehouse, so I'll add a new column. Then I'll again make changes in my transformation logic, and I'll have to backfill all of the data again. Again, we are processing terabytes and petabytes of data. So that process will take time. These are some of the challenges that keeps coming, right? You have to keep modifying data. So every time data scientists, machine learning engineers will make requests to data engineers, like, oh, we want to add these 5 columns. Can you modify the data type to this? I want to create this new table. So this process keeps happening. It is very tedious. Like, again, you will be spending a lot of money behind the infrastructure, time wastage, and everything happens. So what they did, let's just reverse it, right? Because in ETL, you have the access to very limited data. All the data that got transformed, you can only access that based on the logic. But what if you do ELT? Data are coming, you directly dump them onto the data warehouse. These are the modern data warehouse, like Snowflake database, if you have heard about it, right? Over here, you have the Google BigQuery, if you are on GCP. You have AWS Redshift. These are the modern data warehouses who can handle structured, semi-structured, and unstructured. Before, we could only store the structured data into the data warehouse. That is the reason we now do ELT, where you dump all of your data onto the data warehouse, and based on your use case, okay, I will write my transformation logic, and the modification is pretty simple, just writing SQL queries. You can directly query your data and get it done, okay? So this saves a lot of time. Now this is where we are moving. Like, a lot of people are trying to remove the transformation layer. These are the new startups. They are like, we'll change the approach. We want to build a company. I will try to modify things. And they are coming with a lot of products around this. Okay, so we are moving here. So again, why ELT? Scalability and performance. Okay, so a lot of modern cloud data warehouses supports that. Flexibility in data transformation. Okay, so on-demand requests that if you want to get any row and column, even machine learning engineers and data scientists can do that. So we don't really need data engineers at that place. Then cost-effective, supports diverse data types. Now again, in the data warehouse, you are limited to a structured data. Now you can support anything. And the faster time to insight. Again, you're not wasting time to building the ETL pipeline again. You can directly get whatever you want and move forward. One tool that is leading in the market is called Data Build Tool, DBT. The architecture of DBT is like this. Once you load your data onto the data warehouse, like any of this is the Snowflake, Redshift, Google BigQuery, Databricks, and I think this is a Teradata, okay? You can connect DBT, and they have their own modeling system where you can get this raw data, do your development, which is like writing script, understanding, do the testing around that, deploy them onto the system, and then you can get all of this structured data to you that can be used for BI, ML, operational analytics, up to you. And the process of modifying this is pretty easy. It's like changing a simple code, okay? So it saves a lot of time. Now, second thing, all good with the ETL to ELT, pretty simple. Second thing is the open table format. Now, this is a meme. I liked it because every time we do something, we usually store our data onto the S3. Object storage is like the centralized location. You just dump it on the S3 and then you figure it out, like images, audio, video, whatever you want to do. Open table formats are actually built on top of that. So to understand the open table format, which is a new term, we need to understand a data warehouse and data lake. What is the difference between? So we understood about the data warehouse already, right? It requires ETL structure storing. So every time you want to modify something, you have to raise a lot of requests. To tackle the data warehouse, before open table format, data lake came. Anyone know what data lake is? Yes. Anyone else? Different definition? Yep. So yeah. So data warehouse, we call schema on write. Because when we are writing, we are defining the schema. Like an integer, varchar, whatever the schema that we want to put. Now, again, businesses were facing the issue, right? Operations are needed on the data warehouse. I want hundreds of columns. My requirements keeps changing. Machine learning engineers will be like, I am doing feature engineering. I need more 10 columns. I want to remove this. I want to add this, rename this, whatever it is. They were like, let's just dump all of our data onto this object storage like Amazon S3. Okay, it's like centralized repository. And as per your requirement, you can do schema on read, right? While you're reading it, you can enforce the schema that you want, and then you can do all of the operations. Now to make it happen, this is a simple architecture on AWS, right? You have your data stored onto the Amazon S3. there's a tool called as AWS Glue. So you can run a Glue crawler on top of it. It will just read all of the files that are stored onto your Amazon S3, build a catalog around it, and you can query it using Athena. I'll just give you the brief screenshot. So first is like simple files. So this is Amazon S3 bucket, and you can see there is a simple CSV file available. This is the table created onto the AWS Glue, which is like a cataloging system. Cataloging basically means it stores the information about your data, right? How many columns you have, how many rows you have, the data type, all of it. And then this is Athena, where you can see the actual table. You can query it using simple SQL. So in this process, we don't want to do ETL anything. We just store our dump data and query it. But there's a problem with this. Any guesses? Oh, sorry. Go forward. Yeah, one is the asset properties. But any other problem with the data lake? What do you see? What do you think? Okay. Data lake. Yeah. Yeah. Got it. Anything else? What could be the problem? Like we understood data warehouse, we understood data lake. What could be the problem with the data lake also, right? It was solving the data warehouse also, but there are some problems with that. Data cleaning, yeah. Somewhat we are just dumping the raw data. Okay. There are some problems. First is I already showed you that asset properties, right? It is very important, right? Every time you make transaction, if one user is making some transaction, there should be the consistency. So these are the simple files that are actually stored onto the Amazon S3, right? Like a raw files. So if you are working on a file level, you can't really track all of this. Again, the schema evolution, okay? Data structure change over time. So to track what was this before the schema and the different schema, because you could just overwrite the files on top of each other. Performance bottleneck, like if two people are actually working together, there are some issues. And the version control and time travel. Again, if you just replace the file, you can't go back. You can't see like what was the state of the file 2 days back. To solve this, the open table format came into the picture, okay? Now these are the frameworks or the tools that you can see. Apache Iceberg, this is the Delta Lake, Apache Hudi. You can read more about it, you will understand. I'll just give you the brief about Apache Iceberg, okay? So you'll just get the basic idea. So this is the architecture. This is like the architecture that you will find on the website also. So if you understand from the fundamental level, it's more about handling the metadata of the data, because we are making changes on the fundamental data level, right? So if we can have some layer on top of it that could track everything that is happening on top, so we achieve both of the functionality like databases and also the data lake features. So everything is sorted. Most of the companies are using these, moving towards this. Like recently, if you know about Snowflake DB, integrated Apache Iceberg onto their system. Even Databricks has the Delta Lake support, and many major players are also integrating this. This architecture is very plain. So for that, I've used this architecture, pretty easy to understand. Pretty simple. You have the data layer at the bottom, which are the actual files that are stored on your system. On top of the file, we have the manifest file. Manifest files keeps track of everything that your data has, like number of rows, columns, types of it, every changes that you make, it is over here. Now, every time you make a change, the snapshot is created. It's like a versioning of your data, okay? The versioning is tracked by the manifest list. So how many manifest files are there? And then on top of that, there's a JSON metadata file that keeps track of everything that is going under the hood. And then there's a catalog, which keeps track of everything. So every time you read something from the top, it will ask the metadata file that what is the latest version available. It will go to the down and pull the data for you. Very basic overview, not going into detail, but if you want, you can just search online and you'll find the detailed explanation. Third one that I want to talk about is the unified data platforms. Now again, everything that we did, like data warehouse, data lake, Delta Lake, all of these things, we need to combine multiple tools to achieve this. Now there are unified data platforms, as per the name, you can understand. Everything is available to you. Like you just dump your data and you can do everything on the platform. You don't have to worry about anything else. So we have the data lake, data warehouse available onto the single location. And these are the platforms that actually provide you. Like these are the modern platforms. So if you are into the AI, even into the machine learning, you'll probably working with these. Databricks, Snowflake, Google BigQuery, Microsoft Fabric. It's the new service that combines all of the latest Microsoft things. These are some of the features that they provide. Again, we talked about this. This is summary. These are like all of the Snowflake, Databricks, Google BigQuery, Redshift, Microsoft Fabric, all of the features and unified data platform that they provide. Then we have the real-time data streaming, right? We already know about this. Don't want to spend time onto this. It's like companies are moving from batch processing to the real-time. The reason is simple. Computation cost is low. Customers are demanding the real-time data, right? If I purchase something, I need to get the notification right now. If I don't get the notification, this happens to me. Like on my website, if anyone makes a purchase and if they don't get the email about that, he'll keep spamming that I did not get the access, are you scamming me, or something like that. So we need everything real-time, right? Even if you order from the Zepto, you'll wait for 10 minutes and keep track of everything, like kahan pe pahuncha driver. You'll keep track of each and everything. So real-time data streaming is the future. Before, we did not use real-time data streaming because the cost is very high. You have to manage the real-time infrastructure, keep them running if anything changes. So these are the adoption demands for the instant insight. You can quickly take actions onto the customer's data. IoT and edge computing, again, we talked about like Amazon trucks moving from one direction to another. Customer expectations, cloud and scalable infrastructure, so you can easily do that. These are some of the tools. Again, Kafka, Flink, Cloud PubSub, Kinesis, you can explore. Don't want to go in detail. These are the future trends for real-time data streaming. Right? So first is the AI-driven. There are some KSQL thing happening. No, I have not really explored it, but what it is trying to do is that add AI into it and make it much more easier. Then serverless streaming, unified streaming, all of this. And at the end, we have the AI for data engineering. Just like every company is trying to innovate, we are trying to automate some of the things. So you can automate the creation of data pipeline optimization. So if you already have the existing pipeline available, you can do that. I have like 5 minutes available. So you can also automate the monitoring of the data pipeline and the data quality. These are some of the tools available that are doing it. Generative AI and querying is like a chat GPT only. There is an interface given to you, so you can generate the query and query your data. These are the platforms that are doing it. Snowflake's Cortex is one of the recent LLM that they integrated that helps you with, if you want to understand the sentiment of the data, extract the answer, translate them, you can do it on the data warehouse itself. And these are some of the use cases that you can think about, right? Cataloging, real-time decisions, feature selection, all of this. AI can do it. And this is the entire summary of the today's. Going from ETL to ELT, we have the open table formats, unified data platforms, real-time streaming, and the AI for data engineering. Yeah, that's it. Open for questions, or I'm good. Any questions? Little bit. So yeah, you can. It's like it supports Python. Initially I thought that it supports the Spark, but it only supports the Python. It's like a data frame type format, so you can directly use Python, read them, and modify your data. It's like the same. Yeah. Okay. Thank you so much. So I think Fabric is just a collection of all of these services, So there is no, it's like they have provided a directed unified data platform. So if you use Data Factory and Synapse, they have the similar, use case to create the data pipeline. So I feel Microsoft services are almost same. They are just trying to rebrand them in a different way. So you can do everything on Databricks only. So, but it depends on your use case, costing, and everything. Okay? All good? Thank you so much.
Any more questions?
If you have questions, you can connect me on LinkedIn or meet me outside, okay?
Yeah, all right. Thank you so much, Darshil. That was very, very insightful. Thank you. Please give it up for Darshil.
understands speech sentiment, helps prevent vision loss, predicts weather 10 days out in 2 minutes, translates thousands of pages in seconds, detects lead pipes to keep drinking water clean, eliminates paperwork so care is more human, generates from text, visuals, audio, and video, creates entire worlds from your imagination, creates this thing and that thing, a new thing, the new way. It's cloud.
Mathco began with a bold yet simple vision in 2016 to help enterprises unlock the full potential of their data and solve their most pressing challenges. We started as a small, passionate team of problem solvers driven by the belief that data could empower businesses to think bigger and do better on their own. Self-sufficiency remains at the core of our offerings to enterprises. We strongly believe that we live in an age of hyper-personalization. Enterprises, in the quest for being digitally at the top of their game, often face critical challenges. Challenges that can result in millions of dollars lost or missed opportunities to earn them. They're looking to evolve while overcoming their own unique set of challenges.
We today engage with more than 60 plus global enterprises across multiple verticals like retail, consumer goods, pharma, technology, and many more to come.
We're here to enable them to make smarter, faster decisions with enterprise intelligence. It's not just about solving problems, it's about building trust both with people and the tech and creating everlasting value.
Our strength doesn't just lie in numbers, it's in the unparalleled expertise of our mathematicians. Our people are the heartbeat of Mathco. They innovate, collaborate, and bring ideas to life in ways that drive real-world outcomes.
Every individual has a space to take ownership, make an impact, and shape not just their careers, but the success stories of our clients.
Everything we do revolves around creating meaningful experiences, whether it's through exceptional delivery for our clients or the way we collaborate and support one another as a team.
Each mathematician's goal aligned with a larger mission to empower decision makers in global enterprises to own and activate intelligence.
Our goal is to scale Mathco from where we are to 10 times our size. 10x in terms of the value that we add to our customers, the quality of experts we have on board, and the capabilities that we invest in. All in all, we want to be a one-stop shop for all our customers' digital transformation needs.
Synchron is a leading global consulting firm for digital transformation and technology enhancement.
All right, let's begin the next session. So the next session is titled The Evolution of Content from Pixel Manipulation to Personalized Digital Experiences with Gen AI. To present this, we have Rahul Prasad, a tech entrepreneur who has made a global impact with his pioneering work in AI-powered communications. As the co-founder of Bobble AI, an AI keyboard platform with over 100 million users, Rahul has redefined smartphone utility with innovative solutions. Under Rahul's tech leadership, Bobble AI has earned distinctions such as inclusion in Andreessen Horowitz's top 50 Gen AI consumer mobile apps and 20 plus patents in advanced technologies. Please welcome Rahul Prasad on the stage.
Hello, am I audible? Hello, hello. Just a second. Hi, I'm Rahul Prasad, founder and CTO of Bobble AI. We are known for our product, Bobble Keyboard. Have you seen people using stickers of their own faces? Or have any of you have heard of Bobble, used Bobble? Show of hands. Okay, few of you have used Bobble. Okay, good. We have about 100 million users in India and Indonesia. And we have been innovating in this space since 2015. In fact, let me tell you about few innovations that we have done. Have you seen English language, Benglish, Tamilish language being used in other keyboards? That was the innovation that we did in India, which was then copied by other keyboards. Have you seen emoji bar on top of keyboard, where you type and the emoji gets automatically changes to make your conversation more expressive? That was another innovation that we did. Similarly, we were the first to launch stickers within the keyboard. So while typing, you get the stickers, you share it directly, express yourself in the most creative way. We were the ones to launch it. In fact, we launched multiple content into the keyboard. For example, sharing GIFs, sharing memes directly through the keyboard. All those were our innovation. In fact, we have filed more than 40 patents in this domain, out of which 20 is granted. More than 20 is granted, and we have been filing research papers, and 10 plus has been granted so far. So I wanted to talk about and how we optimized everything, what are the problems that we faced and how we solved it. So it was 2014, end of 2014, we were few people sitting together brainstorming about how can we make people more creative. So we know that all of us are creative, each one of are creative, but we don't express ourselves in the most creative way. We don't go ahead and upload our poems, upload our paintings. So we wanted to create a tool which will make it very easy for everyone to create their own stickers, to create their own avatars and share it with people. So this was the prototype that we thought of, that people will just take a photo. This was back in 2015. Right now, it's very common. Multiple such apps has been launched, but we were the one to come up with this. So we wanted to make it as a tool that, let's say, someone takes just one picture, and we will create an avatar. And that avatar can be customized. You can change the clothes, you can change the text, you can change the font, you can change the background, and then that avatar can be used to express used by our users to express themselves. So this was a very good idea. We thought this might work, and we started working on this. So the cartoonification part was not that difficult at that time. The first cartoonification that we did was using a static thresholding. It didn't give us a very good output because of static thresholding, most of the part were dark and most of the part, it was a black and white kind of output. Then we used dynamic thresholding and we created a second version. And then we used edge detection and we created a better version. And we thought this is something that user will like. But the major challenge that we faced is that now we can create the whole cartoonification of the input image. But how do we remove the background? So once we create a cartoon of the head, we are going to put it onto the avatar. We cannot have the background in it. So the challenge was how to remove the background. And we brainstormed, thought of multiple algorithms, and we couldn't figure it out. We thought that, so it was back in 2015, so there was no such algorithm of background removal present at that time, which was very famous or which was known to us. So what we brainstormed, but we couldn't find out a very good solution. And we thought that it's impossible to remove the background using just pixel manipulation. So we almost gave up. But there was an intern among us, and he was listening. And at that night, he went back to his room, started working on the project, he started researching and doing some POC, and next morning he comes and he shows us this output that he was successfully able to remove the background from the image. And that was quite promising, and we thought it's not that good, but it was promising, and we thought we can move ahead with this. So what he did was, so using facial landmark detection, he used dlib library to detect the facial landmark, and once you have the landmark, you know that this area is a face, and you can segment the face from there. Similarly, there was an algorithm which was fairly new at that time that was called grab cut algorithm. All you need to do is give a probabilistic distribution of where the object is, and the grab cut is going to segment it for you. So he combined both of them. So once you know the landmark of the face, you can create a probabilistic distribution of where the hair will be. And he used both of them, combined both the output, and came up with a fairly good background removal algorithm. So this is the story of how we started. This made it possible, and the first app was launched, and we became viral. So multiple people used it, they liked it, and they started sharing our product, and from there, it was just an application to create avatar and share the avatar. But we realized that people are using it to during their conversation. So we found that out because we do all the decision making using our data. So data told us that people are using it during conversation. So we started making it easier for users. So we created a keyboard. And that keyboard, you are doing, so now you can share the stickers during your conversation. So that was so once we launched, so we started focusing more and more on optimization. At that time, there was a bandwidth problem, and we wrote everything in Java. Because Android that time only Java was there. Java was very slow. It used to take 4 to 5 seconds to create one sticker. And we were like, if this is the time it takes to create one sticker and we are giving so many stickers to user, how are we going to fix this? And we were brainstorming. And we saw at the OpenCV library, and we saw there was a shared object file in that. And we were like, how do we create this shared object of our own code base so that our processing will be faster? So there was this concept of NDK, Native Development Kit. Just like Java Development Kit, JDK, there was an NDK in which you can write the code in C++. C++ code was very fast in execution. So we translated all our code base from Java to C++, and that reduced our processing time from 4 to 5 seconds to about 1 second. So this was one optimization that we did to make it faster. Similarly, and the next level of optimization came when we thought that when there was a problem that we wanted to use this. So creating a sticker is just one frame. You just create the head, stick it onto the sticker, and the sticker will be there. But then how about a GIF which has multiple frames and which is also personalized? For that, if I take 1 second to render one frame, it's going to take 30 seconds to render one GIF, because 30 frames 1 second. So we started innovating, and what we did was we wrote our own GPU pipeline using OpenCL and NDK, and we created this framework which was creating the stickers, rendering it within milliseconds, and that enabled us to create GIFs on the fly. And at that time, internet was very slow, and we used to send 3 images to create one sticker from server, and we wanted to optimize that. And this is something that again came as an innovation, that we took a PNG. PNG has 3 layers, red, green, and blue, And we started putting this all the 3 images in 3 layers. So instead of sending 3 images, we started sending only 1 image and extracted the layers from there and created the stickers directly. Okay, why is that tilted? Anyways, to fix the segment, the first segmentation that we did was at the time when AI was not that good. But then UNet came, and there was much more innovation in artificial intelligence. And using UNet, we had a segmentation database, and we were able to create very good segments using UNet. But the problem with UNet was that it was trained on very good data set, and data set was not Indian data set. So, and we wanted to solve it. The kind of output it was, the input that we were getting was very low resolution input, and either it was very dark or very bright. Because of that, the output was not good enough, and we wanted to fix this. So the idea that we utilized to fix this was that we wanted to, we fine-tuned UNet for segmentation on our own Indian data set, but we didn't have a lot of Indian data set, and we wanted to create that data set. So we started generating synthetic data at that time. To create synthetic data, we used StyleGAN. So first we fine-tuned StyleGAN on our Indian data set using directional classifiers, so that we can control the output. For example, if we want a laughing face, or if you want a face forward, if you want spectacles, if you want a very dark image, if you want a very bright image, we were able to control all those things with our fine-tuned StyleGAN and directional classifier. We generated the synthetic data set using that. And then we used SAM, Segment Anything, a model, a very heavy model by Facebook, to segment our synthetic data. And once the synthetic data is segmented, then we trained our UNet on our synthetic segmented data, and the output became much better. So this was another enhancement that we did by fine-tuning a model which was already existing, and by creating our own synthetic data. Okay, till now we talked about cartoonification of the face, but the quality of a sticker was still not good. So we wanted to enhance the quality of the sticker. So enhancing using pixel manipulation was out of the picture by that time, because technology has evolved. So we used Pix-to-Pix model, and we started Pix-to-Pix architecture, and we trained Pix-to-Pix on sample data set. So these quality of stickers, all of them were created by our creative people, our creative team. So they created about 1,000 of images, and then we fine-tuned Pix-to-Pix on those images. And that's how we were able to generate bobblehead of better quality for our user. Similarly, for example, if there are Disney quality photos, or if a set of photos are available in the internet, we can download it and train our Pix-to-Pix model and create an output which is very much similar to that. So this is how we started optimizing the quality of the stickers, the bobblehead that we were generating. So it has evolved so far. Then we thought, okay, now it takes a lot of data to generate one image. How about we generate output with just 1 or 2 images? So we used few sort learning. So what we did was with image inversion, we found out the StyleGAN that we trained with multiple classifiers we used image inversion to get the embeddings from there, and we used the same embedding on the input data to create something which combines both of them. So it takes the style from there, it takes the image from there, and the final output is generated like this. So this is how we have evolved. And the next thing was now we wanted to animate the head. So let's say if somebody is saying hey or somebody is saying no, so we wanted to implement it on the sticker. So let's say if you are sharing a sticker and we want to send an animated sticker, how do we do that? So what this was supposed to be animating, but we used a thin plate slicing motion model, and we created similar output. So when you use this model, what you have to do is on the input, you have to provide a video of the movement. For example, if you are providing a video of nodding the head, it will implement the same thing on another face, another input face that you have provided. The problem with this method was that it was very heavy. The model was very heavy. It was taking a lot of time to implement this, and we have millions of users. Generating this for millions of users was very costly and also very time taking. So what we did was we started to first we started fine tuning it, but that didn't decrease the size of the model. What we did was we started freezing some of the layers in the model and started fine tuning it on our data set. And we realized that when we freeze some of the layers, there was very less impact on the final output. So we determined which layers are those layers which are not very useful for us. Then we trained the whole model without those layers. And that's how we reduced the size of the model to quite small amount. And that enabled us to run it on scale on millions of user base. And we were able to launch this at fraction of the cost, which we would have incurred if we had used the original model. So whenever you are trying anything on machine learning with the models which are already present in the market, don't just go for what is already available. If you want to optimize it, there are multiple ways of optimization. You can try some of them, and I'm sure you will be able to optimize the models to quite some bit. This is something new that we have come up with, and in this we are using stable diffusion. So there's not much of an innovation. It's just the ideas that we have combined. So we are creating. We are using stable diffusion to create the whole image. So what this enables us to do is that for every sticker, for every person, it's going to be different. And then we use either face swap to generate this kind of output, or we use embeddings to generate this kind of output. So this is enabling us to create a multitude of content without requiring a lot of manual work to create the content. So these are few sample outputs that we have recently launched and as premium offering to our users. Where's the video? Okay. Similarly, some of other premium offerings are professional photography, professional videography, which the video should be playing, it's not playing, and 3D stickers, which are generated using stable diffusion. Right now, we have not started optimizing on this, but in the future, we are planning to optimize this as well, because using stable diffusion takes a lot of time, and either stable diffusion or flux, it takes a lot of time. So we want to decrease the model size itself so that the cost will be lesser, the time to generate the content will be lesser. We have trained few low rank adapters to get the best quality, but decreasing the size of the model, this is something that we'll be working on. Okay. Play bhi hoga kya ye? No, it's not playing. Okay. So that brings us to we have always been working on India because we needed a lot of creative people to create stickers and to create the background, the create the body and everything, and to create different type of heads. But the new generative AI has enabled us to scale it up very rapidly. So we have created a pipeline, agentic pipeline, where we just put the country name. So let's say if I am putting Vietnam, Thailand, USA, it will run an LLM model. It will determine the type of lingos that they use, the type of clothes that they wear, and how they greet each other. So it will generate all the prompts. And from those prompts, it will generate, and the type of clothing that they are wearing. And from those prompts, it's going to generate images. And and from those images, the good quality image, we keep the good quality image, and and the kind of output that you can see is here. So for us, we just need to put the country name, and the whole pipeline creates thousands of stickers within few hours. And this has optimized our manual operation cost by a lot. So one challenge that we faced when we were working on this was that the stickers that we make is personalized. So head is different, body is different, and background is different. Everything comes as separate layers, then they are combined together to create a sticker. But whatever is generated using generative AI, it's a single image. So we have to come up with our innovative ways to ensure when the body is generated, head is not generated, or only the background is generated, or we can generate separate background, separate foreground. All those innovations enabled us to create plenty of content in no time. Oh, it's going back. These are some of the sample stickers that we are able to generate for multiple countries. So we have been focusing a lot on on-device models, so that data doesn't have to leave user's device. And this is some in our future roadmap that we will be working a lot to make the size of the model very small. And nowadays, the smartphones are getting better and better. They are coming with TPUs, NPUs, and I think it will not take more than a year for us to reach there. And we want to work on very hyper-realistic output. For example, let's say if you want to create a reel of you going to Simla, you going to Switzerland, you won't need to do you won't have to do anything. You won't even have to write a prompt. You just select a template and it will create it for you. And that will be highly personalized for you. So these are few of the innovations that is in the roadmap. And that's it from my side. Thank you. Do you have any questions? Feel free to ask. Yes, please.
Yeah. Hey, Rahul. Thank you. That was a good talk. And yeah, I'm Saket. I write software, and I was wondering, with your plans to have on-device generation, how would you ensure that your secret sauce doesn't leak out? If like people all the time, your entire moat is about having this, right, and not having it leak to other platforms like Meta or someone else copying your designs. So how do you make sure that that doesn't happen?
Very good question, but it's a myth. DeepSeek R1 just released their model. DeepSeek released R1, V3 was already there. Meta has released Llama 3.0, a series of Llama. OpenAI has closed everything. Earlier it used to be open, now it's closing. And you see what's happening to OpenAI, and you see what's happening to DeepSeek. So open source models are getting, the companies are getting more valuation. In fact, your moat is never this, that how we have created this. Your moat is your user base, your moat is your feature, your moat is your networking effect. So, because the more you try to close it, people will come out ways to get it out for unless you keep it in server. If so, that's my answer.
Perfect. Thank you.
Any more questions? Okay, thank you.
Thank you, Rahul. Thank you so much. We'll be starting our next session at 3:25. So we still have some time to go.
We specialize in the financial services and technology innovation sectors. We work hard to become the trusted innovation and transformation partner of choice to our clients. Synchron's progressive technologies and optimization strategies span end-to-end artificial intelligence, consulting, digital, cloud and DevOps, data, and software engineering, servicing an array of noteworthy top-tier firms. Our coordinated, cross-regional teams have deep domain experience in high-tech, capital markets, investment banking, wealth management, retail and commercial banking, asset management, exchanges, insurance, and payments, as well as cutting-edge technologies. Our 14,000-plus global employees, spanning 55 offices across 20 countries, are passionate about innovation and meeting new challenges. Our
team at Synchron is committed to pushing the boundaries of AI technology and delivering state-of-the-art solutions. We understand the importance of staying ahead in today's fast-paced world, and Gen AI tools are designed to give you that competitive edge. The future is here, and Gen AI is leading the way. Embrace the power of generative AI with Synchron Nexus tools.
In a world clouded with complexity and ambiguity, there exist significant opportunities for disruption and growth. At Tiger Analytics, we help our clients navigate this uncertainty, empowering them to move decisively through shifting sands, unlocking these opportunities. We work with our clients to strategize, design, and engineer a future-ready enterprise. At Tiger Analytics, we've been reimagining possibilities with cutting-edge AI and analytics, solving some of the toughest problems out there and building the blueprint for tomorrow. And at the heart of this mission is our battle-tested team of exceptional technologists and consultants. It's our unique expertise and character that enable us to create exceptional value even in hazy conditions. That's our Tiger gene. The Tiger gene is what makes us learn relentlessly, experiment without fear, seek help, and offer help. The Tiger gene is what helps us uncomplicate complex problems, build for the future, deliver clarity amidst ambiguity. To our clients who are traversing a fog of uncertainty, we are not just a technology partner, we are a certainty partner, relentlessly seeking, solving, challenging, and growing. Together, as we set bold ambitions and target extraordinary outcomes, let us experience the power of data-guided decisions, the potential of connected insights, the promise of an AI-empowered future. Experience certainty to shape a better tomorrow with Tiger Analytics.
Even before the world could start talking about AI and Gen AI, for the last 15 years, we have invested in AI with the pioneers in AI. We have built some world-class solutions around AI.
Wipro has been at the cutting edge of data science and AI for a while now. Wipro and I get to work across various and diverse industries, everything from agriculture to pharmaceuticals to healthcare to oil and gas.
So we are helping many Mang-level customers in their transformation journey. So we have strategic consultants, we have domain experts, we have data scientists. So basically we do customer hand-holding right from the inception to post-deployment stage.
We have more than 400 plus use cases which are live. We embed AI into the end-to-end software development lifecycle, as well as we are working with our clients to infuse AI into the operations, as well the application management services, infra management services, by bringing in the generative AI to enable an end-to-end transformation, autonomous operations for our clients, predictive operations for our clients.
Our responsible AI
All right,
is taken
we shall start now.
seriously, and we have typically 4 dimensions that we talk about.
The world has moved from drag and drop timeline-based editors. Text to video is a paradigm that makes video creation and distribution a verbal skill. This takes this confined ability to the hands of every person who can think creatively and has a story to tell. But chatting with a video creation and editing agent has its own set of challenges. Let's hear more on this from our speaker, Abhijit Singh, co-founder of Binge Clip AI. Earlier, Abhijit ran a hotel aggregator consumer tech startup, Zorooms, as supply head and an AI consulting firm, ePowerX, as an hands-on AI developer. Having been on both sides of the table enables him to understand and anticipate user needs and translates them into scalable AI applications and models. Also here is Prateek Khandelwal, the co-founder of Binge Clip. Let's welcome the duo on the stage.
Hello everyone, this is Abhijit. Some of the introduction has been done about me. This is my second startup, and in 2012 I passed from IIT BHU, same with Pratik. We did our first startup in 2014. It was a consumer tech startup. I worked as a supply head over there. I aggregated hotels, which were sold to the customers. He used to do data science over there. And post that, we started our own AI consulting firm. We used to build machine learning and deep learning models across various verticals like e-commerce, finance, IoT, different kinds of problems. So we did it for 6 to 7 years approx. And in 2022, we came across an image generation problem for a client in Dubai. And in those times, DALL-E 2 was not launched. It was in very early stage. We used to generate images in almost 24 seconds, one image, and it was kind of very hazy image. And that's why in those days, AI images were getting used in AI art. So one of our friends, he was doing crypto, and he invited us to launch some NFTs, and that's how we came into the world of generative AI. Okay. We have a lot of exposure with videos and commerce earlier on, so we decided to embark on this journey of the video. We had a lot of exposure with the problems that end user, like lower set of users face with the videos. And we understood these problems, we understood AI. That's why we have founded BingeClip AI to solve the problem. The motivation is pretty much simple. I will just zero down on the motivation a little bit because it is a problem statement we are trying to solve. So just like a consumer in the day-to-day space, especially the Gen Z audience, they on an average have a video app in their mobile phone. Usually VN is one of those apps. Remini is also one of those apps. And it's a very simple kind of apps. It aggregates all your photos and videos and makes a sensible, presentable story out of it. Okay. And in India, it's a very big trend. India is surprisingly second largest video creator audience in the world. It should not be like this, but it is there. Okay. We find that these audience are going into the companies and they are working hard in those companies. And everyone knows that in whatever work you do in your company, presentation is one of the biggest skill that has to be there to present that knowledge out there to the teams, to your customers, or to all the stakeholders that you are working with. Okay. That's why we have a PPT industry, okay? But all of this audience understand the importance of videos. They crave for a tool which can convert all these documents into the videos, all their knowledge work into the videos, so that they can present what they want to present. It should be in terms of story. Everyone wants to listen a story because of the attention span problem, time limit problem, understanding problem, domain expertise problem. There are n number of problems. Okay. So, but when we started working with this kind of people, we thought that Canva is solving all the problem. Canva is a drag and drop editor. InVideo is a drag and drop editor. We have other kind of drag and drop editors also like copying. Okay. But we realized that there is a lot of gaps which is still not filling the gap for these users. The first gap was very, very important one. They want very much accurate information to be there in the video. It's a knowledge work. The information has to be accurate. Okay. Let's say there is an agri person, there is an insurance person, there is a loan person, okay, there is a health person. एक image, एक video clip, एक fact भी गलत नहीं हो सकता. Okay. It's very, very important part for it. So all the information, the first information problem statement was that all the information must come from a knowledge base. Okay. Second part is the visuals, again, all the information must be very, very accurate. Okay. And most of the text to video editors or even the editors like drag and drop editors, they are not facilitating it. They are making this kind of problem a kind of clumsy editing problem. Okay. You have a timeline based editor, you have your own clips, you can put that on timeline, but then that footage will not be processed, it will not be trimmed, it will not be clipped. Okay. And this, everything makes it an editing problem. And this is where the user goes out of the picture. Okay. Then the third part, when you ensure these two things, then comes the design problem. Okay. Okay, we have collated all the facts together. We have put that everything on a timeline. But I don't know how to design color, fonts, typography. Sorry, fonts and typography are same, but colors and typography and also the visual elements that should be there. What should be the flow of the process, animation that we want to do. But most of the users are not acquainted with it. They just consume it, but when it comes to application, they are not able to do it. Take care. This is the third level of problem that we face. And the last one is the editing flow. Take care. When it comes to edit the video, it's the most clumsy part, just like in the software development. AI can write all the code for you, but the hard part is debugging. Take care. So these problems for a statement, we decided that this will be the core mode of our product. Take care. And we started working on it. We started working on a video product where you can write a prompt, you can write an idea, you can write a script. Take care. You can ask a question, and a video comes out. Take care. And the idea is that you should edit it bare minimum. Take care. So we started working on this tool, and what happened is we started getting a lot of use cases which was not social media centric, but communication centric. Like you want to communicate to your customer and you want to send personalized message. Like there is a loan customer, he wants to, you have sent a product video, कि ये मेरे loan का video है, this is how health works, this is how loan works, but they have an objection कि I am not comfortable with the interest rate, I am not comfortable with the premium, not comfortable with the payment tenure. Similarly, in agriculture, people tell about कि this fertilizer will work for your wheat crop, but he told कि I overdosed this wheat crop last year, this fertilizer is not working. What should I do? Take care. So in those scenarios, what happened is asking a knowledge base and generating a video out of it was very, very useful use case that came into the picture, and we started to work on it along with the text to video editor that we have. So right now our product should involve three kinds of things. We generate and edit video, okay. We store them. While storing, we generate the tags automatically, the titles automatically, the descriptions automatically, and in the last, when you ask a question, we give a query, we judge the intent, and we give you an accurate video out. And this is done usually on the chat. So I'll just show you one video, how it is working. But today here, we will talk on the core component only, which is video creation and video editing. Okay? So please play the video. So this is just one demo. So you write hi, it asks you to generate a video, you select a language, and it tells you to ask a question. Okay. So the person has asked a question about 3 diseases of potato, and video generation happens. Now there are 2 kinds of stuff here. First, see the video, and I'll explain about the ETA. Here we need the volume. Sorry about it, but it has a legit volume. So you can see that all the visuals and facts are accurate about these videos. And this is what our customers are seeking. Okay. So this is one of our product offerings, but the main core product is the video. Okay. And I think Prateek will start on how we are solving everything step by step, like the knowledge base part, video search part, and the last part, editing, will be covered by me. So.
Hello. Hello. Yeah, good afternoon, everyone. So I think Abhijit has already covered the introduction part, so I'll straight away move to the components here. So while watching the video, you saw there are 2 components to video creation process in our stack. One is script to video, and the other one is query to video. So what is query to video? When you have a knowledge base attached to your system, then basically you have a query, you get the context from that knowledge base, and then you generate a script, and then you basically go to the script to video creation part. First, I'll explain the script to video part, and then we'll get to the query to video part. So script to
Batana jab bhi
So script to video, in essence, we assume that whatever demo you saw on the WhatsApp, let's say we assume that the user already has a script in hand. And now once you have the script, the next process is basically doing the script analysis part. So what we do is, based on the language, whichever the language was selected by the user, we convert that script into audio using TTS, and then we have a word level timestamp with us. We put that timestamp data plus the actual script into the script analysis module, which you can see here. What it does is, it is nothing but an LLM, but we have done a lot of prompting there just to make that very, very smart. What it does is, basically it converts that script into scenes, and scenes in such a way that the logical flow should be there in the video synchronization part, and it should be coherent. So the script analysis part is basically converting the script into scenes, and we have a lot of components in that data, where for every particular scene we have start time, end time, uh, tags, context tags, duration, and the most important part here is the search query. So what do we want from that particular scene? So we have like 3 media integrations. For every scene you just saw the video. There can be avatar, there can be image, and there can be videos. So the search query part for every scene is very important. So that is where the entire, you can say, the crux is. If you don't have the right search query, you will not have the right media assets. So that part is done. Once that is done, we basically do this integration. Avatar selection part is basically given to the user. A user can select, we have pre-made avatars with us. User can select the avatar, whichever avatar they like. And these are all, you can say, real avatars. These are not AI avatars. So the realism has to be there. Then the image and video part, I'll explain in the next slide. The search part, like where exactly is the search happening. Post that, what happens is, once you have the scene level information, you have all these, you can say, media integration part done, you basically get to the theme part. So what is the theme which any particular clip is saying? Because that is important. We have basically some templates which we have pre-designed for every particular theme, and some are AI generated. So theme is nothing but design, you can say, for every clip. Once that is done, we basically have the text overlay part. Text overlay, it is actually not written here, but yeah, you just saw the video where whatever you are trying to speak, if that text is not in sync with whatever you are saying, then it's not relevant. And again, the most important part here is it has to be in sync with the avatar also. It cannot be like, and same is true with images and visuals. If you're saying something about a potato disease, and if you don't have that disease in front of you, it's a problem. And same is true with text. You cannot just say anything and the text synchronization is not there. So that this is where the timestamp data comes into picture. And yeah, once that is done, what we do is we basically render all the clips individually. And the most important part here is, if let's say we have a scene and we convert that scene into, let's say, 7 clips. So the 7 clips have to be processed in a parallel manner. That is very important. It cannot be sequential. So the crux here is the scene segmentation part. If the scene segmentation part is not done in such a way where the dependency is not, you can say, not attacked, then there is a problem around what you do in terms of doing the parallelization part. So the moment we have clips, like the video which you saw, for a 1 minute video, we take 2.5 minutes just to render that video. And we are constantly basically reducing that time, but that is the core purpose, that you have to parallelize everything. You cannot do sequential computation. And some of the computations are really, really, you can say, heavy. So they take a lot of time, GPUs also. Once that is done, final rendering is done, and then you get a final video. We attach a music on the background, and you get the video accordingly. So this is the script to video part. Yeah, I think I already covered this, but yeah, like I said, avatars, you can have personalized avatars also, which you have. Like we are dealing with agriculture-based companies who want agriculture-based avatars. We are dealing with insurance-based companies, healthcare companies. So they want avatars who can basically have a, who can relate to, like users can relate to those avatars. They cannot be like just AI avatars. And images and so coming to the images part, we have 3 you can say options here. One is integrate your custom images also. Like for example, if we are working with any particular company, they have their custom image dataset also with them. So do we have a process where we can integrate those custom images into our pipeline? Yes. If the custom image is there, let's say if the custom images are not there, then we basically search those images in the stock library. So there are a lot of stock libraries which are open source. They basically provide you, open source as in they provide you the asset according to your search query. If even if like we don't get custom images or the, you can say, stock images, we basically generate those images on the fly. So that is again one option. Similarly, for videos, we are right now only dealing with custom videos and stock videos. We don't generate clips because that is the essence. If we are able to generate clips, then we are able to generate the entire video also. So that is not what we are doing right now. And then there is a sync text part, which I already told you. So yeah, this I have already covered, I think. Yeah, so from our understanding what and the business context also is important here. The most important understanding here is the script has to be accurate, which is very, very important. And the visual part, according to that script, has to be very accurate. If you are working in the text to video space, and if we are integrating any third-party images or videos or custom images, if the search is not working properly, then the relevancy is going for a toss and the engagement is dropping. That's what. And एक नॉर्मल वीडियो बनाने में इतना वक्त नहीं लगता है, बट एक अच्छा वीडियो बनाने में काफ़ी टाइम लग जाता है. दैट्स व्हाट द learning is. So we focused our, you can say, the core of our entire stack is how do you basically do proper searching and how do you do proper scripting. These two parts are very, very important, and then we'll come to the video operations part. So scripting mein, search mein, the important part is you have to be context aware in terms of visual search, because here what is happening is for every scene you are having a text query and you want a visual asset for that text query. So that is kind of a multi-model embedding which we are talking about, because what happens is if you are having a text embedding model and you are having a visual embedding model, they need to be present in the same latent space. Otherwise, the similarity won't come what you're looking for. So inherently, text is kind of sequential and it is, you can say, symbolic. But when it comes to video or images, there are a lot of spatial features, and it is temporal dependency which you call. So creating embeddings only for text-based models and creating embeddings only for visual, like images models, is not going to solve the problem. You have to take a path of multi-model architecture. So after doing a lot of, you can say, ifs and buts, we did a lot of iterations also. We basically, the core foundation here is how do you bridge the gap between text and visual semantics for similarity, because similarity was not coming. Initially what was happening was we have a text which is basically a search query. We pass that text into an embedding model. You get the embedding. Now you have an image, let's say. For image, you generate metadata. You have the tags. Sometimes the user only gives you the tags in their systems, from their systems. But you have to convert that tags or metadata into embeddings, let's say. Again, this is something which was not working. Why? Because visual features are not coming into picture. You are ultimately, what you are doing is you are basically having the metadata, you are converting that metadata into embeddings and just giving the text to text similarity only. So it was not that accurate, and accuracy was very, very important for whoever we were working for. After this, we did, the most important part is we have to get to the model which is basically having text and visual embeddings trained in a shared latent space. If we don't have that, we cannot do that. Clip is again OpenAI's very, very robust model, but again it is, you can say, it is trained on the web data. So that is the problem. We had to do this on a, you can say, custom data. So we fine-tuned clip models for our agriculture-based data. Same is true with VideoBERT. VideoBERT is again for image. It is again a core architecture is transformer-based only, but it is for video. Sorry, not image. It is for videos. So how do you basically convert the video into scenes, and for every scene, not scene at actually frames, how do you convert embeddings from those frames and basically do the similarity with the text which you are having. So these two models are the core which we are doing. We do a lot of fine tuning also. Then there is a semantic search approach which is normal, and the database which we use is PG vector. And vertical fine tuning is very, very important. Like I said, the video which you saw is of agriculture. So if we don't provide relevant data, we don't get the accuracy which we are seeking from the general models, because these models are definitely good, but these are not good for custom data sets. Same is true with healthcare data, and same is true with insurance data. So this was around script to video part. The video operations I've already covered. Again, the second important part is query to video, and this is where our, you can say, the focus was, because a lot of people are asking that we have a knowledge base, we have answers to all the queries, but we cannot have a video on the fly, which you just saw. So query to video is something which is again very important. And knowledge base, when it comes to knowledge base, you can see user is basically giving you the query, you do the query analysis, you do the script generation part, which I just explained, the same thing, and the completed video part. But here is the most important part: how do you retrieve that information in a very, very, you can say, concise manner? Because if you don't have that information with you, again you will lose the context, again it will have a ripple effect on script generation, and it will have a ripple effect on video generation. So again, if you are asking for, let's say, the video in which we saw, give me 3 diseases of potato, and in the knowledge base, if you don't have potato ka koi bhi disease ka data, then again it will go to the LLM and basically get the data. But what if instead of 3, you only get 2? What if instead of potato, it was not able to understand that context really well? Potato ke jagah kuch aur ho gaya, wheat aa sakta hai, because there are a lot of crops which we have in our database. So the information retrieval is very, very important here. And that is where the next part, the RAG part, which comes into picture. Next. Yeah, this is the accurate scripting part for, you can say, vision enhancement. So you have the document processing workflow with us. We have the document processing workflow with us. What it does is basically whatever is your knowledge base, whatever kind of modality you are having in documents, we just put it, and unstructured.io, we use unstructured.io for basically getting the right elements from every document. But the most important part with us was there were a lot of documents which were having text data, image data, documents, PDFs, Excel, CSV, HTML, everything, on top of it multilingual, because we are catering to vernacular audience in India. So if you don't have the retrieval at place, then that becomes really difficult. So unstructured.io really provides a good, you can say, element-wise contextualization of whatever context you are needing. That is one. But the most important part here is you cannot use that context directly. So what we do is we convert that context into the, map that context into the page, whatever page they are talking about, and ultimately to get the context for that query, we pass on the entire image. We don't, again here we are relying on vision language model, where along with the question, we pass on the image of the context to get a better understanding. Because what happens is if you only give text, then there is a problem. Then there is a search, then there is an accuracy problem which we have faced. So we generate embeddings accordingly, and we basically, you can see the visual retrieval part, we retrieve the entire page image associated with the relevant part and basically get to the search part. Once that is done, contextual reasoning is there, and we get a better output. Still, this is work in progress, but yeah, that's something which is done. Once we have the accurate extraction of, you can say, script, we do the script to video module, which I already explained. So this is you can say accurate scripting.
So yeah, I'll cover the editing part, and this is one of the most crucial part which differentiates the product from all of the products. What happens is generation will happen, and there will always be some inaccuracies in generation, and user will like to edit that video. And with AI video editors, there is a lot of scope which is increasing in terms of what kind of edits you can do. So I will categorize the edits into 2 parts. One edit is you want to make an edit to overall video, like you want to change the language of the video, you want to change the length of the video, you don't like the tone of the video, you want to adjust it to the audience. Let's say your audience is like, you say, someone from 18 to 25, you want to change the color, tone, templates according to that. What is happening currently in tools like Canva, you'll have to switch the template altogether, and which is a very costly task. Sara content, everything that the text, images has to be transferred from one template to the another template. So it's a very, very costly edit that has to be done. There are second kinds of edits which are very, very simple stuff where user wants all of the control. They want to change the asset. Let's say we saw the video where there were some disease images over there. He doesn't like the disease images. She doesn't like the disease images. That images, the exact images has to be changed. They tell we have better images, we can upload it and we can put it over there. So these kind of edits are very, very accurate one where a user wants control. So we have divided the UX into two parts. And what has happened is one is text-based editing and another is drag and drop editing. Okay. And for that, what we have done is in backend, we have created a DAG architecture. We have divided the video into layers. We start from the background, we go to the template, we go to the components of the template, which are avatar, video, and images that Pratik told us. And then to each of the components, there are effects and animation attached to the component. And then in the last layer, we have text and we have effects of the text. This is how our DAG architecture is arranged. Okay. We have created a UX where we have given a simple drag and drop interface, which adjusts these elements of the DAG. You want to change the text on the screen? Okay, no problem. Okay, you go and edit the text of the screen. It will directly update it into the DAG. But what happens if you want to change the theme of the video altogether? Okay, so that's where the agentic flow works for us. This is the where we found a real use case of agent in our editing process. So we put an agent, we put an editing agent on the top of the DAG, okay, and it takes a text query. Let's say text query is adjust my video to the audience between 18 to 25. They like the video more colorful. Okay. So the first part is understanding that query, breaking it into the actions. Okay. And then the DAG agent decides which of the subgraph which will be executed for making this change. So in this kind of scenario, the subgraph which will be getting executed will be the template part. And since it's a hierarchical structure, so first, the moment you select the template, the DAG ensure that rest of the elements will get automatically updated. Okay. And this is how we are creating an intelligent agent, which is kind of there besides you. It takes instructions from you and adjusts the video accordingly based on their own intelligence. This is where we are moving from a simple drag and drop editors towards the Premiere Pro features, towards the features which are inside the DaVinci Resolve. It's not the frame by frame features, but the advanced features one. Okay. Let's say, for example, you want to change the length of the video. Okay. So in that case, what will happen is it will skip the background, it will skip the template layer, and it will come to the scene layer, which is the component part. Okay. It will rewrite the script altogether. It will split it all together, and then whole of the DAG will get executed again. Okay. So this is the first part. This is how the function is getting allocated by the agent. The second part is the compute. Okay. So we have several components, like there is a lot of components which is running in a video tool. Okay. And right from the search to avatar lip sync, a lot of things are happening over there. And some of the components are really compute heavy. And we need to know in real time that how much compute is getting allocated in which of the component while video is getting created on scale. Okay. So these agents give us an overview of if, let's say, at one point in time, let's say 1,000 videos are getting created from our APIs. So from which parts the compute is getting allocated. This has really helped us in saving the compute cost. Okay. It's exactly the A100s. So yeah, this is our editing flow altogether. And this ends our presentation. Okay. And we are inviting questions. If you have any questions, please ask us. Yeah, please.
So you have image retrieval or image generation, right, for the prompt to video. So in that, are you like using generative AI or you are trying to like grab some images from the web?
Right. So, Michael.
Yeah. So text to image you are saying, right? For image retrieval you are saying.
Yeah. So you are also grabbing some visuals to like paste it beside the avatar.
Yes.
Right. While the video is getting created. So is it Gen AI images or you are like getting it from?
So yeah. So there are three categories to it. One is, let's say you are a company and you already have image database with you. So the first part is the search part. Like if you already have the image, we don't generate it. Second is, let's say you don't have the company dataset with you, but still there are a lot of good images which are already there on the internet. So stock images. So according to the search, we basically get to the step 2 part, which is the stock image part. Still, if we don't get any relevant search, then basically we generate it. So but once you get to the generation part, it's like normal text to image algorithms which we use.
And the second part, So you have two GPU intensive tasks, right? One is script generation, image retrieval, and another GPU intensive task of like rendering. So what is the typical like split of like GPU compute? How many hours or like compute time you are like spending for rendering and for script generation?
Yeah, so effectively script generation, you can say is not GPU intensive. Okay, the major GPU intensive part in our entire workflow is, you can say, the avatar syncing part, the avatar lip syncing part, which takes a lot of GPU, and the video operations part. Because video operations, like I said, there are like, let's say 7 to 8 clips for every particular video. If they are happening in parallel, you need to have robust GPUs. So right now what happens is, like I said, the compute time for us is, if you have a 1 minute render video, if the render time of, the length of the video is 1 minute, the render time for us is 2.5 minutes. So that is coming with, you can say, right now, if I tell you the number of GPUs which run in parallel for that is basically, you can say a heavy container, a heavy machine with 8 containers is fine. Okay, but this we can easily create 2,000 to 4,000 videos with this. Let's say you want 10,000 videos, you want 50,000 videos, you want 1 lakh videos, because the personalization part is also there. Then on the fly, what we do is we multiply those servers with GPUs. Yeah.
Split.
Acha, you're talking about the split part. Avatar generally takes 30 seconds. You can say avatar is the most crucial part. You can say 30 seconds for, you can say, 20 to 25 seconds of video. So for 1 minute, it takes around 1 minute. So that is the split.
Yeah.
Okay, one last question we can take.
So you spoke about the importance of different segments being independent of each other, right, during the script segmentation phase. So considering the limited time of the video, let's say 1 minute or 2.5 minutes, so how do you ensure the important information of the script is retained in the video, and also ensuring that too much text is not getting overlaid on the video, like so that the user doesn't have to re-edit it during the editing phase multiple times? Like,
Yeah.
how do you balance it out so that you can still run the pipeline, like you said, in parallel fashion to save time?
Yes, actually that is the most crucial part, and we are still, like I said, work in progress. Because what happens is, if you have a script and if those scenes are not, generally scenes are dependent on each other, right, but the problem is not dependency of scenes. The problem is, which we are trying to solve, is the components which you generate for that particular scene, they have to be orthogonal to each other. You can say as orthogonal as possible in terms of information. We are not saying that visually एक चीज दूसरे से dependent नहीं है. That can happen. But the components which are important for any clip generation, if those components are dependent on your the next and the previous clip, then it becomes a challenge to run everything in parallel. And frankly, there is a challenge. So that's why we don't get accurate videos also sometimes. So that is still like a lot of work is going on in the script analysis part. How do you write the prompt? How do you write the prompt in such a way that, okay, you have the script, you convert that script into scenes with n number of components which you want. At the same time, they have to be interdependent. If you want any context, you can pass a context tag. एक potato agriculture की बात हो रही है, तो एक context है agriculture का, तो you can pass that agriculture का in different scenes, different clips also. That is what.
Got it. So based on your experience, right, in the entire pipeline, you answered a bit in the previous question as well. If you are generating 1,000 videos and you are doing compute optimization, right, where have you seen the most amount of compute being taken while running it? Which phase it is?
Lip sync.
Lip sync.
Lip sync takes a lot of time.
Lip sync and vision search, these two components. Like when vision search gets really intensive, it takes a lot of compute, because it involves looking inside the videos and the image itself, because हमारी use cases वैसे हैं.
Thanks a lot.
Thank you.
All right, so that was the session from Abhijit Singh and Pratik Khandelwal. Guys, please clap for them. Give them your encouragement for that knowledge sharing. Thank you, Pratik and Abhijit.
Thank you. Thank you, everyone.
Thank you.
Our next research explores deep learning models to predict the aging and sudden death behavior of lithium-ion batteries, which is critical for automotive energy systems. Our speaker Praveen Prasanth is a deputy manager at Renault Nissan, specializing in the modeling and simulation of automotive powertrain systems. His interests lie in the modeling and simulation of internal combustion engines and hybrid and electric powertrains with a strong focus on data analytics and AI. Please give it up for Praveen Prasanth.
Am I audible? Yeah. So how many of you are from automotive industry or some background? Automotive background? Wow. Any automotive enthusiast? Great. So I am Praveen. I am technical leader, system simulation. So what's simulation? Anyone can try a small definition? Okay. Yeah. So just mimicking the real world and trying to create some models. It could be digital, it could be physical, and it could be a combination of both as well sometimes. So Anas is one of my intern. He also contributed to this paper. Thanks to him. So I represent Renault Nissan Tech at Mlds. So most of my presentation, I would like to develop the context first because I know this is the odd man out presentation at Mlds because it's coming from core engineering background. So I'll try to develop the context and just convey how important and how mysterious the problem of battery aging is. And then we'll go into the modeling perspective, what kind of models are traditionally available, and regular machine learning steps like data set, modeling, and finally the best practice of sequence modeling, and we'll conclude. So what's battery? Battery is simply a source of energy, electrical energy. So all our portable devices today, be it your Bluetooth or your mobiles, or your, in fact today it's EV, they're all powered by batteries, so especially lithium-ion batteries today. So what happens in lithium-ion battery or any battery, you have high energy dense or high potential electrode A, from which the electron flows, which is basically the current which powers your devices. So A is nothing but anode and C is cathode, B is the separator between that. So electrical energy stored as a chemical form. That is battery, and it's also source of energy for all our devices. So people might be having some difficulty in conceiving the battery architecture. So I had put like this so that everyone can understand. So the bread slices forms the electrodes and some kind of cheese separator, and you have the electrolyte kind of wedge stuff. So battery is close to us, and literally the energy source. So it comes in all kind of shapes and sizes. We have been playing around with our toys from early childhood. So we have seen all different types of batteries. But what is the solution for EV? It's so important because the specification or the requirement is very huge, or it is also challenging to meet the requirements of the vehicle needs. Typically, over a lifetime, a car would travel 3 lakh kilometers. It should be durable for that long range. So, and today we are talking about long ranges. For example, we would buy a car only if it is having the range of 500 kilometers. So we need a solution which is which can pack high energy in a small space. So basically, lithium gives a solution because it's light in weight, and it can also hold a lot of energy in small space. For example, the comparison between lithium ion and typical lead acid battery, it would be like 5x. So same size, but you can pack 5x amount of energy into the lithium ion battery. So any observation here? What do you see? Yeah, batteries powering cars, but something else. So yeah, Chinese, China battery. But but today they are the leading powerhouse in terms of, I mean, in battery as well as EV. They are giving tough fight for all traditional companies like us. So it's a big challenge. So many companies across globe, they're all trying to do some partnership and develop some ecosystem where they can develop their own batteries. And batteries cause the major cost in a EV, like up to 40%. The cost just comes from the battery. So this is a known fact for all of you. The A had a couple of A winter, true, right? So only after the inception of the data availability, the compute power, and successful algorithms to train, we have successful models and the booming of deep learning. And today we've gone up to Gen AI. So EV is not very far from this. The evolution also goes like that. If you see, 1830 we had EV market. By 1910 we had 30K EVs on road. You know what happened in 1920 which drove the transformation from EV to ICE? Any guess? Not steam engine. Some kind of events happened which catalyzed the transformation. World War. Okay, so the batteries or electric vehicles which were before this, they were all non-rechargeable vehicles as well. So today we all talk about climate change. Emission norms are getting stringent every day. We are moving towards BS7 in few years. So in terms of emission, it's very difficult for OEM to meet the norms. So just a fact, 2024, we have globally sold, not just Renault, globally 17 million EVs were sold. So message is, winter is common for any kind of technology or any kind of revolution and evolution. So simple terminologies. So LFP is a kind of material which go as cathode. Typically anode is graphite, and voltage, capacity, cycles. We typically charge for a while, and then we discharge. As we use, it gets discharged. So this is one cycle: charge 100% and discharge. So this is one cycle. So typically, we all have experience. Initially, our mobiles, when you charge, it will hold for 2 days, sometimes 3 days. But after a year, it will hold only for probably a year and a half. And then slowly it drops very drastically. Finally, we will have to charge multiple times a day. So interesting thing is, or challenging part is, batteries age. So initially, let's say 100 is the initial capacity, and then over a period of charge cycles, it ages. So state of health is another important terminology which is needed. So it goes like this: the available energy relative to its original capacity, that is called state of health. Any idea why I have put some mark for 80%? Yeah, as you reach 80% SOH, state of health, what it means is my 20% of capacity has been lost. I cannot, let's say initially your capacity was 100 ampere hour, now only you can push 80. But this threshold, when we reach, it becomes not useful for the EV application. So what it happens is, it is used for the secondary life application, typically for grid usage. So the idea or the problem of battery degradation is complex. So I'll give you a small story. This is the story of 48 identical cells, identical in chemistry, form factor, manufacturing process, and experimental protocol. All were same. So if you look at the initial distribution, the capacity distribution will always have a small distribution, and you will have small tolerance because of the variability in manufacturing. We cannot have all the components as per spec in reality. So after aging, like 1600 cycles, if you look at the dispersion of capacity, if you look at the dispersion, the standard deviation is very high. So any idea what contributed to this? They were all identical, everything like same. So it's a research work done by one of the people. So they attribute this to the manufacturing variation which comes. The electrode separator or the collector. So all these are of the scale like microns, 10 microns, 25 microns. It's hard to keep as per design. Even a small variation, for example, electrolyte, just 1 ml extra, it can drastically change the trajectory of your aging behavior. On top of this, we have many variations specific to users, specific to kind of geographies. We have different temperature. Some drivers could be very aggressive, they'll abuse, and different state of charge when you charge and discharge, and then the kind of breaks you take, and then the cycle number as well as. So all these are increasing the complexity of this problem. So this problem is amplified in real world. So again, in an ideal case, you have lithium ions on the cathode. When you charge, it goes to the anode, and then when you discharge, lithium ion shuttles back to the cathode, and electron flows through the external circuit, which powers your car. This is ideal case, but ideal is ideal, right? So it doesn't happen in real world. That too, inside a battery, it's highly complex. You have many kind of degradation mechanisms happening in each constituent of the battery. For example, anode, cathode, separator. So, and these mechanisms or modes, they're all interconnected. So even a small variation at the beginning, it can lead to totally different trajectory. You can see what is the observable thing. So we can observe only the capacity fade, which is nothing but the state of health, reduction in capacity, and then power fade, loss of power. So the degradation is high dimensional problem, just like human ages or human body ages. It's a mystery. We cannot say this is how it degrades. So the key point, all batteries age. Aging is very uncertain. You cannot model it. Traditional modeling, for example, physics-based models, they're going to, for example, in the previous case, what I showed, if you use any physics-based model, all will overlap. They'll have same kind of trajectory for all the cells, but that's not the case. So how are we going to solve this mystery using machine learning? So the business problem, this is a life cycle of any vehicle development. It starts with the requirement. We do a lot of system level simulations, component level simulations, and then as the prototype comes, we do a lot of real world testing. We put the vehicle to abuse. For example, in battery case, we do electrical abuse, thermal abuse, and even mechanical abuse, and then check the durability of that. So this is the place where we are spending so much time and effort. Today, cost, effort, they are okay, but not time, because we want to squeeze the product development life cycle in less than 2 years. Because that is also one of the key factor, the time to market. So for an OEM like us, where we validate is at cell level. That is more practical. If it meets the cell level requirements, I'm sure that it's going to meet the module level and the pack level requirements. So the problem is today, the problem which I'm trying to solve is, let's say I have initial some X amount of cycle data, the aging characteristics. Can I forecast into the future? So, for example, in a regular case, we cycle it up to 1500 cycles. It takes almost 1.5 years, 100 cycles in 1 month, typically. So that's a kind of problem I'm trying to solve. So it'll get advantage in terms of cost, time, and effort. So time is what is exciting for our management. So I'll try to relate with the LLM. LLMs are advanced than the kind of sequence modeling which I'm showing. But to this crowd, I think this is the way I can introduce the sequence modeling. So in LLMs, what happens? We just try to predict the next word, right? So what happens if the input itself is numeric instead of text? So we do the prediction of the next element in the sequence. So sequence modeling is general term because I'm doing the calendar aging part. So let's keep it kind of flexible or generic. So time series, as per definition, a sequence of data points that occur in successive order. So that's what the definition of. But it's complex. You see, in LLM, it's just univariate. You just have one sequence coming in, and then you just predict one word or the next element. But in real world problems like us, the engineering problems we are trying to solve, we'll have multiple cases or multiple features. And typically, we will try to model or forecast many things into the future, not just one variable, but many other things. So it's becoming more and more complex. Now, let's get into the actual problem. So this is the data set. So this is an open source data set. I did not use our own, I mean, the Renault's data set because it's highly confidential. We don't want to put the confidential data into public forum like this. And this paper is also getting published. So we are not allowed to put all this confidential data. So we have taken a public data set. So it is LFP. So LFP is becoming more and more popular today, and it's going to be future for few years. But there are a lot of exploration. So what am I on? And don't know what's going to happen every week. Someone claims that we have identified the best chemistry for batteries. So it consists of 124 cells, 1.1 nominal capacity ampere hour, and then voltage is 3.3, and majorly it is coming from fast charging protocol. So when we do fast charging, we are trying to put more amount of energy or more amount of charge into the battery, but it is going to degrade your battery faster because it increases stress factor. For example, if you put more amount of charge current into your battery, it's going to degrade faster because of the thermal expansion. Internally, you will have some resistance to flow, so that increases the temperature of the battery. So this is a kind of accelerated aging when it comes to this kind of fast charging. So we need a model which will have some a temporal dependency. So which can model some temporal dependency, or which can have some memory of the past so that it predicts the future. So feed forward neural network, that's a vanilla architecture. But for this kind of models, RNNs, recurrent neural network, they have some amount of memory. They can remember. So your current output depends on the previous output as well. So this hidden state also has some characteristic or the elements of the previous history. So this is the inception of, I would say, the memory models. After that, we had a lot of inventions of LSTM, long short-term memory, GRU. GRU works for short-term memory, and many other advanced models like temporal CNN. So temporal CNN is nothing but CNN, convolutional neural network, adapted for time series. So instead of grasping the spatial pattern, can we grasp or can we make the model understand the temporal characteristics? Transformer, again used in LLM, deep Gaussian models. So those are all the models which we tried. So finally, we got some good amount of input features, and we wanted to predict next output. So this is a simple pipeline. We'll have the data, kind of time series data. You convert that to trainable format using the sliding window approach. Then you put all the models and see what is the output. And then using the predict and update loop, you kind of forecast into the future. So with the model what we have developed, we can forecast into any number of cycles. So forecasting, when you train, you will get wonderful results like this, the R square. But when you do the forecasting, it's going to be difficult because the error keeps on adding, and then it creates a problem because at every when you forecast and then you kind of predict and update, the error is going to accumulate, and finally this is what you reach. So Gartner Hype Cycle, it is to explain any technological evolution. So any product development, it will have similar phases. So this is where actually, I mean, when you fall into the trough of disillusionment, that is where your actual ML work starts. So then you do the hard lifting part. You really get into the problem and try to see what all is scope for improvement. So these are the list of best practice which we used for any kind of time series modeling. So best thing is like sequence decomposition, data augmentation, where you put some noise into your data and then train it so that the model learns or tries to capture the overall trend well. Then model complexity, we need to talk about that. So it also depends on the complexity of your, or the nature of your data. For a less complex data, if you put highly complex model, kind of transformer, or if you put LSTM with too many layers, it's going to give you a hard time. But finally, to be honest, a simple LSTM only worked in this case. So hyperparameter tuning, you can use some of the libraries like Keras Tuner. And all these early stopping, regularization, batch, these are all for making your model more and more generalized. So early stopping is important because overtraining also means overfitting. So when you have limited amount of data, you need to be careful that you are not overtraining. So after doing all these things, this is what we got. So we have initial input like 250 cycle data. From there, how can we forecast into the future up to 2000? This is for another cell up to 1500. So this is what we got. So we also have bounds of plus or minus 10. What we see on the y-axis is normalized capacity. It is not just the capacity. That is why you see the spread of 0 to 1. So the output, what we got was very, very satisfying, because looking at the complexity of the problem, I think this was good. But after this, we continued to work on this and developed the model. Today we have much better results. So I'll just talk about the future work. One is foundation models. So today the battery data is very limited. So what we kind of want to do is, we would like to develop a foundational model, putting all the data available, and then with a good quantum of data, we can have good foundational model from which you can do the kind of fine tuning for and adapt for any kind of chemistry and form factor. The other thing is physics informed. So we are trying to put some amount of physics into the modeling. So typically for ML work, we have the data loss. So how can we put this losses from the physics? For example, we have physics loss, or the governing equation. We convert that to a loss function and then put it for training. So that is one way where you can integrate physics into our models. So it becomes more trustable, and it becomes easy for me to convince my boss. So I know it's the last day, and it's already like weekend. So thanks for being here. Thanks for your attention.
Thank you, Praveen. Unfortunately, we won't be able to take questions. We have overshot. I know some of you have questions. Please feel free to get in touch with him outside the hall.
Yeah, I'll wait outside. We can talk.
Yeah.
Hope you had some takeaways today. Thank you. Five-seater. 5 duster, my KP today.
That was a nice plug. Thank you, Praveen. By the way, let me remind you, stand-up comic Kumar Varun will be with us at 5:30 p.m. in Audi 1. I'm sure none of us want to miss his set. But before the laughs, we have some intense learning to do. Let's see what we have next. Our next research paper introduces an LLM-based agentic framework aimed at reducing mean time to recovery during IT incidents. The conversational AI Ops incident management bot assists on-call personnel by recommending resources, referencing similar past incidents, and suggesting collaborators. Our speaker, Chandan Kumar Agrawal, is a principal engineer at Atlassian working with the AI Ops space. With over a decade of experience building and scaling some of the core enterprise-grade machine learning intensive products in various sectors like ride-hailing, advertising, and SaaS, he has demonstrated his expertise in large-scale backend systems, applied ML, and MLOps. Please welcome Chandan Kumar on the stage. I have a request also. Please let the speaker talk. Do not talk in between among yourselves. It creates disturbances for the speaker. And keep your phones on silent, please. All right.
Hey everyone. Audible to everyone? Cool. Okay, Chandan here. I'm working with Atlassian. I'll be sharing today our work on LLM-based agents and its application to one of the very niche areas, software incident management. Basically, how agents can help with the incident resolution, help assist in the incident resolution. Why this talk could be interesting is this paper is actually an adaptation of an actual enterprise agent which is live currently being offered by Atlassian as one of their AI ops offerings. So I hope we get to learn something as I go along. Okay, so I'll touch on what we are trying to solve, followed by exactly what we are building and how we are building. Then some quicks about building at an enterprise scale and actually making it an monetized product. And then we'll see on where we are going from there, right? So software incidents. I hope those small crowd, but most of you have been aware of what incidents are, right? If not as a developer, at least as an end user, your favorite e-commerce websites going down on big sale day, world airline disruption because of a bad security update to a OS, right? We all have seen that, right? As a company owner who builds softwares, it could be catastrophic for you in case you are running with a very lean team, and with every moment your website is down, you might be burning millions of dollars or maybe your complete funding, right? So where you operate and at what stack you operate, the incidents practically feels like your house is on fire, one without an insurance, to be honest, right? So what we are trying to do. Modern day software architectures are quite complex. You have your microservices running, thousands of microservices running. My stint at Meta, they were at 1.10,000 microservices running a monolithic code. So the complexity just keeps growing, right? And a small change in one part of your architecture could take down whole system, and it takes you hours to debug what exactly went wrong, right? Usually organizations quantify that using a matrix called MTTR that shows your incident robustness to your incident management process, right? Where we come in, we try to help you take down this your MTTR and sort of hopefully save some money around, right? Because with each minute your website is down, you are losing your customer revenue, but you're also incurring operational costs. Developers, support team, communication team, everyone is busy trying to sort of mitigate the incident, and your PR team, everyone is busy to get things out, right? So what we thought of when we designed the principles of our agent, when we thought that it could help with this IT operations or incident management for any medium-sized, large-sized SaaS companies, right? So we know that incident is a war room-like situation. For people who have run here, tier 0 services in web-based companies, you know that it's practically, there is a lot of heat in the room. People are trying to debug problems, and you cause more issues if you panic rather than actually solving the issues, right? So you need an assistant who is context aware, so they understand about your ecosystem, what you're currently trying to do, what you have done, right? It's everywhere, so it's integrated with your tools. It's there when you're going to look into the documentation. There is an assistant to help you. You are communicating on Slack. You are trying to resolve an incident. It's there with you. You are trying to resolve an incident on Zoom. It's there with you. It needs to be there real time, trying to help you out. Then only it actually helps, or it doesn't, right? And modular by design. Now, this is slightly a quirk for a software-based or a Atlassian-like SaaS company which design products for other companies. We'll find a very different kind of companies who have a slightly different ritual on the incident management, right? So we want this product to be able to be customized by our customers, right? You take the good parts which you like, customize it the way you want, what works for your incident management process, and use it, right? So these are some basic principles when we set out to design and sort of solve this problem, that what actually will make it useful to the company. I mean, we could club tens of things and say, wow, it works brilliantly, but if it doesn't solve an actual problem, it's not a solution, right? So we look into first the core of an agent, right? If you have attended some talks in last 3 days, this is something hopefully you already been knowing by now. So I'll not go too deep into this, but I'll just see what basically powers our agent. Note that this is not specific to just the IT-based incident management agent. This architecture could be practically applied to any agent you are going to design in today's world, right? Till today, I don't know if something comes tomorrow, right? So, yeah, okay. So this is basically a very high-level design of how the agent decision-making works at the core of an agent. The important thing to note there is a capability. To think of a capability as something like what your agent advertises it can do, right? So if you have a agent that sells that it can be a great writing assistant, right? So what are some of its capabilities? It should be able to summarize your work. It should be able to change the tone of your work, right? It should be able to write in, say, multiple languages, right? So all these are 3 different capabilities. So usually an agent by design should have multiple capabilities for it to be a comprehensive agent, right? Now we use a LangChain-like framework to sort of make a decision making on which capability should I trigger based on what you're doing and what is your query, right? Because again, as I mentioned, there are multiple capabilities there, and you are trying to sort of, especially in a war room-like situation, you are trying to sort of work with me to solve a problem, right? So we use LangChain-like framework. I'll come to why it's called LangChain-like and not LangChain itself. A framework to sort of solve this problem. So one of the sort of highlights of this framework is it allows that real-time decision-making based on user queries, the context which I just created, based on where you are, what you have done, your past conversation history, etc., and what those capabilities are defined. So how do I define my summarized capability there? Actually sort of helps my decision-making engine to say, okay, this guy is particularly looking for summarizing capability. Let's go and invoke that, right? And again, then the final step is response generator. It's basically after you have triggered the capability and the output you have got, how LLM sort of tailors that output based on what kind of user you are and what you are actually looking for to start with, right? And if agent is not clear with what you're trying to do, ask some follow-ups too, right? So this is how this works. Again, there will be a lot of literature already on this. Why I said it's like LangChain, because this is in-house developed proprietary work. We have not used any open source for this, primarily because it allowed us to move really fast and launch several agents in the market as an Atlassian. Also gives us a lot of control on how we wanted to design it. So as I said, we wanted our customers to customize agents at some point of time, right? And gives us a lot of control on explainability. So if you build a SaaS product, and it was frankly a new experience for me in last 10 months, a lot of your customers ask why this is happening and what's happening, right? And if you just take in some open source product, it's sometimes difficult to explain why some things are happening the way it's happening, right? And then we added some good sort of improvisations. For example, you could use the same agent framework to power a lot of your in-product experience where you don't need a conversational bot medium just to surface the same capabilities, right? So capabilities, right? So now I'll just focus on specific capabilities which we say our agents provide for you to actually help you in the incident resolution, right? We'll look into what those capabilities are and some glimpse of how it's being built, right? Again, as I said, this is a live product, so I might not go into all the details, but I've tried to put slides very much relatable to a lot of open source examples, whether it's models and stuff like that, so that you could follow what I'm trying to sort of say here, right? So one of the sort of like historically, 50 to 60% of incidents are repeated, right? Either they have a common root cause, common source of a problem, or a common human mistake, right? We have found it through multiple research, and that's why a lot of AI ops offerings have from times immemorial and offering of just similar incidents, right? What we did is we sort of exposed this data to our agent and let sort of mine it for you, right? So it sort of mines it for you, helps you with sort of setting how severe this incident could be. You've just started an incident, you've logged an incident. As a customer support engineer, you don't know what could be the impact. It helps you say that in past such incidents usually blow up. It actually costed company a lot of money. I think you should escalate, right? So saves you that time of actually making a decision, making should I escalate or not, right? Similarly, as a persona of an on-call, it could tell you that previously in a similar situation, you basically rolled back your system, right? Should you go back and see whether it's the same problem and roll back, right? So it makes you that gives you that suggestion on what to do, mining on your previous incident information. If I say what this information usually is, so think of an incident logged as a Jira ticket where you recorded what happened with the incident, comments were synced from your Slack, and then you kept your priority, severity, everything logged there. And then you also attached your postmortem report which explained what happened there, right? So that's how Atlassian has an offering an ITSM tool where users actually record these things, right? So that's where we mine to actually help you with your incident resolution, right? In terms of implementation, a very standard RAG-based implementation. So whatever you read of RAG, we just went ahead and applied. So we use standard bi-encoder models, slightly tuned on the tenant level data for indexing and retrieval, followed by re-ranking. And then agent interface to actually mine that data. So I sent 10 similar incidents with all hydrated data back to agent, and then use the agent decision engine to actually mine that information and surface what you are looking for, right? Another similar RAG-based sort of implementation on a slightly more comprehensive recommendation system is using your knowledge base articles to basically suggest you some solutions or some resolutions or sort of how to solve this problem, right? So again, it follows a very standard RAG-based thing where the agent comes in is basically, so on the right you will see is a standard recommendation system, right? You would have seen this architecture tons of times, right? You have your data index somewhere, you have a model complexity which keeps growing as the number of data points get reduced, and you finally get the result. Most of the recommendation system works like this, right? Whether it's enterprise search or whether it's an actual Google search, right? But where agent actually starts making sense is once a user query comes in, it has all of the context, what you have done till now, what conversations you had with agent right now, where you are, your incident details. It has already amended all that to create your queries, reconstruct your queries. Then it creates multiple queries, expands it's using standard query expansion techniques like synonym expansion, etc., and then sends it to this search system for search. Once it gets search results, it actually tries to mine, is something relevant to my user's query, and then finally generates a response back to the user. So how in real world it actually plays out is, now previously I've told you you have to roll back the system, right? But you are a new engineer, or maybe you have never done a hotfix back in 1 year of your tenure in this company, right? How should I roll back or how should I do hotfix? It exactly pinpoints this is a way the hotfix needs to be done. These are 5 steps which you need to follow. Do you want me to take that steps also, right? Depending on your integrations, it can also take that steps for you. Right? Another similar sort of high-level derivatives using the previous 2 example is, it can also suggest you first responders. I am either an SRE who's looking to major system and don't know which team to reach out, or again, a customer support engineer who don't know which team to reach out. It can actually suggest you few good responders based on your previous 2 information and complex mathematical models over that. We have not yet went ahead with the complex neural network models on this because we still are waiting for a product market fit on this particular thing. Right? Again, any good ML recommendation systems need some sort of feedback loop mechanism to understand how well we are doing with quality. Very standard metrics, as you see, all of the previous capabilities at least we discussed are standard ranking and recommendation system things. So we are also using a very standard ranking matrix to sort of understand the quality of our suggestions. I'll come at the end on why some of this basically doesn't sort of help so much, right? One thing is we also try to look at some agent-based metrics, right? Try to sort of innovate a bit with how can we sort of capture agent-based metrics and understand a bit more about agents, right? One of the pitfalls we have found with this particular agent is because assuming you don't mess up your systems every day, you will only interact with agent hopefully once in, and we don't want you to interact with the agent if you're not broken your system, right? So some of the regular retentions just on the whether they are coming back to the agent itself, etc. For example, the last one, right, might not be so great metrics for this particular kind of a problem. You don't have incidents every day. You don't have a regular occurrence. There is no periodic time series prediction on that. You could make that there will be an incident every month on your organization, right? Another interesting capability is, so currently whatever capabilities we discussed were more on our recommendation, ranking, and stuff like that, right? Another interesting application LLM has found is how can a Gen AI based problem statement or Gen AI based applications could actually help you, right? And postmortem reports are based on kind of organization and kind of practices you follow, are one of the basic rituals of an incident management process, right? In a lot of cases, if you do this right, the number which I mentioned, 55 to 60% of repeated incidents could highly reduce, right? So, and we realize that there is a lot of friction in creating these postmortem reports because usually no one wants to go and write this. You are, as soon as the incident gets resolved, you are put to some higher priority work and the postmortem report keeps lying. And 2 weeks later, when it's actually due, and you are sort of trying to club it at night before that, you are already lost on a lot of details which you remember about 2 weeks ago, right? So we try to sort of automate this for our customers, and it's one of the highly used sort of application, as you could understand, because it's in the right intersection of that automation and AI, and actually solves one of the very much used sort of a feature, right? So what does this PIR generation do? It helps you make sense of all the things you did. So because I was everywhere as an agent, I could actually make sense of what you did when you did, right? So this is where the postmortem, your agent is able to track your events and sort of create a chronological order of what happened, how it happened, and what actions you took, and maybe even suggest what could you have done as a resolution steps, right? This you will find in papers. I'll not touch because of lack of time. But basically, we have put together a very high-level diagram on how, if you want, you could implement something like this, right? Again, some important points here. We use highly 1P and 3P data, so where you're conversing, where you're using Zoom, Slack to your incident management, we use that to sort of generate this. We have to really tune prompts using all of state-of-the-art techniques like placeholder prompting, role prompting, etc., to make this very much customized for different tenants. Another interesting application of LLM you'll see here is an LLM as a judge, right? This is very interesting because, again, this kind of application, you can't use standard RIC6 metrics to measure their efficiency. So we have tuned LLM as a judge on a human-graded exercises and then use it at scale for our production systems, right? So quickly onto the challenges, right? So we have seen slightly different kinds of capabilities with increasing complexity, right? And again, as I said, this is live product offered by Atlassian. So what are the challenges we sort of actually faced besides the standard system challenges, right? So the most important is how you can be still privacy compliant, right? With LLM, it's very easy to breach the privacy. Just send one thing to an LLM model sitting outside and you just breach that contract, right? So you have to be very careful on kind of solutions you design and how it caters to all kind of privacy contacts you have with your customers, right? Another interesting thing is, as I mentioned, heterogeneous nature of our tenants. So each solution needs to be customized at some sense for a tenant. You can't share models, you can't share data, right? Accuracy, again, in enterprise, unlike a user B2C business, you don't get a lot of quick feedbacks. Again, in this case, you will be having for each tenant, maybe few incidents in a month, right? So there is a lot of delayed feedback for you to actually act on your quality, right? So these are some of the challenges we faced when we ship agents as an enterprise software, and we are continuously sort of looking into this, right? So what we have sort of seen, we have seen, and actually all the terms you must have heard in last 3 days and even last 2.5 years, how it came together to actually ship an enterprise-ready solution, which actually customers are finding useful. We have a prediction that some of our customers are seeing already an 8% reduction in the MTTR just because agent is everywhere and helping them with less context switch, helping with a lot of this task which they anyway did during an incident resolution, right? And as I said, we are still sort of quite early into this, so we are tackling all of the LLM challenges around hallucination, as well as one challenges we mentioned around about improving the quality, where we are struggling to sort of get feedbacks quickly, or we can't share data, so we have to tenant-based models, etc. Right? So a long journey ahead, but I hope if I come next time here, there's something different from what I have here. Okay, thank you. Yes.
A bit of an off-topic question, but the question is, how do you kind of take care of the timelines around the AI projects? Given the fact that it's probabilistic, you really don't know when you're going to crack it to a point where the accuracy is very high, latency is very low. So how do you kind of set those expectations with the leadership teams?
Got it. So again, not an official spokesperson of
Yeah,
Atlassian.
yeah, yeah. Nothing's
and I've been
official
only
in
with
anything we
Atlassian
talk.
for last 10 months, so again, take it with grain of salt. But at least for these projects, Atlassian is currently operating on an sort of like an something on steroid, right? So we are very much sort of like, we know we might miss this bus, so there is a lot of sort of push to get this right? Usually, Atlassian used to put some of these things on the public roadmap, right? So once you put in public roadmap, it's an official commitment, right?
Right.
So usually the things we try to put on public roadmap is something we already know is in the beta phase, already released to tenants, right? So some of the products you're seeing now started at least a year ago.
Got it.
Yeah, I have a question here. Excuse me. Yeah, here.
Yes.
So you mentioned about the feedback. You just touched about it, but didn't explain. So I thought I'll ask you. So when you produce some results, right, they may have a lot of errors, right, and you need some feedback to be given. So question is, how do you take the feedback? What you might explore different strategies, what you find most effective, and also when the feedback comes, how are you using it to produce a better result when the similar queries or similar incident happens?
Okay, so I can't share much on this again because it's a ready-to-use product. But I'll say is one of the interesting application of this is, so other systems you're mostly operating on your standard recommendation systems, right? So we believe that if you get that right, bearing hallucination, you will be on a quite close quality, right? The interesting part comes in something like AI generated PIR, where you're generating a very critical data on a where you're generating a very critical report on a very critical data, right? So that's where we are still improvising. We have tried to use few LLM as a judge through tried different models, tried different techniques of human plus machine to grade them, right? And then bake them in, right? But again, you might find something more in the paper, right? But that's about what I can share at this point.
Yeah, I have a question. Yeah.
Yep.
Okay. So for the cold start issue, do you have any approaches as of now? Any learning methods?
So for cold start issues, we are not offering certain features for now, right? So for example, something like PIR doesn't need a lot of data, right? So we offer you that. That's why the customization part comes in, where you could just enable an agent with just one feature. And we hope that over the time, as you have more incidents, so 3 months, 6 months, you will be able to solve a lot of this. Also, we have in pipeline bunch of features which doesn't depend so much. It's a more Gen AI kind of features, so that makes this whole buffet good. By the way, I've only discussed the 4 capabilities, but to make this agent work, there are tons of other simple capabilities like NLP to search and stuff like that, which makes this thing work, which is also quite useful in an enterprise scenario.
So then I have, you mentioned about hot fixing using agents and identifying the past reports, preparing automated report generations, and also, see, all things are revolving around incidents, like whatever happened and all that. So do you have some kind of idea about the root cause analysis of those events? Because events are coming from thousands of sources and multiple events might be correlated, right? So agents can figure out the root cause of that event, right?
Possibly. I can't comment more than that on that right, for now.
Sorry?
I can't comment more than that for now, right? On the root cause analysis and what we are doing there. But yeah, I agree with your point that we need to have, it would be great to have a root cause analysis somewhere.
Because RAG won't work, CAG won't work here, because that's everything is coming as real time. Agents should work. So just want to know more insights. Maybe we can take
I relate with your problem, but I can't say what we are doing with it, right? So.
Oh, really? Okay.
Okay, thank you, Chandan. Thank you so much. Please give him a big round of applause, people. Moving on, our next research work introduces an autonomous large multimodal-based agent for automating software and web operations using enterprise knowledge. The agent performs repetitive web tasks, automates decision-making, and enhances precision through retrieval augmentation generation. Our speaker, Mlds Audi, is a seasoned professional with a strong academic foundation. With 14 years of industry experience, including 7 years in the data science domain, he currently serves as the General Manager Data Scientist at Michelin India Private Limited, where he leads applied AI research for industrial applications. Please welcome Gaurav Adke on the stage.
Thank you. Hello? It's audible, right? Thanks. Yeah, okay. So, hello all, I'm Gaurav Adke. I'm here with my colleague Varun, and we have another author who is not here, Ameya. So, we'll be discussing on vision-powered RAG agents for organizational software and web operations. Yeah. So, basically, we'll start with the introduction, why we went into web automation, then what are the challenges we face into this task, the contributions, the agentic workflow, how we build and how we build the complete architecture, its components, the results, and finally the remarks. So initially, like why we begin this task, like especially into the organizational context, we need to do lots of day-to-day tasks in web operations, considering like applying the leaves or filling maybe agile tickets or something similar. So now what happens is for that, as an employee, we need to train them and we need to follow multiple documents from them. And then these are basically very monotonous and routine tasks which needs to be done on day-to-day basis. So it actually consumes a lot of time of employees. So first objective was to improve the efficiency into these routine operations. Then most of these operations are well documented in almost every organization. So we can use this documented knowledge to automate the process. And generally, historically, this kind of operations were carried out using RPA, robotic process automations. But now those are very static and hard-coded. So we wanted to make it a little more dynamic so that we can handle all these portals which are getting updated periodically. And then also the basically user can just give the query in natural language and it will handle that as well. And of course, reduce or eliminate the trainings from that one. So with this as a motivation, our objective was to develop the autonomous agent, so which will understand the user query in a natural language, and then it will execute the task in both web and software automations. So here for the paper presentation purpose, we are showing the web automation as application. So now the challenges is like, these web pages are especially designed for human as a user, all the graphics, all the context and everything. So whenever we want to put it for the agent to make it work, so first of all, it has to understand the user query and then what would be the probable output from that one. Then understand the entire complex web structure. So nowadays, because of this multiple graphical contents and long web pages, it is getting more and more complex to understand the entire web structure from an autonomous point of view. And then after understanding everything, agent has to generate the plan to carry out the desired task. For example, I'm saying it to say apply leave from this date to that date with say casual leave. So now it has to first understand the entire web portal. Then it has to go to those, go to the next page, then again understand the next page entire web structure. And there could be some pop-ups and then drop-downs and everything it needs to fill. Then complex navigation as well, because if sometimes the pop-up comes or the cookie approvals or even the language settings can be different, which needs to be changed. So this basically comes as a pop-up and which could be slightly difficult to handle in autonomous way. Obviously, these are very easy as a human, but for the agents, it could be difficult. And since they rely on underlying LLM models, those are trained on public open data sets. And especially for the agents which we are developing for the internal web pages, that knowledge is not available for the LLM agent. So we need to integrate our own knowledge into the agent and then utilize it for the application. So this is one, so generally in the literature like Web Voyager or Agenty or Web GPT. So to understand the web page structure, they generally follow two approaches, the HTML parsing, which can be noisy because the HTMLs can be very long, and to understand the entire HTML through parsing can be error prone, or you may not even extract all the clickable elements from the parsing operation. The next thing is obviously screenshots, and screenshot generally in literature, what they have done is, on the screenshot, they have built object detection models to extract or to create a bounding box around the clickable elements. But this again could be noisy because the bounding box creation may not happen always on the clickable elements. It could be some text or some image which may not be on clickable. So this actually has all the challenges and what we understand how to conquer all this one. So accordingly, we have developed the pipeline, which we'll present in the next slides. So our main contribution is basically, first of all, integrating RAG so that we can you can utilize our all internal knowledge database and just scan through it and come up with the process. Then, since, as I said, like this HTML parsing is very noisy and it could be error prone, so we have developed a pipeline for XPath extraction, which extracts only clickable elements using the JavaScript. And now, instead of object detection bounding boxes, we create bounding boxes on these clickable elements where there is no CV involved. And these are very robust because it is now getting information from the HTML parsing through the clickable elements. And basically, all these bounding boxes we create as a set of marks prompting because it has a unique identifier. And wherever it is on the page, LLM can directly say that go and click on here, even if there are two similar or even the same name elements on the web page. And to reduce the hallucinations and increase the robustness of the operations, we have kept the possible actions for the LLM to be very limited. So for example, just scroll down, enter the text, go back, and like that. So this is the overall agentic workflow. So the user gives the query, which is the natural language. Then we have split our agent into two parts, the planning stage and the execution stage. So in the planning stage, basically, another thing is now because we have split this into two, we don't have to use large vision models always for all the steps. We can even rely on small language models, and then execution stage can rely on the vision models, which could be little costlier than that one. Then the execution stage, we actually have the observation space, which we'll discuss what is observation space, action space, and then how are we integrating multimodal vision models on that one. So we have kept the analogy slightly similar to the reinforcement learning so that it can have easy way to understand what we are actually doing. So the agentic flow detailed, I'll just introduce on that one and then I'll hand over it to Varun. So as I said, the user instruction comes as a natural language, which is given to the planning stage. Planning stage is a language model, text-based model, and it also has the RAG integrated on the internal documentations and the LLM knowledge itself. So that from that, it basically generates the plan, like to carry out this task, what could be the number of steps to be followed, kind of following a tutorial to complete that task. Then it gives this task to the execution loop. So, and yeah, so basically to carry out all the stuff, we are using the Selenium so that it operates in the background to operate the web operations. So the first task is basically to extract all the XPaths using the JavaScript tool, and it extracts only for the clickable elements. And then all these bounding boxes and the IDs, we just create these bounding boxes on the images of a snapshot. And accordingly, we also create this data frame where the ID and corresponding XPath is mapped so that it can be referred during the loop anytime it wants. This is the observation space, is basically the HTML parsing or the ID what we have created, and the snapshot with all the bounding boxes which we have just got it. And this bounding box creation and the XPath extraction, it happens for all the pages. If you go to the next page, it will just remove all the bounding boxes. It will remove the table. It can store it in the memory, but for that task, it will remove the table and create a new one for the next web page. So this information is basically always the latest and updated one. So like I said, the action space is very limited, just like scroll up, down, enter text, and like that. And we basically send the snapshot with the bounding boxes mounted on those to the large language model. And accordingly, the task comes and then it just gives you the ID and the set of action to be performed. So for example, click on ID number 21. And then for that ID number 21, we again refer back to our data frame. We extract that XPath, and that is given to the Selenium to carry out the task on that one. This basically loops continues. We also added the reasoning and reflection in that one, so that it doesn't just keeps on running for a long time. If it finds that it's not going anywhere or it just not working well, it just stops and just tells the user that the action is not completed properly. And at the end, when it gets the end signal, it just stops and whatever is the output is shown to the user, like applied leave or maybe filling up some task in that one. Okay, I'll call Varun for explaining the next components of this pipeline.
Hello. My name is Varun, and I'm going to explain you the methodology about the knowledge hub. So basically, we took the documentations of all the internal web pages that are present and fed it to the RAG and extracted out the steps that are present to maybe apply a leave or fill in a frequent feedback and all the steps that like converting the um, making a LLM reason about the steps and everything, and we have created a normal text file about it. After that, the bigger issue was clicking on the right element, because most of the things, the complications what I was facing while working on that was there were certain things that were as an image component or something else on the web pages, but while going deep inside the HTML pages, that were represented as a different terms inside. So I could not just send the image to LLMs and tell them to generate a Selenium code to click this or that. There was a lot of times that I was facing issues. So this was my pipeline to get the XPaths, because XPaths are kind of addresses where you can find what element is located, and it is always correct. It will never go wrong. So what I did was I set out the bounding boxes, as Gaurav explained, that every clickable element has a bounding box with a unique ID around them, and we used to send that screenshots with the reasoning, with the planning stage to the large multimodal to give the next step and the reason why it is choosing that action and performing that action. So if you can yeah, so these are the XPaths and the IDs that are over here with the bounding boxes around them and with IDs. So when I send this image to the LVM, it outputs me with the next step what I have to do with the action. So I have given the LVM of set of actions that we have, that is either click, enter a text, or scroll up or down, or go back. That are five action spaces that we have, and I've kept it limited because otherwise it was generating random Selenium code and it was most of the time hallucinating over there. So these are the action spaces that I have inside the agent that it performs. And yes, so this is my prompt. Basically, I am entering my previous response from the LLM. What did it click? What did not click? I'm asking the LLM to fill the next response that I have. I have sent it with the action space. If there's some input that I need to take from the user regarding some entries, I have prompted the LLM to write me a Python code about it and create a UI so the user can enter the data over there, and no data that user is entering goes back to the LLM, as I get the text and it directly goes to the Selenium API to enter. It never goes to the LLM if it is a password or anything. It never goes to the LLM. And also I have the task over here and the planning steps that we generated in the starting appended in this prompt. And the next prompt over here is, once we have created a step, the action has been taken, I take that observation back again and I keep my previous three observations and I give it back for reflection, asking the LLM for the step that it took, is it right, is it wrong, or if my task is finished. If it is wrong, can you please tell me which is the right step I should go back to, so that I don't waste my time going deeper into the HTML DOM tree where I'm not going to find my solution. There have been a lot of times while I was trying the open source frameworks, this was a bug where people were, where the codes were just running inside and we were not reaching a meaningful output after that. Yeah, this is a first demo that I tried was on a Google website to turn the dark mode off on in a different language. It was not English, so it did that. And there was another where I was applying leave, and it was able to apply leave on the workday. Now, what RAG was doing, so there's this point where I'm not using any hints right now from the internal data source that I have provided as a RAG. Over here, it went to a web page that was not associated to leaves. And while using the reflection prompt to ask LLM if it is leave or not, it gave me the output where I'm wrong, I'm going wrong into the DOM tree, it is wrong, I should go back 2 pages, because right now where we are going, we'll not find a leave application. And there's another example where I did that and we went to the leave. So one thing that I found, the on the state of the art right now, accuracy with all the operators. Operators, I don't know, but when the computer use came, computer use accuracy was 23% on the task what it was performing. And if you are going specifically for the web page operations, it was around 40%. Once I had introduced RAG with hints giving what the next step can be, how the processes are done, the accuracy increased by 20-30%, and my leave applications and frequent feedbacks, three main objectives that I was focusing, were going on smoothly without any error. Yeah, so 3-4 things that I feel I improved on with the open source frameworks that were present. By introducing the reflection, I stopped LLM going deep into the DOM tree and wasting a lot of tokens, because while I'm sending a prompt involves a lot of things inside, and there was a huge token cost that was involved. And secondly, I had kept the exploration in a HTML page till only 10 steps. If you are doing a task, a user task, that is something on a psychology level, that a task will not go down 10 steps and it will finish. So I have kept it on 10 steps, and if I get stuck on any error, I had given it only 3 tries to retry it again, check if it can be resolved by going back or not, and we were ending the task over there by giving the task could not be concluded. Otherwise, yeah, that's it. With the RAG, we increase the accuracy.
Yeah. So just to summarize, so we actually, our objective was to build a stable system, because just to avoid the hallucination and randomness which may come by by forcing LLM to generate the entire Selenium code. So that was our objective, to keep it as minimal reasoning possible from the LLM as possible, and just to keep all the possible errors away from the LLM. That's what we did. We integrate the XPath extraction into that one and set up marks bounding boxes, which actually increase the stability, so that pinpointing which element to be clicked. So that was the useful addition. Like Varun explained, the reasoning steps were added. The screenshot of the bounding boxes were helpful. The set optimals were purposefully kept very minimal so that LLM is restricted to choose it from them. And a reflection is added just to avoid any long iterations which we may encounter in the erroneous explorations. The main limitation what we observe currently is in the scrolling, and what I mean by scrolling is not on the main web page, but sometimes if the widget comes on the main web page, on that if there is a scrolling, I mean we were struggling at the beginning. So if it is without scrolling and just entering the data or clicking, it was working well. But if there is a scrolling on top of the main page, we were struggling. We actually are working on that one. Presence of the captchas, I mean, of course, for our internal web pages, we don't have to worry about the captcha because we may not encounter there. But if it is being used for the open web pages, this is a limitation. And of course, ethically, I mean, that again, another discussion to be carried out, whether shall we use AI to solve the captcha or not. Yeah, the next, like the previous talk, we actually can integrate these IT tickets, issues, and their resolution as a document for the LLM, so that it can use that information also to solve some of the tasks which is it given to. Yeah, thanks. That's all.
We can take 1 or 2 questions if you have any.
Question is regarding that you are kind of doing the Selenium work, right? That
yes.
Is it not a solved problem with the Vusion scripts, and one time somebody can record the script and then you can play a number of times?
Yeah, exactly. So that is more on the RPA side, robotic process automation. So what happens is that you can record the steps, so that becomes very static. So what happens is some of these web portals we actually observe every like 3 months, 6 months, or even 1 year. They keep on updating, and sometimes the leave application is only the example what we have shown here. But apart from that, many of the agile tickets, it could be variation in as per the user query which can be applied. So there actually this task is more useful.
Here also I see a lot of tight coupling, right? So you have object detections, you have boundary conditions. The moment I change my UI, things will go haywire, right?
Yeah, so the object detection is purposefully removed from this one. Whatever the bounding boxes are created, those are from the clickable elements and not from the computer vision object detection. So even if the UI changes, when we parse the HTML, we exactly get which are the clickable elements on the entire web page. And we create the bounding box on top of them with the unique ID. So that's how it knows where to click and which is the clickable element.
But the sequence of clicks would change.
That's fine. So that kind of information should be available in the documentation. From there, it will extract. So
RAG will work there?
Yeah, we actually have observed it works.
Thank you.
Maybe GPT 4. Mike?
I was trying to understand their workforce. One thing I understood that everything they have to give steps for it. They have to predefinedly tell that here is the X path or here is there. But the change what I noticed can be influential was while every HTML page has the HTML code, and I as a specific we were creating divisions around the clickable element. So it does not matter if you are giving the paths or not. It's on the LLM's reasoning capabilities that if it can identify, or if you have the documentations to carry out that next step is this, or LLM can identify the next step is this, then your workflow keeps on going on without even if the UI changes, it still keeps on going on because the logic of your workflow will never.
That is correct. That's a different thing that you have created because you are analyzing the page right at the moment, not like you have stored it somewhere unlike RPA. So you have passed that thing, but what I wanted to understand is on the commercial side, have you tried to map it to, okay, some other vendor costs this much for this much clicks on this, and this is how the computer runs for this much amount of time. Any sort of analysis that you would have done? Because obviously there is a huge cost for this picture tokens that you send, and you are sending some RAG related data also again and again for every interaction that happens.
Yes.
So obviously the metrics can be created around it. So I was just interested if you have already done so.
Yeah. So actually one addition on that one is, since we have kept this vision model and the language model separately, for the RAG, we are actually trying with one of the open source model mounted in our own system without any GPT uses for that one. And only for the vision, we would be relying for the GPT models.
Any research you have done on the vision model being open source and being locally deployed during this stage?
I actually tried that, but there's this paper set of marks prompting that actually told me that if you provide a semantic knowledge with the image, it gives you a better response on a relative angle. But while I tried the same set of marks prompting on the open source models, I could not get that output back again. So it was hard to get that same thing from the open source models compared to what GPT was.
Thank you.
All right. So that brings us to an end to this session. Thank you, Gaurav.
Thank you.
Thank you so much. And coming to our final paper now. This research presents a systematic approach to case deflection, enabling customers to resolve issues independently, reducing the need for support. The speaker wrapping up this year's MLDS is Tulsi Das Sharma. He is a data science analyst at Cisco Systems, specializing in data-driven solutions, data science, and generative AI. He holds an MSc from IIT Madras and participated in a joint master's program in Germany. Outside of work, Tulsi is a chess enthusiast, taekwondo competitor, and enjoys guitar, fitness, stock market analysis, also singing. Please welcome Tulsi on the stage.
Hello. Hello.
Clap, people. Please clap for him.
I'm audible. So good evening, everyone. Thank you so much for staying this late for the last presentation of MLDS 2025. So before I move ahead, I'll just give a short introduction about myself. My name is Tulsi. I have been in Cisco for the past 1.5 years, working as a data scientist. And my other team members who have contributed in this project are Nishant, Ashwin, and Sunil. So moving ahead, all about this project is how we can save the time of our consumers or the customers, right? So the best thing which you can do for our customers is save their time or impact on the customer experience. So that is the whole point about this project. So in a year, we have around 1 million plus cases, right? So in 1 million plus cases, around 25% of the cases are just on about how-to cases or some product-related queries. They are not that complex, so that we need our engineers to get involved in those cases, right? So for those particular cases, how do we create a intellectual capital or a documentation so that their stuffs can be resolved faster? That is about this project. So the reason behind around 70% of the customers, right, around 70% of the customers, they try to do self-service for their cases, but they fail to do so. Just 9% of them succeed. There is a huge gap from this 9% till this 70% that they that particular gap, they are not able to self-resolve their cases. So and why did this happen? This happens because of inefficient documentations or inefficient ICs, whatever we have. So before moving forward, I would like to define what does case deflection mean. Case deflection means the ability of the customer to self-resolve their case, right? So more the customers will self-resolve their case, our engineers won't be involved, for that particular case to move ahead, and the customer satisfaction will increase, and the recurring revenues and the annual revenues, everything will increase. So how we have integrated machine learning and generative AI in this case, that's what this whole project is all about. So as I said, I don't know how it went out of the box, but the one part of this project is diagnostic IC, and the second part of this project is bug IC prediction. The diagnostic IC part is the Gen AI based thing, and the second part, which is the bug IC, it is supervised machine learning. So how we have integrated both of them to create proper intellectual capitals so that their cases or their services will be immediately resolved. That's what we're going to talk about. So moving ahead, if we talk about diagnostic IC model, so the very first step in diag IC model we did is the clustering. We took as I said, we have 1 million plus cases in our system, and so every cases cannot be individually resolved, and we cannot just go and straightforwardly we can solve them. So first we did some unsupervised learning, and we created buckets for them so that we can tackle them individually. So first of all, we did clustering so that we can create buckets, and which will have from the case nodes, from the release nodes, or from the bugs, they will be served in a bucket so that we can tackle them individually. So this is one example of how the topics were identified. Let's say anyone iOS upgrade assistance, and this we have done it in the form of how frequently it is occurring, or what is the importance of that. Let's say these are the topics which were identified, and inside each topic there are an n number of case nodes or n number of release nodes which are identified, and documentations were done for these cases, which will go inside the LLM, which I will show you. And this particular thing I have masked out. This is the final output. I will show you in the later slides. Yeah, so this LLM is basically RAG based. So we tell to the LLM that apart from n number of vocabulary which you are trained, use the archives which we are creating. In the previous slide, as you saw, these are the topics, or these are the clusters of all the case nodes or all the bugs which we have earlier formed. And according to that, we give that as an input to the LLM, and we tell that no need to hallucinate for the results, or no need to go away. You just need to check our archives, what are the documentations which we did, and according to that, there will be a question given by the customer, and the output will be tailored according to that particular question. So that is all about how we do the retrieval augmented this RAG-based LLM for diagnostic IC. And finally, the output will be in the form of troubleshooting steps, or the final output in the troubleshooting steps, the customer basically in the how-to or product-related queries, there where we don't need any extra engineer to put upon. So this will be the final output, and I will. So when we talk about the complete framework, So as I said, first we're doing unsupervised learning. We're identifying the topics from different bugs. And in unsupervised learning, what is happening, we are creating from the case notes, from the release notes, we're doing topic analysis when bucketing them. And according to those, then we're going putting this inside the LLM as our, in the archives. And post that, we are creating the summarization, right? And in the summary, we are providing the troubleshooting steps or the proper introduction or the keywords, which is easier for the customers to self-resolve the case. Which so what happens is a particular engineer, like the time is saved for both the customers as well as our engineers, right? So this is the first part of the whole project. The second part where we have the bug IC thing. So this is nothing but a ML model. So when you see these documentations which are created, these documents are also are created by our own engineers, right? So we also went one step ahead by thinking, why only save the time of our customers? If we also save the time of our inbound engineers, so it will also increase the efficiency twice or thrice, right? So this machine learning model most probably does that. So what it does is, let's say I'm an engineer, and for me, I have the task, like in a day, I have a task, like I'm given 100 number of bugs, and I'm allowed to, I'm asked to do a segmentation that which, let's say 70 bugs, I'm allowed to do the digitization that 70 bugs will be digitized and 30 bugs will not be digitized. So what do I mean by digitized and not be digitized? The digitizable bugs are those bugs which can be basically, they are the how to or the product related queries which can be self-resolved by the customers, right? Then we will go back and put it inside the archive. Okay, but the non-digitizable bugs are those bugs which are complex. For sure, the consumers or the customers won't be able to resolve the complex cases, so there is no point in creating documentations and then creating troubleshooting steps. So earlier it was manual. The engineer was provided 100 bugs. He was asked to do, okay, finally he was doing manually, he was checking for all the bugs, and 70 bugs are digitized. He said it will be digitized and 30 won't be digitized. Now we have created a ML model for that, which straight away rejects those, it classifies or it predicts based on the historical data by taking the release notes, the case notes, the basically in the form of categorical and text variables. It says that which all bugs can be digitized and which cannot be digitized. So the undigitizable bugs, which are complex in cases where there is no point in making the documentations, are removed away straight away, and then it those 70 bugs which can be digitized are passed away to the engineers, right? So then the efficiency of engineer increases because earlier he had to do 100 bugs, let's say for an example, and now just 70. So this is where the ML model comes into the picture, right? So when you talk about the complete framework, this project is all about how we can integrate like the traditional ML along with Gen AI, right? So as I said, there will be bug data, which will be having the release notes, the case notes, and it will be going inside our ML model. And this blueprint which I showed you, this is not the only one blueprint. We have a lot of products, like 15 to 20 products which are in production right now, this particular model. So this is just one of the best performing models. So this is for the demonstration purpose. So the models are specific to the products, like whichever model is best suited for whichever product, that model has been used for that, right? So as I said, like the release notes and everything will be coming into the ML model. Then the ML model will be doing predicting which all bugs can be digitized. Then this digitizable bugs will be going to the engineers, and they will be manually checking. Basically, this part is the human in the loop. And finally, those from those digitizable bugs, it will be going inside the knowledge repository or the archives, which we will be storing inside the archives, which will be presented to the LLM, right, in the RAG, basically in the RAG format. So when a consumer will be asking some questions, so it will be taking on from this knowledge repository, and the answers will be completely tailor-made from the questions whatever the consumers have asked. So the biggest takeaway from this, which we found out, is like how seamlessly we can integrate the traditional ML methods or the clustering methods with the recent LLM method, so that the final output has to be achieved just like the customer satisfaction or the CSAT score has been improved. And basically in this the digitization efficiency has also improved, right? So when the customer satisfaction improves, the renewal rate, the you know everything gets optimized accordingly. So this was all about how we can use both ML and LLM together for the customer satisfaction and everything. So this is all about our projects. Thank you so much. Questions? Yeah.
So in the documents that you have passed to the RAG
LLM.
basically, are you only passing the prominence scores for the clustered documents, or I mean, what is it in those
Yeah,
documents?
so those documents, they take in all the let's say we have a specific after we cluster this, right? Yeah. So let's say there is one particular upgrade CPI from this version to this version. This particular cluster will have all the related documents regarding all the bugs or all the release notes, all the case notes related to this particular category, and they will be documented as a whole. So all the documentations means the troubleshooting steps regarding all the products which can, the subtext or the sub-products which goes inside this particular problem, the documentations like the troubleshooting steps, what is the solution for any particular problem, everything, every possible details goes inside this particular category inside the LLM.
Okay, like the historical resolutions for all those topics.
Correct. Yeah, that is one part. Yeah. Yeah, sure. Yeah.
Cisco device you have, like version upgrade or a firmware upgrade, there is an issues with it.
Yeah.
So before you give it to the RAG system, like how are you separating out that this is related to this version upgrade? Is there anything related to that product when a customer asks? Because when I open it, like I have this version upgrade, firmware is not working. So where are you capturing that?
So like when you put inside, like in this knowledge repository, whatever product you want, right? The documentations for all the information regarding that particular product, the troubleshooting steps from the historical data.
No, more like I'm saying, is there a pre-processing before you hook into the RAG system? That's what I'm asking.
No, not as of now. So as of now, what is happening is like in this digitizable bugs, first of all, we're seeing that whether that particular issue can go inside, like is it worth it to put a proper LLM for that or not? Else it goes inside unsuitable. See, if it is a complex query, right? For that, for sure, an engineer has to be involved, right? The whole point of this is to increase the deflection rate, so that we don't need to use our engineers to put their head inside the problem. The customer comes, they self-resolve the issue, and they goes away. So that's the whole point. So that's why the bugs which can be digitized, that means that we have the knowledge repository for that, in the history and the documentations, that only goes inside the model as of now. Yeah.
So if you see here, there is no everything is like grounded. Solution is whole grounded only, right? Or do you have like ungrounded solution also?
Yeah, like along with like as we're using Llama 2 for this, this knowledge repository makes it grounded, but along with that, it also has the access to the original model which it normally has, right? So it is a combination of like grounded as well as what knowledge it has from outside.
The follow-up question, like why do you need, like because every information is product related, is all your domain expertise, everything is like, why do you need that external, like why do you not ground the solution?
So that's what, like that is just a plus point for this. Even if we have it, it's not an issue. Like let's say we just have this, but something is out of the context, for example. So it's always better to have two instead of one. So that is the reason, like when we do the summarization steps and all, if something is missing from here, that can be fetched from the outer repository or something like that. For that reason, we have both of the things.
Yeah, I have a question. So
I want to know more about the kind of vector store that you are using. So and how frequent you are updating your knowledge base. So when you do that, you